day. As you can see on your right, NASA astronaut Christina Koch taking a video of NASA astronaut Victor Glover. We expect to have great views of the crew throughout the day, as well as, of course, the moon. We expect to surpass that Apollo distance record in 55 minutes and 50 seconds. We are now looking live at a camera mounted on one of the spacecraft's solar arrays, pointed to our lunar neighbor. We are currently just 14,200 miles away from the moon and 247,672 miles away from planet Earth.
Houston, integrity for AGA.
Ready to copy.
Carbon dioxide 2.3, oxygen, which has the alarm 26.3, 73.1 degrees, 10.3 psi. And one follow-on question. We understand milestone words will be directly following the conference. Will that take the place of the PAO event, or will the PAO event still take place per the timeline?
Good question, Christina. The milestone words that we exchange at the record distance at the end of the conference will take the place of the PAO timelined activity. So that'll be our moment to talk about this occasion, and after that there will be no more expected PAO words, and you can get straight into your flyby. Copy all AGA.
Okay, thank you. And final clarification, even though it's taking the place of it, it will all just be on OE1 with HHP camera, no additional video. Is that right?
Affirm.
Okay, thank you. Yep, some of us had already heard that. Sorry about the second question. We appreciate it. Talk to you soon.
No problem.
Those communications between NASA astronaut Christina Koch and Canadian Space Agency astronaut and today's Capcom, or capsule communicator, the one person here speaking with the crew right now, that is Jenny Gibbons. She is an Artemis II backup crew member here in Mission Control, Houston. We are now 4 days, 18 hours, and 30 minutes into the flight of Orion for Artemis II. The Artemis II crew inside Orion lifted off atop the Space Launch System rocket on Wednesday, April 1st from NASA's Kennedy Space Center in Florida. Those 4 crew members are the first to live and work inside the Orion spacecraft, which they have named Integrity, and have been busy conducting meticulously timelined events. It was a beautiful ascent from Kennedy Space Center. One of those early events was the proximity operations demonstration, during which NASA astronaut Victor Glover, the Artemis II pilot, manually flew Orion after having just detached from the interim cryogenic propulsion stage as if they intended to dock. This was practice for future Artemis missions, during which astronauts in Orion will dock with the lunar lander that will take them to the surface of the moon. About 24 hours after launch, 25 hours actually, Orion then conducted TLI, the translunar injection burn. This 5-minute, 50-second burn committed Orion to departing high Earth orbit and set us up for today's flyby. That translunar injection burn also served as the spacecraft's deorbit burn. It slingshots Orion around the moon and sends the crew on a free return trajectory, with splashdown approximately 7:07 p.m. Central on Friday, April 10th. Last night on Flight Day 5, the crew entered the lunar sphere of influence, the point at which the pull of the moon's gravity will become stronger than the pull of Earth's. We've also been getting some great views inside the cabin of the crew members living daily life, from working out to eating, taking photos, and making memories together. But they've also been taking some beautiful views of our home planet and of the moon, and we expect many, many more of those following today's activities. These live views back inside the cabin of Orion, but before we get into Flyby, let's take a minute to get reacquainted with our crew. Reid Wiseman is the Artemis II commander and a Baltimore native. He's been in space once before.
I think there was going to be some families heading into the viewing room today. If they end up showing up, could you just give us a heads up when they're there so we can just wave to them on the camera?
Absolutely.
And that was the voice of Reid Wiseman. He has been in space once before as a flight engineer.
If they don't come, you could just lie to us and tell us that they're there. That'd be great, thanks.
We'll keep that in mind, too.
And
I'm sure they'll be here.
Wiseman also has a great sense of humor. He was aboard the International Space Station from May through November 2014 as part of Expedition 41. This was a 165-day mission during which he and his crewmates completed more than 300 science experiments in areas like human physiology, medicine, science, earth science, and astrophysics. They set a milestone for station science by completing a record 82 research hours in a single week. He also served as chief of NASA's astronaut office from December 2020 to November 2022, and here on Earth he has 2 daughters. The Artemis II pilot is Victor Glover, selected as an astronaut in 2013, when at the time he was serving as a legislative fellow in the United States Senate. His first trip to space was in November 2020, when he launched as a pilot of NASA's SpaceX Crew 1 mission. That was the first operational mission of NASA's Commercial Crew program, which resumed launching American rockets from American soil to the International Space Station since the end of the shuttle program. Victor is a U.S. Navy captain and naval aviator who served as a test pilot, racking up more than 3,500 flight hours in more than 40 different aircraft. He also became the first person to pilot Orion the other day when we saw the Prox Ops demonstration shortly after launch. He and his wife have 4 children. Mission specialist Christina Koch is a native of Grand Rapids, Michigan. She was selected to the Astronaut Corps in 2013, the same class as Victor Glover. She served as flight engineer on the International Space Station from March 2019 to February 2020. During that time, Koch set a record for the longest single spaceflight by a woman with a total of 328 consecutive days in space. She also participated in the first ever all-female spacewalk with her friend and colleague.
España, cuando son la 1:11 de la tarde aquí en Florida, en Estados Unidos, en un día absolutamente histórico. Por primera vez en 53 años, 4 seres humanos van a sobrevolar la Luna. Lo vamos a ver. Bueno, vamos a ver mucha parte, o hay otra que no vamos a verla, y luego os voy a explicar el porqué. Y no solo eso, sino que van a hacer cosas que nadie ha hecho jamás en la historia de la humanidad. Hoy se van a romper récords que llevaban más de medio siglo intactos. Nuestros 4 protagonistas les conocéis ya bien: el comandante Reid Wiseman, el piloto de la misión Victor Glover, el primer afroamericano, persona negra, persona de color en ir a la Luna; Christina Koch, especialista de misión, primera mujer en ir a la Luna; y Jeremy Hansen, especialista de misión de la agencia canadiense, primer canadiense en ir a la Luna. Así que, bueno, hay muchas primeras cosas, y si la tripulación ya es histórica, bueno, pues van a hacer cosas, como os decía, históricas, porque hoy va a haber 6 hitos absolutamente increíbles, ¿no? El primero se va a superar el récord del Apolo 13, la nave Orión va a cruzar los 400.171 kilómetros de distancia a la Tierra, y ese número no es solamente arbitrario, sino que es el récord absoluto de distancia que un ser humano ha alcanzado jamás, estableciendo, bueno, pues como os digo, un nuevo récord, ¿no? ¿Y quién tenía ese récord antes? Pues lo tenía la tripulación del Apolo 13. Hablamos de 15 de abril de 1970, cuando su misión, abortada por aquellos problemas tan famosos que habéis visto en la película, pues les obligó a rodear la Luna sin aterrizar, ¿no? Y ese récord ha resistido todos estos años. Y bueno, pues hoy Wiseman, Glover, Koch y Hansen van a ser los humanos que más lejos han viajado en la historia de nuestra especie, y eso es increíble. Luego, sobre las 8:45 de la tarde vuestras, es decir, en 1 hora y media más o menos, va a arrancar lo que se llama la... ¿Se ven las cosas? Bueno, pues es que, amigos, el entorno es hostil, pero llevan 3 cámaras Nikon profesionales, llevan 2 D5 que son todavía con espejo, y una Z9 que están modificadas además por firmware para tomar imágenes como nunca lo ha hecho antes y sobrevivir todo el impacto, ¿no?, que tiene la radiación, que tiene el hielo. Pues van a llevar esas 3 cámaras, como os digo, y van a fotografiar y videografiar 30 objetivos biológicos seleccionados por todo el equipo científico de NASA, entre ellos la joya de la corona, que es la cuenca orientale. La cuenca orientale, que es un cráter de un impacto de casi, bueno, imaginaos el tamaño que tiene ese cráter, 1000 kilómetros de diámetro. Eso es más ancho que España de este a oeste. Y ese cráter está formado hace 3.800 millones de años. Tiene anillos concéntricos de montañas que son visibles, y lo que van a fotografiar son las zonas de esa, lo que llamamos la cara oculta, que, bueno, no es cara oculta, es la cara que no vemos. Pues ningún ojo humano las ha visto directamente, ¿no? Porque sí que es verdad que las misiones Apolo pues pasaron por ahí, pero en cómo daba ese momento la sombra del sol, pues no lo vieron. Y sobre las 12:44 de la madrugada vuestras, serán las 6:44 aquí en Florida, se va a producir lo que se llama pérdida de la señal, o blackout en inglés, ¿no? Y es que la Integrity, la Orión, va a desaparecer tras esa cara no visible de la Luna, y la masa lunar lo que va a hacer es bloquearla físicamente. Va a bloquear todas las comunicaciones con la Tierra, y vamos a tener 40 minutos de silencio absoluto. Eso va a ocurrir sobre las 12:44 vuestras. Esta es la primera tripulación que va a experimentar este aislamiento cósmico, esto de estar incomunicados 40 minutos, desde Apolo 17 en 1972, ¿no? Y lo más impactante de todo es que los 2 momentos cumbre de la misión van a ocurrir durante este blackout. O sea que Houston no va a saber, ni Houston ni nosotros, claro, si todo ha ido bien hasta que la señal vuelva. O sea que imagínate la tensión que va a existir en el centro de control, ¿no? Más récords. Bueno, este no es récord porque, como bien sabéis, hemos alunizado, que es la palabra exacta, en la Luna 6 veces, pero sí que vamos a aproximarnos en esta misión a una distancia de 6.500 kilómetros sobre esa cara no visible. y para entendernos es más o menos la distancia que hay entre París y Nueva York, ¿no? Pues desde las ventanas la Luna va a ocupar el tamaño más o menos, si extendéis el brazo y cogéis una pelota de baloncesto, pues es más o menos. Artemis II, esa misión lo va a ver como un balón de baloncesto más o menos de ese tamaño con el brazo extendido, ¿no? Así que eso es lo que ellos van a ver por la ventana. Apolo 17, como os decía, voló sobre la cara visible. Artemis II es la primera misión en sobrevolar a baja altitud la cara no visible, y esto nunca se había hecho, ¿no? O sea que están volando sobre paisajes, sobre montañas, sobre cráteres, sobre mares basálticos que ningún ser humano ha contemplado jamás con sus propios ojos, y lo van a poder fotografiar con esas cámaras, también con sus teléfonos, también con algunas GoPro que llevan por ahí. y bueno, pues una vez que ocurra ese blackout, se reanudará la señal, si todo va bien. Eso va a ser sobre la 1:25 de la mañana, hora peninsular en España. Orión va a emerger detrás de la Luna y van a suceder dos cosas a la vez. Una, que nos toca muy de cerca a los españoles, es que las antenas de Madrid, que son parte de la red del espacio profundo de la NASA, junto con Goldstone en California y junto con Canberra en Australia, pues esas antenas de Madrid van a recuperar el enlace. Y lo podéis ver en la página que he construido, que es artemis.orbitainfinita.com. Pues podéis clicar e incluso ver cuándo esas antenas están funcionando en tiempo real, ¿no? Así que fijaros qué orgullo nacional en este momento histórico que una de las antenas clave que va a recibir las primeras señales de la nave Orión una vez atraviesen la cara no visible de la Luna va a ser las antenas de Robledo de Chavela en Madrid. Así que enhorabuena a los premiados, como decían mis amigos de Goma Espuma. Y los astronautas van a ver por su ventana el Earthrise, que dicen aquí en inglés, ¿no? Que es que la Tierra saliendo por el horizonte lunar, un disco azul y blanco flotando sobre el gris muerto de la Luna, ¿no? Y este fenómeno que hipnotizó a la tripulación de Apolo 8 en 1968, pues ellos lo van a vivir de nuevo, ¿no? Así que imaginaos qué emoción. Y no solamente eso, sino que a las 2:30, de 2:30 a 3:32, hora peninsular en España, durante 57 minutos, la Luna se va a interponer entre Orión y el Sol. Y lo que va a ocasionar es como un eclipse solar, pero visto desde el espacio profundo, ¿no? Y estos son los 4 astronautas en el siglo XXI que van a presenciar un eclipse solar desde el espacio profundo, y los primeros en verlo tan cerca de un cuerpo eclipsante. O sea que imaginaos qué privilegio. Y hay mucha gente que me preguntaba en YouTube, en el otro directo, me decía, oye, ¿y esto cómo funciona? Bueno, pues a diferencia de un eclipse visto desde la Tierra, aquí no hay atmósfera. O sea, que imaginaros el contraste tan bestial que van a tener, ¿no? O sea, que eso significa que la corona solar se va a extender pues, casi como en plata, ¿no? Alrededor de un disco perfectamente negro. O sea, que será el cielo más oscuro que un ojo humano ha visto jamás. Que os tengo que decir que iré conectando de vez en cuando pueda, porque hoy tengo un día de locos. Pero os vamos a dejar con estas imágenes, y a medida que se aproximen estos momentos importantes, ya sabéis, en 1 hora y 40 minutos, a las 7:56, se va a superar ese récord del Apolo 13 de distancia, y a las 8:45 arranca la ventana, siempre hora peninsular, en España, arranca la ventana de observación lunar. Así que iré conectando dentro y fuera. Mi amigo Fernando Sierra está desde León a los mandos de todo esto, y de vez en cuando me irá pinchando, así que escucharéis una voz profunda desde Florida, que os va a ir contando cosas. Mientras tanto, os dejo con estas imágenes.
Around, the less of that they will see. So those are targets we will hear them describe early on in the flyby.
Fascinating. Well, and the crew has been training for years for this day, and so we're going to hear them make a lot of calls about what they are seeing on the moon, and they're going to use a lot of interesting terms that I myself need some brushing up on. So could you walk us through a few of the things that we'll hear them use to describe the moon, like albedo, exosphere, ejecta, just some of those major terms we expect to hear from the crew?
Yeah, of course. Albedo is basically a term of a reflectiveness of the surface. And so high albedo usually for the moon means bright areas, and low albedo means like darker areas. And so when you look into the night sky, you can see the high albedo areas are the white parts and the low albedo ones are the darker areas. Ejecta is when you have an impact and it ejects or throws out material that then ends up on the surface, and you can see that as sort of rays or ray systems. So you might hear them describe, oh, I can see for example, with its rays. It has an asymmetric rays coming out, and so we are excited to hear them describe that. You might hopefully hear stuff about color or color hues, and so if they can see any changes in those color hues from like white to gray to maybe brownish, we're excited to hear about that. Exosphere is the almost no existing atmosphere of the moon. It's barely there. But there is dust on the lunar surface that can get lofted up through electrostatic forces. And when the sun goes behind the moon, it can scatter forward on those dust particles and sort of like create a little glow on the horizon. And so we're really excited to see if the crew can actually see that.
This is so exciting. Thank you so much for walking through all of that with us. Julian Gross, Artemis Curation Lead, we really appreciate you joining us here today, and good luck to your team.
Thank you. I'm really excited to be here.
We are now MET 4 days, 18 hours, and 49 minutes into the flight of Orion. This view of the moon from the Orion spacecraft as we get closer and closer. We're live here in Artemis Mission Control at Johnson Space Center in Houston, Texas, just about 32 minutes away until the crew surpasses the record set by Apollo 13 as the farthest astronauts to ever leave Earth. This view coming from a camera mounted on the tip of one of Orion's 4 solar arrays. Each array has a camera on its tip, and so we anticipate getting views throughout the lunar flyby. Of course, except during the point of loss of signal when the spacecraft flies behind the moon. Inside the cabin, the crew are configuring the inside of Orion for today's flyby, making sure they have everything just where they want it to help them take the pictures that they are aiming for the science team here on the ground. Coming up in just a few minutes, we will have a pre-lunar flyby conference. During that Lunar Flyby Science Crew Conference, our science officer here on console, Kelsey Young, will be speaking directly with the crew members about their targets, about their goals for today, what they expect to see, and what we are hoping to hear from them. We have a lot of milestones coming up today, so make sure you don't miss them. The first coming up, again, at 1:56 p.m. Eastern Time, the crew will pass the distance from Earth record set by Apollo 13 in 1970. At 2:45 p.m., lunar flyby officially begins. The crew will have that time on their schedules to begin photographing and providing audio recordings of what they are seeing on the moon. At 7:02 p.m., Orion will make its closest approach to the moon, approximately 4,070 miles away. Of course, all of these numbers are going to have to be confirmed following the flyby. These are estimates, and we are working with orbital mechanics. At 7:07 p.m., Orion reaches its maximum distance from Earth, approximately 252,760 miles away from us all. At 8:35 p.m., the spacecraft will enter a solar eclipse. The crew will become the first to see a solar eclipse from the moon. Ahead of the official beginning of flyby today, Kelsey Young, Artemis Science Flight Operations Lead, will be conducting a pre-lunar flyby crew conference. She will give information on camera setup, remind the crew of their intended targets, answer questions from the astronauts, and more. Young will help the crew set their targeting timeline, which counts down the time they have to image each target and what they'll be capturing next. She'll also remind them that the ground team will be calling for science sit reps, also known as situation reports. Those are essentially call-downs to report what they've been observing. They'll continue to do this even through their LOS, their loss of signal, as those communications will come down later on after they reconnect with us on Earth. This view in the cabin, you can see the crew members are already using their cameras, getting set up, and they have dimmed the cabin lights to allow them better visibility outside of the windows and fewer reflections. Now, 28 minutes until they become the humans to travel farthest from our planet.
Houston Integrity, we are ready for the conference on your call.
Houston is ready for the conference, passing you over to Science.
Good morning, crew. This is Science. We couldn't be more excited for a full day of lunar and planetary observations today, the first one in over 54 years. How do you hear me?
We hear you loud and clear, and Kelsey, you just got to know you're pulling us away from the moon right now, so let's go.
Message received. I will keep it tight here. I did just want to start with a thank you on behalf of the Lunar Science team and the entire lunar and planetary science community, of which you are absolutely a part, for what you've already done in this mission and what you're going to do today to inspire the next generation of scientists. I have to say Moonjoy is the new term that's already become our team's new motto, so thanks for that. In this conference, we'll cover hardware and config reminders, and then I'll just briefly, as you said, cover today's science plan. I'm assuming you already have your LTPs up. Confirm that, and I'll jump quickly into the cabin config reminders.
Okay, we we have the LTP up just to give you a sit rep on board. You've got Reid and Christina on one PCD, and Ike has his own, and Jeremy has his own.
Copy that. That was going to be one of my questions for you, and I'll ask a question back. Is that the config that you and Christina plan to carry throughout the day for PCD use?
Negative, Kelsey. Our plan for PCD use is we have run the power cables to Windows 2 and 3, and we are going to leave one PCD. The yellow PCD will be in window 2, and the green PCD will be in window 3, and we will do that the whole day, and then the red PCD will be a rover.
Understood. Super helpful. Recommend when you guys switch in and out of PCDs to add your initials to your OneNote annotations, just so we can keep track of whose is who. And then given that you have 3 PCDs instead of 4, for the data transfer at the end of the day, recommend making a new subdirectory entitled For Science for your own photos, or with your initials, that we can keep track of which pictures came from which flashcards.
This view.
So, Kelsey, I just want to here's what we're doing. We have community cards in all cameras on board, and then when each astronaut approaches their camera, the intent is they will put their card into that camera for photos and then put the community card back in at the end of the session. But just know it is harder to manage cards than we thought, and we don't want to miss science, so it might end up a bit more disorganized.
Understood. Thanks for that essay. Just read the flashcard numbers down when you get a chance, and we'll follow your lead on the best thing to do operationally during the flyby. With that, I'll move on to windows. So the window characterization DFTO you guys did a few days ago confirmed that window 2 is ideal for imaging, so no change to config of photographer in window 2, observer in window 3, and science sit reps in window 1. Coming up on a handover. Be back with you shortly.
Hang on, Kelsey. The way we have it configured, tell us if this is going to be wrong. Window 2 is the long lens with a shroud. Window.
As you heard, science officer called to the crew. We are now in a handover time period. We will regain communications with the crew very shortly. These are tracked, and we are currently on the Deep Space Network. This is the first time humans have used the Deep Space Network in over 50 years, given that we currently use the tracking data relay satellite systems in the for the International Space Station. This view from Artemis Mission Control on the right is Kelsey Young. That's who you hear speaking with the crew. Young is the Artemis Science Flight Operations Lead, and we also look forward to speaking with her here today. Again, we are just about 22 minutes until we reach the Apollo record. We are in a handover of satellites with the crew aboard Orion.
The T-shirt shroud for the Z9 and solar, and then window 3 will be for visual observations, and window 4 is for floater.
And thanks, Integrity, for that. Reid, we had a handover during that time, so I'm going to have to ask you to give that read back on window orientation for the crew again.
Okay, we are happy to change it, but the way we have it configured right now is window 1 has a T-shirt shroud for the Z9 for solar. Window 2 has the shroud for the long lens for both lunar and solar. Window 3 is for visual observations. Window 4 is for floater. And then the docking hatch window has had a great view, so we've done a lot of mapping through that as well.
All right, copy all, Reid. A note just on the window 1 T-shirt shroud that you can remove that for the lunar observation block if you want to, if you want that extra view for another floater, but defer to you guys on that. You are go to use the full 400 millimeter zoom on the long lens, but where possible, try to keep the end of the lens flush with the window to prevent imaging through the multiple window panes at an angle. And if you have to take an image at an angle, recommend you limit the max focal length to 200 millimeters or simply acquire the images at multiple focal lengths. Last imaging update as a result of the DFTO is that if you can take the images out of the left side of window 2 where possible, that is the best half the window. Understand that might not be possible with the shroud. Any other imaging questions from you?
Y te cuelgo aquí, Fer. Pues aquí seguimos y además escuchando lo que es la retransmisión de NASA. Les estaban ahora mismo comentando que tienen que utilizar un cierto tipo de lente. Les estaban diciendo que si iban a utilizar la lente de 400 milímetros, que es un buen zoom, pues que intentasen pegarlo lo más posible a la ventana, para que hubiera pocos reflejos, ¿no? Y que si tenían que tomar la foto con ángulo, que lo hiciesen sin utilizar toda la lente, los 400 milímetros, sino que bajasen hasta los 250. Y eso es para evitar esos reflejos. Cuando habéis estado en un avión, pues imaginad que queréis hacer una foto y a veces se cuela el reflejo del cristal del avión, ¿no? Pues es para evitar eso. Y decíos que van a llevar, bueno, pues cámaras, creo que lo he comentado antes, van a llevar cámaras Nikon, cámaras modificadas, van a llevar 2 de 5, que son cámaras un poco más antiguas, de unos 20 megapíxeles, y van a llevar una cámara Z9, que es una cámara que tiene 46 megapíxeles, ya sin espejo. Llevan varios tipos de teleobjetivos y van a tener que tomar un montón de fotos porque tienen 30 objetivos geológicos seleccionados por un equipo científico. Como os comentaba antes, la joya de la corona es la cuenca orientale, ese cráter de más de 1 kilómetro de diámetro, pero hay muchos otros, ¿no? Y es que la Luna, como sabéis, como podemos ver desde aquí, pues ha sufrido y sufre diferentes impactos de meteoritos, ¿no? Os decía que el mare oriental es la joya de la corona, que es 1000 kilómetros de diámetro. Tiene una antigüedad de 3.800 millones de años. Imaginaos cuando un asteroide gigante, durante lo que se llamó el bombardeo intenso tardío, pues impactó contra la Luna y hizo ese pedazo de cráter. Y esto es un ejemplo casi del libro de texto de una cuenca de impacto multianillo, ¿no? Que se llama en ciencia. Y es que cuando ese proyectil golpeó la corteza lunar, pues reaccionó como un estanque al caer en una piedra, ¿no? Y es que formó 3 anillos concéntricos de montañas que aún son visibles y que ellos van a poder ver. Estamos hablando de un anillo exterior, el Montes Cordillera, luego tienes el Montes Rook y el exterior y el Montes Rook interior, ¿no? O sea que esto es prácticamente imposible de fotografiar bien desde la Tierra porque nos queda de perfil en el borde de la Luna, ¿no? Y Artemis II lo va a ver de frente con luz rasante, que es la peor luz para la vista, pero la mejor para la ciencia, ¿no? que son sombras alargadas que revelan pues ese relieve como un mapa, como si fuera en 3D. Y para la ciencia esto es muy importante porque es que este cráter, esta cuenca oriental, ese mare oriental, es el mejor conservado del sistema solar. Y dices, oye, ¿por qué nos importa esto? Bueno, pues que es que entender su estructura nos dice cómo se forman esos cráteres gigantes en cualquier planeta rocoso, incluida la Tierra primitiva, ¿no? Cuando nos cayó aquel meteorito, entre el que extinguió los dinosaurios, ¿no? Como teoría. Oye, más cosas que van a ver. Como os decía, 30 objetivos. Os voy a ir contando cosas poco a poco. Voy entrando y saliendo del directo cuando pueda. La cuenca Aitken Polo Sur, ¿no? Lo que se llama la SPA Basin. Si los 30 objetivos estuvieran jerarquizados por importancia, este probablemente sería, pues no sé, antes he dicho, ahora me contradigo a mí mismo, ¿no? Pero este posiblemente sería el 1, fíjate. Lo tendría que discutir con algún científico y ver a cuál colocaría en el 1 o en el 2. Pero es que esta cuenca, la Aitken Polo Sur, es la cuenca de impacto más grande, más antigua, más profunda del sistema solar conocido. Estamos hablando, para que os hagáis una idea, de 2.500 kilómetros de diámetro y 13 kilómetros de profundidad. O sea, imaginad lo que ocupa. Y es que, cuando digo lo que ocupa, estoy haciendo así cálculos rápidos con el teléfono, pues casi la mitad sur de la cara no visible, ¿no? Sí, casi la mitad, fíjate. Esto está formado hace 4.200, los científicos estiman entre 4.200 y 4.300 millones de años, cuando el sistema solar apenas empezaba a organizarse. Y la hipótesis más apasionante, que esto es increíble, que es que el impacto fue tan brutal que pudo haber excavado material del manto lunar, o sea, la capa bajo la corteza que nadie había tocado nunca. Y las muestras del manto lunar son como el santo grial de la geología planetaria, para que os hagáis una idea, ¿no? Y bueno, como antes decía, ¿por qué nos importa esto? Bueno, pues que es donde la NASA planea aterrizar con Artemis II, que es la siguiente misión, ¿no? O sea que las fotografías de Artemis II van a servir como reconocimiento previo de zonas de alunizaje, digo yo aterrizar. Pablo, date un capón, Pablo, así, pom, pom, capón, alunizar, no aterrizar. Me he dado 2 capones, por cierto. Os cuento el tercer objetivo y lo dejamos aquí por un rato. Venga, va. Cráter Tsiolkovsky. Mi pronunciación no es seguramente la ideal. A ver si lo digo bien. Tsiolkovsky. No, Pablo, dilo mejor. Tercer capón de Pablo para hoy. Esto es que el fin de semana he estado trabajando en la página web y en ese tracker que estáis viendo, y no he dormido nada, y ahora estoy medio atontado, pero es el cráter Tsiolkovsky, que es lo que llaman el ojo oscuro de la cara oculta. De la cara oculta, no, de la cara no visible, que digo yo. Y este cráter tiene 185 kilómetros de diámetro. Y tiene una característica muy, muy, muy rara. Y es que su suelo está inundado de lava basáltica oscura. Y dices, oye, ¿y esto? Bueno, pues eso crea un contraste visual que es espectacular. Con las tierras altas brillantes que lo rodean, parece como un ojo negro gigantesco, ¿no? Y además tiene un pico central muy prominente, una montaña que se levantó por lo que se llama rebote elástico. Justo después de ese impacto, pues se levantó ese pico central, ¿no? Y es uno de los pocos cráteres de la cara oculta con mare, ¿no? Contar cuántos cráteres hay dentro de él permite datar el basalto, o sea, nos dice cuándo dejó de haber volcanismo en la cara oculta. Y el nombre que yo pronunciaba mal, Konstantin Tsiolkovsky, fue, como os podéis imaginar, un ruso, un visionario que a finales del siglo XIX formuló las famosas ecuaciones del vuelo espacial, ¿no? O sea que sin sus matemáticas, nada de todo esto sería posible. O sea que le tenemos que dar las gracias a Konstantin, que si hay alguien que me esté escuchando desde Rusia, que me perdone, Tsiolkovsky. Y luego vamos a hablar de más rusos o incluso más soviéticos, porque el siguiente que os voy a contar dentro de un ratito, el cuarto objetivo de de toda esta videografía y fotografía, os lo voy a contar después, ¿no? Y si queréis os cuento algunas anécdotas también de las cámaras, y también os voy a contar posiblemente por qué hay gente que va a estar un poco decepcionada con las imágenes que vamos a ver, ¿no? Vamos a ir contando todo poco a poco. Espero que estéis disfrutando de este directo. Os voy a ir contando seguramente cosas que en las televisiones ni en otros programas de YouTube os cuentan, que son cosas, bueno, que he ido leyendo, estudiando a lo largo de los años, y las comparto con vosotros porque creo que son cosas súper interesantes. Así que no solamente podéis ver esas imágenes ahora mismo con Christina Koch y su pelo en microgravedad, me encanta ver eso. Fijaos que no llevan zapatos, no llevan esos calcetines. Y he escuchado, antes de cortar, que han pasado un poco de frío, ¿no? Y ahora parece que eso ya está solucionado, porque como veis, yo creo que es Jeremy Hansen, si no le veo mal. Creo que es Hansen, sí, el que está con un polo en manga corta. Ah, no, es Reid. No, es el comandante Wiseman. No, Pablo. Está... Bueno, es que claro, un marine, estos son más duros que el vinagre, ¿no? Siempre que les veo a los marines y a los militares, a los astronautas de formación militar de esta pura y dura, recuerdo al coronel Trautmann de la película Acorralado, ¿no? Rambo 1, que decía: ese hombre sería capaz de comer cosas que harían vomitar a una cabra. Pues los astronautas son así de duros, ¿no? Pueden soportar temperaturas y situaciones como vivir en ese espacio tan pequeñito durante 10 días, comer, dormir, hacer tus cositas, bueno, pues ahí llevándose todos bien. Bueno, oye, que luego volvemos a conectar, que además seguramente que tenéis alguna pregunta. Me han llamado de un montón de televisiones, de un montón de radios, y me preguntaba ahora un periodista: oye, Pablo, tengo una duda, una pregunta estúpida, y me dice: ¿la cara oculta va a estar iluminada? Y digo, pues no es ninguna pregunta estúpida. Así que si queréis luego os cuento por qué yo no digo cara oculta, y luego si queréis os cuento si la cara va a estar iluminada o no. Así que conectamos en un ratito. Os dejo con estas imágenes. Mira, Reid Wiseman, antes de desconectar, me han mandado así el dedito para arriba. Eso es que va todo bien. Continuamos viendo juntos este directo, amigos.
As I was mentioning, we have the Orion spacecraft flying today. However, the Artemis crew members named their Orion spacecraft Integrity, so you will hear calls to this entire crew with the name Integrity. They say that the name Integrity embodies the foundation of trust, respect, candor, and humility across the crew and the many engineers, technicians, scientists, planners, and dreamers required for mission success. This view live from the outside of Orion as we continue Preparing for our lunar flyby, now less than 5 minutes from surpassing the record set by Apollo 13 astronauts for the farthest humans to travel from Earth. This will not be the farthest that Integrity travels today. They will continue until they reach approximately a distance of 252,760 miles. That would be about 4,105 miles farther than Apollo 13. However, these numbers are our targets, and we will get confirmation on those numbers as soon as we possibly can and share them with you all. We talked a little bit about what to expect from the crew, whether that's taking photos or making audio recordings. To get a little more detailed, Reid, Wiseman, and Jeremy Hansen will be up first to capture imagery and record audio on the portable computing devices. You hear those referred to as PCDs, while Victor and Christina serve as the support members. The crew will switch windows and roles halfway through their shift, and 1 hour and 5 minutes later, Victor Glover and Christina Koch will be the next crew members at windows 2 and 3 to take photos and make annotations, while Reid and Jeremy take on those support roles. There are 5 viewing blocks, and the crew will swap out with each one. During 2 of the blocks, the 2 support members will also be able to enjoy their midday meal. At least 3 times per block is a science sit rep. Again, situational report. This is partially an operational status, reporting back if they missed any targets or gotten any specific ones, if they have issues with their camera or any other operational items. The other part is an actual description of the moon. This task is done by one of the support team astronauts, so that's not the crew currently taking photos or making annotations, but they do have windows 1 and 4 that they can float up and provide that information from. If you watch the entirety of the flyby, you'll also notice the crew will be photographing some targets multiple times to get observations in different lighting conditions. This is due to Orion changing their location throughout the flyby. What this crew will be able to capture in a couple of hours of the same targets in different lighting would take orbiters years to do because of solar and spacecraft positioning. This crew has studied the moon extensively, and they're also familiar with what the science team calls the Big 15.
Bueno, y entro, había dicho que me iba un rato, pues es que vuelvo porque tenemos un récord que se va a batir ahora en 1 minuto. No queda absolutamente nada, que es el momento histórico en que la nave Orión va a cruzar los 400.171 kilómetros de distancia a la Tierra y van a rebasar el récord de la tripulación de Apolo 13, ¿no? Y eso lo vais a presenciar ahora, lo vamos a ver juntos. Yo estoy viendo mi rastreador, vamos a ver, que quedan nada, quedan escasos kilómetros. Esto va muy rápido. Va a ser ahí 56, ¿no? Alguien dice en el directo que lo del récord que no tiene más, bueno, injundia que una mera anécdota, ¿no? Pero bueno, para mí tiene injundia desde el principio, desde el momento. Estos son los seres humanos que más lejos han estado en la historia de la humanidad, ¿no? O sea que para mí es algo que es importante. Estoy intentando ver la medición, pero bueno, hemos llegado a ese momento que creo que es uno de los hitos. Siempre es bonito, ¿no?, decir que se han cruzado los récords. Y bueno, pues ahí está. Los 4 seres humanos que más lejos han estado de la Tierra. Y muy pronto seguramente habrá otros. Y esto es lo bonito de la ciencia. Esto es lo bonito de la exploración espacial. Imaginaos cuando vayamos todavía más allá, cuando nos vayamos a Marte, pues que se romperá todo ese récord una vez más, ¿no? Pues ahí queda. vuestros 4 astronautas ya son hombres y mujeres récord. Aquí lo dejo, luego conectamos.
Set the record for the farthest distance humans have ever traveled from our home planet. At that time, over 55 years ago, Lovell, Swigert, and Hayes flew 248,655 statute miles away from Earth. Today, for all humanity, you're pushing beyond that frontier. Integrity, over to you.
From the cabin of Integrity here, as we surpass the furthest distance humans have ever traveled from planet Earth, we do so in honoring the extraordinary efforts and feats of our predecessors in human space exploration. We will continue our journey even further into space before Mother Earth succeeds in pulling us back to everything that we hold dear. But we most importantly choose this moment to challenge this generation and the next to make sure this record is not long-lived.
Thank you, Integrity, and congratulations to you and the rest of the Artemis II team.
Thank you, Houston. We have a couple more things we'd like to take this moment for. Our science team helped us out with a couple of relatively fresh craters on the moon that have not been previously named, and our crew would like to propose a couple of potential names for those items or those areas. And we spent a bit of time this morning looking out the window, and we're able to see them now both with our naked eye and through the long lens, and so we feel this is a good time to send this down, and a special shout out to Kelsey for helping us with this. The first one we'd like to suggest is a named crater in honor of our great spacecraft Integrity. And so if you were to look at Oriental on the far side and then draw a line straight up to Ohm on the far side, relatively in the middle is an unnamed crater, and we would like to suggest it be called Integrity in the future. And the second one, and especially meaningful for this crew, is a number of years ago we started this journey in our close-knit astronaut family, and we lost a loved one. And there's a feature in a really neat place on the moon, and it is on the near side, far side boundary. In fact, it's just on the near side of that boundary. And so at certain times of the moon's transit around Earth, we will be able to see this from Earth. And so we lost a loved one. Her name was Carol, the spouse of Reid, the mother of Katie and Ellie. And if you want to find this one, you look at Glushko, and it's just to the northwest of that, at the same latitude as Ohm, and it's a bright spot on the moon. And we would like to call it Carol, and you spell that C-A-R-R-O-L-L.
Integrity and Carol Crater, loud and clear. Thank you.
As the Artemis II crew passed the record set by Apollo 13 for the farthest humans to ever fly from Earth at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time, Canadian Space Agency astronaut Jeremy Hansen shared.
We're getting ourselves all put back together now, and we are going to dim the cabin lights and prepare for our science objectives ahead. Thank you.
Sounds good. We're doing the same down here, and you're maneuvering to your observation attitude.
As we pass that Apollo 13 record of the furthest humans to ever fly from Earth at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time, the Artemis II crew shared some poignant words, specifically Canadian Space Agency astronaut Jeremy Hansen. The crew also called down 2 craters not yet named that they would like to name. One, Integrity, in honor of their spacecraft, which they have named. That's near the Ohm crater. Another near Glushko, which is a bright spot, named Carol, in memory of Reid Wiseman's wife. There was a moment of silence here in Mission Control Houston, and now the team and the Artemis II crew are ready to begin their lunar flyby. We are 4 days, 19 hours, 31 minutes mission elapsed time of the flight of Artemis II, our 4 astronauts aboard Orion. Today is our lunar flyby day. The spacecraft is currently about 12,000 miles away from the moon, and you can keep up with the distance from Orion to the moon and Earth by visiting nasa.gov/trackartemis, or you can just stay with us here because we're going to be telling you throughout the day. They are currently 248,834 miles away from planet Earth. Coming up next on the crew's timeline today will be their cabin configuration portion. You heard some calls down to Science Officer Dr. Kelsey Young earlier about how they have configured the cabin so far. This is just a little bit more of timelined activity for them if they need to further do so. On flight day 3, the crew had time on their schedule allotted for configuring the spacecraft cabin for how they intended to arrange it today. Of course, they had to take down that configuration for another test yesterday of their Orion crew survival system suits. But configuring it on flight day 3 allows them the opportunity to get a chance to see what works for them now that they are in the microgravity environment. Again, the crew is about to begin their cabin configuration portion of their timeline, though they have been working that already, as well as potentially during their post-sleep period this morning. The official lunar flyby observations are slated to begin in just about 40 minutes. That's when we'll have the crew at the windows photographing the moon, as well as making calls down about what they are seeing. Again, we are live here in Artemis Mission Control for the duration of the flyby. Currently, the Orbit 1 flight control team is on console. This room is staffed 24/7 from the time before the astronauts step foot on the rocket until the time they splash down and are safely recovered in the Pacific Ocean on flight day 10. Again, this is Artemis Mission Control here in Houston. We are now 11,777 miles away from the moon. We did pass the Apollo 13 record of farthest humans away from Earth at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time. That distance, 248,655 statute miles from the Earth, continuing to be exceeded by the crew. They will reach their farthest distance from the Earth around 6:07 p.m. Central Time. At that time, they will be in an LOS, or a loss of signal, with us on Earth, as they'll be flying behind the moon. as the crew gets into their cabin configuration preparations, we are joined by Dr. Sarah Noble, the Artemis Lunar Science Lead. Thanks for joining us here today.
Yeah, it's quite a day.
Yeah, we are very excited. I can only imagine how you guys are doing over there. So tell me a little bit about yourself and what your role is for Artemis II.
Sure. So I'm the Artemis Lunar Science Lead, so over the entire campaign, and my job is basically to make sure that as we have this big adventure back to the moon, we actually learn new things about the moon.
Fascinating. So why is the moon such an important destination today?
Yeah, so the moon is a pretty amazing place. It is a great place to learn about basic fundamental processes that happen on like all the planets, like cratering and volcanology. And also it is, part of our Earth-Moon system. And, the Earth recycles its rocks pretty well, right, through plate tectonics and weathering and whatever. Most of the rocks on the Earth are geologically young. But on the moon, we have the entire record that goes back 4.5 billion years since we formed. And so if we really want to learn about what was happening in that period, like the moon is really the only place we can go.
We're also thinking about going back to the moon, and we want to go to the lunar South Pole. So what makes that such an interesting destination?
Yeah, the South Pole is cool, right? It's far away from the places we went during Apollo. It's different kinds of rocks there, some of the oldest rocks on the moon. It's also a place where we think there might be resources like water. There are craters that really never can see the sun because of the low sun angles there, and they get very cold. And we think that water and other things can build up in those craters, and so we're very interested to see what that might do for us.
I'm very interested as well. So for some of our viewers who might be new to this, what does lunar science look like during an Artemis mission?
Yeah, it's pretty exciting for us as we have really sort of built this from scratch to try to understand how we can best use the crew to support our science. And so, we've developed a system. We've got a team in place. We've got a back room here in this building called the SIR, the Science Evaluation Room. And there's in fact a back room to that back room over in another building here at Johnson Space Center where we've got our teams of scientists working really hard. They're actually speaking to this room through our science officer. This is now the first time we've ever had a science officer in flight control room. So we're pretty excited about that. So we have a really voice out and up to the crew.
I know, it's been so exciting to hear Dr. Kelsey Young speaking directly with the crew today, now so close to the moon. And we have a live view here of the science operation, or the science evaluation room. So this is where the majority of your team is today, is that right?
Yeah, that's right. This is a big chunk of our scientists. You can see them in there now working hard, trying to get ready for the day. And then again, there's a second room where we have a lot of our data folks, where the data will first come down and they'll sort of sift through the data and get it ready for this team to take.
What's the mood like right now in the SIR?
It is, I would say, giddy. I think we've worked very hard for this. They have done simulation after simulation. They have worked really hard over the last couple of years to get ready for this moment. And I think everybody's just really excited to see, even already we've had some descriptions from the crew coming down, and it's so great to see their joy and our joy, our love for the moon come through.
Yes, we are in for a real treat today if it's been anything like their observations the past couple of days. So how are the lunar science teams using this test flight to prepare for future missions to the moon?
Yeah, absolutely. This is the way that we are building our foundation for the future, from everything from, how do you train a crew to be a geologist, right? And so, working through that, getting them classroom training, field training, building the science team, building these physical rooms that we are in, designing the software that the teams are using, and then, figuring out what happens to that data. They're going to take this data and it's going to come down, and how do we get it out to not only our team, but out to the world and the rest of the science community?
Yeah, that's a great point, because when you hear these crew members talk, you would never know that they're not geologists. Your team has trained them so well.
They have been very good students.
Who can blame them? It's a pretty great topic. One more question for you. How does the science that we're doing on Artemis help support long-term exploration and including our sustained presence on the moon?
Yeah, you know what? We have a saying in the Science Mission Directorate that science enables exploration and exploration enables science, right? So you need the scientists because we are the ones who are the experts in, landing site and doing analysis of landing site and making sure we can find a good place to land, to understanding the properties of the soil so we can, design our systems to manage that, understanding the radiation environment, keeping our astronauts safe, all of these things, right? But, in return, you provide us with opportunities where now we're going to be able to collect this data and collect samples and deploy our instruments and all of that. So it's a symbiotic relationship.
That makes perfect sense. Well, Dr. Sarah Noble, Artemis Lunar Science Lead, thank you so much for joining us here today. Best of luck to you and your team, and I hope that you get to enjoy today too.
Thank you so much.
We are now Getting closer and closer to our lunar neighbor, this live view coming from the Orion spacecraft and a camera mounted on one of its solar array wings.
Houston, integrity for camera serial numbers.
Ready to copy.
Hey Jenny, these are card numbers for the various positions. For the long lens on the D5, we will have individual cards. Victor's 1008, Jeremy 1019, Reid 1012, myself 1015. For the Z9, we will have one card that is dedicated for today, serial number 1007. For the cabin camera D5, we will have one dedicated card for today, serial number 1022.
All right, Christina, we copy all. Thank you.
We just realized that we have Earth out window 1 and Moon out window 2, and Earth out window 4 and Moon out window 3, and it gives you the best idea of scale we have had yet. The Moon is about 3 to 4 times the size of the Earth, and it is almost full, and the Earth is just a small crescent out there. It's magnificent. I got a picture of it with the wide lens. Such a majestic view out here.
Amaze, amaze, amaze. Thank you, Reid.
Those are some of the communications we're excited most about today. Commander Reid Wiseman calling down their view right now, obviously a little bit different than what we can see from the solar array camera. They are looking through the windows of the Orion spacecraft, able to see at the same time Earth and the Moon. You also heard NASA astronaut Christina Koch calling down some of the cameras that they will be using today. The crew is in that cabin configuration portion, and we expect the lunar flyby observation period to start in just about 20 minutes. Checking in on Orion's distance and speed, they are currently traveling 1,071 miles per hour, 249,159 miles away from Earth, 11,293 miles away from the Moon, and continuing to grow closer. At closest approach to the Moon today, the spacecraft will be just about 4,070 miles away from the lunar surface. This will be during our loss of signal with the crew as they travel behind the Moon, and we will await their return to get the official number for you for how close they come to our lunar neighbor. Inside the cabin today, the lunar targeting package is the primary tool guiding the crew observations and consists of two key components. The lunar geography review helped the astronauts study major lunar features in advance and help learn how to orient themselves during the flyby. Because, of course, the Moon is not actually labeled like it appears here when we look at this map. The lunar targeting plan provides a detailed timeline of observation targets, background science context, and specific instructions for the pictures the crew should take, as well as the verbal descriptions that will be helpful to the science team reviewing them later. This is a screenshot from their lunar targeting package, and a screenshot specifically of that lunar.
For attitude.
Go ahead.
Hey Jenny, understanding we are in final attitude now for the lunar flyby, would it be possible to pitch the vehicle down 5 degrees? That would allow us to get the D5 long lens flush and have the least amount of window distortion.
We're checking.
That call from Christina Koch, NASA astronaut and mission specialist on Artemis II.
Copy.
The Orion spacecraft is positioned in a specific attitude to allow the crew to best see the Moon outside of their windows today for this imaging opportunity. That call was a request for a potential attitude shift just slightly, another 5 degrees, to give them a better view and to give them a better opportunity to use their long lens camera. They'll also be using that lunar targeting package we were discussing. I am following along with that real time, so I'll be able to share with you exactly what targets the crew is looking at and when. They also trained with a lunar science passport. It's a little reference guide used on Earth to reinforce recognition of key lunar features. It is not on the flight, but it was a significant study tool for the crew to get them ready for launch. The apparent size of the Moon will change throughout the flyby, and it'll appear roughly like a basketball held at arm's length at the crew's closest approach. That reinforces the need for careful planning and practiced observation techniques.
line.
Go ahead.
Hey, Jenny, just to make absolutely sure that we start observations when expected, we are showing in Optimus that observation time starts in about 15 minutes, and in LTP that our first target, discussion 1, starts in about 29 minutes. Can you confirm you'd like us to start discussion 1 in 29 minutes at 1900 GMT?
Christina, we are tracking that discussion 1 should start at 18:45. That's 15 minutes from now.
Okay, copy all. It may be a granularity issue with LTP, but understand that we start that observation in 15 minutes, and I bet when we get there, the green line in LTP will match the start of the white band for discussion 1. I think it's just a matter of the labeling and the granularity. Thanks for confirming.
Copy, and we'll look into that a little bit more on our side as well. Christina, can you verify for us that your green line is moving on the timeline page of your LTP?
Affirm. Jenny, I do think we're good. Looking closer, I see the labels are just not aligned with start or end times of the white visible bands. It fully makes sense now, so I think we are all set. We'll look forward to starting some observations in about 13 minutes.
Copy. Thanks, Christina.
As you heard discussed, we are expecting the crew's observation time period to start in about 10 minutes. First, they'll be conducting a warm-up, warming up to their science observations of the moon. They'll be discussing with each other, helping each other orient using the major landmarks that they've studied, asking what is familiar.
If we roll left, port 5 degrees, that would get the moon closer to the left side of window 2.
Copy, Victor. We'd like to know if it's pitch and roll or one or the other.
Jenny, we actually thought you already put the pitch in. Had the pitch been put in already?
No, we need a little while longer to talk about it.
So Jenny, I guess what's happening is just as our orbit's changing, where it is in the window is changing, so maybe these fancy little adjustments aren't worth it. It's going to continue to move in the window. Or is the spacecraft going to keep the moon at the same point of the window if we adjust the attitude? I assume the previous.
Right now, we are pointing the center of the window to the center of the moon with 2 degrees of deadband.
The conversation you hear happening now between the astronauts aboard Orion and Artemis Mission Control here at Johnson Space Center in Houston, Texas. They are in the center of your screen, seated at the CAPCOM, or Capsule Communicator Console. That's Jenny Gibbons, Canadian Space Agency astronaut and Artemis II backup. She was also the lead Capcom for Expedition 63 aboard the International Space Station. The crew is requesting some attitude changes to the spacecraft to allow them to better image the moon, our priority for today. Of course, those have to be discussed on the ground before they are put into work aboard the spacecraft, so the team is taking some time to do so. You also heard Gibbons reference that we are into deadbands. Deadbands are essentially keeping us in the lane in which we're traveling. If you're familiar with lane assist in your car, very similar in this case. We are now 10,870 miles away from the moon, traveling 1,066 miles per hour and 249,390 miles away from Earth. Again, we recently surpassed the Apollo 13 distance record of farthest humans have ever traveled. And upon calling down some words during that milestone, Canadian Space Agency astronaut Jeremy Hansen noting that he hopes that this record that they are setting today is soon broken by future explorers. This is Artemis Mission Control. We are standing by for the beginning of Lunar Flyby. Expecting that to start in just a few minutes when the crew will begin a warm-up discussion, preparing for the day. They will be capturing images along while discussing what they find familiar about the moon and what looks unexpected to them. Again, just minutes away from the official start of Lunar Flyby, or when it is timeline.
Pues bienvenidos de nuevo, amigos. Estamos a escasos 3 minutos de uno de los momentos clave de esta misión Artemis II. A 2 minutos ahora, exactamente a las 2:45 hora local aquí en Florida, 8:45 hora peninsular en España, se abre lo que se denomina la ventana de observación científica. Y es que la cápsula Integrity, esta Orión, va a reorientarse para, para tomar multitud, decenas o miles de fotografías con sus 3 cámaras Nikon profesionales, con sus 2 D5 y con su Z9. Tienen diferentes teleobjetivos y lo que van a perseguir son 30 objetivos geológicos muy bien seleccionados por el equipo científico de NASA. Antes, en la conexión anterior, hemos definido los 3 primeros, creo que nos hemos quedado en los 3 primeros. Y bueno, pues se va a marcar un hito, ¿no? Si queréis os cuento un poco el equipo fotográfico que llevan. Os decía, llevan 2 cámaras Nikon D5, son cámaras profesionales de 20,8 megapíxeles, que es la misma cámara que muchos reporteros de gráficos de guerra y fotógrafos olímpicos han utilizado durante muchos años. Es una cámara bastante robusta, muy rápida. Sí que existen cámaras mucho más rápidas hoy en día, ¿no? 12 frames por segundo con sensores grandes y tiene un excelente comportamiento, que por eso se ha elegido con poca luz. Y de hecho la foto que veíais el otro día de la Tierra imponente se había hecho con esa cámara Nikon D5, ¿no? También llevan una Nikon Z9, que es la joya a la corona de Nikon. Tiene 45,7 megapíxeles. Es la primera cámara sin espejo que viaja al espacio profundo, y NASA pues ha trabajado directamente con Nikon para modificar esta cámara y hacerla, bueno, pues para que soporte todas las condiciones con las que va a estar, ¿no? Tiene un firmware especial, tiene lubricantes para que no se congelen ni se evaporen en el vacío, tienen carcasas térmicas, tiene una protección contra radiación cósmica y tiene unos botones además rediseñados pues para poder manipularlo incluso con los guantes, ¿no?, de los astronautas. Y luego también llevan, por supuesto, diferentes lentes. Llevan distintas focales, desde gran angular hasta el teleobjetivo largo, y luego pues pueden hacer panorámicas del disco lunar completo, ¿no? También pueden hacer primeros planos, y de hecho antes en una conexión desde Houston escuchábamos cómo les daban algún consejo sobre cómo tomar esas fotografías. Intentarse acercar lo más posible a la ventana, utilizar el 400, y si tenían que tomarla en ángulo para evitar esos reflejos del cristal, pues utilizar una lente un poco más, una longitud de unos 250 milímetros. Me estoy acordando ahora, como curiosidad, de las cámaras Hasselblad que llevó el Apolo, ¿no? Hasselblad, mítica marca que todavía existe. Esas cámaras tenían 12 megapíxeles, equivalentes como mucho, ¿no? Y Artemis II lo que va a traer son imágenes pues 4 veces más de resolución, o sea que imaginar lo que vamos a poder ver, ¿no? Sí que es verdad que bueno, tenéis que tener en cuenta que todas estas cámaras, sobre todo las del exterior, se están enfrentando a situaciones muy complicadas, con un entorno muy hostil, ¿no? Llevan un sistema experimental de comunicación óptica que utiliza un láser, utiliza luz infrarroja para transmitir datos, y entre esos datos están las fotos, por supuesto, a una velocidad superior a la de las ondas de radio, pero esa conexión se prioriza para pues que la misión se lleve a cabo de forma segura, ¿no? Entonces, si hay que priorizar la seguridad antes que la retransmisión de fotos, pues se hará, ¿no? Sí que es verdad que antes del sobrevuelo han hecho una demostración en la que han transferido más de 100 gigas de datos recopilados durante toda la misión hasta ese momento, ¿no? Pero ese sistema de comunicaciones ópticas solo puede utilizarse de noche, porque la luz solar puede causar interferencias y está sujeto también a otras limitaciones, ¿no? Como el hecho de que apunte en la dirección incorrecta mientras esas ventanas del Integrity están enfocando a la superficie lunar, ¿no? Por tanto, todas las imágenes en directo del sobrevuelo, así como la telemetría de la cápsula, deben transmitirse a través del mismo canal de radio directo, ¿no? O sea que ahí es donde el desafío más importante reside. Y bueno, pues vamos a ver qué es lo que vamos a ver y lo que no vamos a ver, ¿no? Habrá gente, por supuesto, que esté desencantada cuando veamos esas imágenes. Habrá gente que esté, como yo, fascinado igualmente. Y lo que tengo clarísimo es que cuando lleguen de vuelta a la Tierra, o cuando se puedan transmitir esos datos, pues vamos a ver imágenes increíbles, ¿no? Van a poder grabar vídeos 8K. ¿Qué es lo que van a fotografiar con esas cámaras y con esos sistemas que os contaba? Bueno, además también, antes de hablar de eso, llevan también alguna GoPro, ¿no? Yo creo que sí, que llevan alguna GoPro, si no recuerdo mal. Sí, las cámaras SOC, que son las que, de hecho, son las que están en los paneles solares, que la gente dice, oye, no se ve muy bien. Claro, es que estos, durante la pérdida de señal no vamos a ver nada, eso de antemano. Pero mientras tanto, de hecho, las cámaras que estáis viendo ahora, vamos a ver si yo lo puedo ver, voy a clicar aquí. Sí, veis, mira, esto que estáis viendo aquí, que veis la cápsula Integrity, la Orión y la Luna ahí detrás, pues esta cámara es una GoPro. Y son especializadas, son modificadas. Una está montada en cada una de las 4 alas, por así decirlo, que son los paneles solares que se extienden desde el módulo de servicio. Y bueno, nadie esperaba vídeo de alta resolución, ¿no? Pero estamos viéndolo, joder. ¿Qué más queremos? Lo veremos mucho mejor cuando, como decía, retransmitan esos datos de vuelta y ese vídeo de 8K, ¿no? Porque esas fotos serán como las que haces en tu teléfono, o como el vídeo que puedes grabar y luego transmites, ¿no? Es que están a muchos miles de kilómetros de distancia. Os decía, ¿qué es lo que van a fotografiar? Antes os hablaba de la cuenca oriental, de la cuenca Aiken Polo Sur, del cráter Tsiolkovsky, y ahí me había quedado, yo creo, ¿no? Os decía que ese cráter Tsiolkovsky de 185 kilómetros de diámetro, que tiene una característica rarísima, que está inundado de lava basáltica oscura, ¿no? Y que parece como un ojo negro gigantesco. Bueno, pues os contaba también que Konstantin Tsiolkovsky fue el visionario, ese ruso que formuló las ecuaciones del vuelo espacial, y que por eso están todos ahí. Bueno, me había quedado ahí. Otro de los grandes objetivos para hacer ese tipo de fotos y de esos vídeos es el cráter Korolev. Es un cráter que tiene 437 kilómetros de diámetro, Es uno de los más grandes de la cara no visible de la Luna, y se llama así por Sergei Korolev, ¿no? Que fue un ingeniero jefe del programa espacial soviético y el padre del Sputnik. El padre del Sputnik, nada más y nada menos, ¿no? Así que hay una ironía bastante graciosa. La cara no visible de la Luna es una galería de honor soviética, ¿no? Porque fueron los rusos quienes la fotografiaron primero con la sonda Lunar 3 en el año 59, ¿no? Del pasado siglo. Y al hacerlo, pues tuvieron derecho a poner los nombres. Así que por eso se llama cráter Korolev. Y tenemos también otro de los objetivos, es el cráter Apolo. Claro, Apolo, porque el Apolo 1, Grissom, White, Chaffee, esos fueron los tres astronautas que perecieron en aquel terrible incendio del Apolo 1. Pues ese cráter lleva el nombre de Apolo en honor, y hay algo poético casi en que Wiseman, Glover, Koch y Hansen, nuestra tripulación de Artemis II, vayan a fotografiar hoy los cráteres dedicados a los tres astronautas que perecieron en aquel terrible accidente en 1967, que a raíz de aquel accidente se hicieron un montón de cambios. Lamentablemente en la historia avanzamos al tropezar y al perder vidas humanas, es terrible, pero es así. Bueno, pues este cráter Apolo, un cráter de 537 kilómetros dentro de la cuenca SPA, pues está nombrado, por supuesto, en homenaje a ese programa, ¿no? Más objetivos que vamos a poder ver, no sé cuándo, antes o después. El cráter Daedalus, 93 kilómetros de diámetro, prácticamente en el centro geométrico de la cara oculta. Alguien me preguntaba antes, oye, ¿es la Luna? Parece redonda, pero lo es. Bueno, pues es que es casi, ¿no? Es una esfera casi perfecta, ¿no? Con tres ejes. Es como un limón muy, muy, muy redondo, o sea, ¿no? Casi perfecto. Pero bueno, el cráter Daedalus es el punto más alejado, el más aislado de la Tierra, radioeléctricamente hablando. Es decir, no hay interferencias de radio humanas. Nada, cero. ¿Por qué? Porque la Luna actúa pues como un escudo, ¿no? Y por eso se considera desde hace décadas como el mejor lugar del sistema solar para construir un radiotelescopio, imaginaos. O sea que capturar imágenes de Daedalus no solamente es ciencia, sino que es prácticamente un avance informativo para lo que nos espera en la próxima generación de exploración espacial. O sea que hacemos un pequeño repaso, si queréis, del top. ¿Por dónde vamos? Ya he perdido la cuenta. Yo creo que vamos por el 6, ¿no? Top 6. Vamos a hacer top 6, como hacían los 40 principales. Hola, soy Joaquín Luqui. Qué grande Luqui. Pues hacías del 40 al 1. Nosotros vamos a hacer del 1 al 30, yo creo. Vamos a repasar Cuenca Orientale, la joya de la corona. Ese cráter de 930 kilómetros de diámetro, formado hace 3.800 millones de años en el bombardeo intenso tardío, que son los cráteres que veis ahí. La cuenca Aitken, SPA, Polo Sur. La cuenca de impacto más grande, más antigua, más profunda del sistema solar conocido. 2.500 kilómetros de diámetro, 13 kilómetros de profundidad, 4.300 años de formación. Fijaos, ¿no? Qué increíble. Hemos hablado del cráter Tsiolkovsky, ese ojo oscuro de la cara no visible de la Luna. El cráter Korolev, del padre del Sputnik. Y el cráter Apolo, homenaje a la tripulación del Apolo 1. Y el cráter Daedalus, que es el último del que hemos hablado, ¿no? El mejor sitio para construir un radiotelescopio en el sistema solar, porque no hay interferencia de radio humana, ninguno. sea, que fijaros que alucine, ¿no? El mare moscoviense, que es el siguiente, es otro de los objetivos que tienen marcados la tripulación. Me está llegando un mensaje de Eric Berger. Vamos a ver lo que me dice. Lo voy a leer aquí. Nada importante. El mare moscoviense, mar de Moscú, esto es una rareza, uno de los poquísimos mares, entre comillas, basálticos de la cara no visible de la Luna, ¿no? Porque fijaos, la cara visible está llena de estos mares oscuros, el mar de la tranquilidad, que todos habéis oído hablar de ello, que es donde aterrizó el Apolo 11, ¿no? Habéis también posiblemente oído hablar del océano de las tormentas, ¿no? Pero en la cara no visible son excepcionales, ¿no? Y los científicos llevan décadas preguntándose, oye, ¿por qué la cara visible tiene tanto mare y la cara no visible casi ninguno? Que es uno de los grandes misterios, ¿no? Todavía misterio, fijaos. Y tienen, por supuesto, como todo buen científico, pues tienen hipótesis. Y es que la hipótesis que tienen es que la corteza de la cara no visible es más gruesa que la de la cara visible. Así que el magma interior pues no ha logrado romperla, ¿no? Y las fotos de Artemis II a estas escalas, con esos objetivos que decía que llevan, pues van a ser clave para dar con una respuesta, ¿no? Por lo menos con un refuerzo de la hipótesis. Y bueno, pues estoy mirando aquí las imágenes, veo el control de misión. Yo creo, sinceramente, que van un poco retrasados, ¿no? No lo sé. Veo que tengo a mi amigo Nacho Sevilla con sus notas en el streaming, siempre perspicaz, siempre dando las claves para que vosotros podáis aprender cosas con estos directos. Estoy leyendo su última nota. Tras el incendio del Apolo 1 se rediseñó completamente la cápsula Apolo, se instalaron escotillas de apertura rápida, se eliminaron materiales inflamables y se cambió la atmósfera interna. Pues Nacho, como siempre, dando en el clavo, porque fue así, ¿no? Y terrible accidente que además está grabado en vídeo y es terrible no escuchar aquellos gritos. Pero son héroes, ¿no? Héroes de la exploración espacial, y gracias a ellos, pues la misión Artemis II hoy está aquí, ¿no? Amigos, no sé si seguir o seguimos un poco más. Vamos a seguir. Nos habíamos quedado en el mare moscoviense, ¿no? En el mar de Moscú, yo creo. Sí. Yo creo que sí. Pues vamos a hablar de los mares basálticos, ¿os parece? Los frentes de lava. Y es que a lo largo de esta observación, que tiene que haber empezado ya, y si no ha empezado ya, tiene que estar a punto de empezar, van a fotografiar lo que llaman los mares basálticos, ¿no? Que son esas llanuras de lava solidificada y los frentes de flujo individuales, que son esos escalones que marcan cómo avanzó la lava hacia miles de millones de años, ¿no? Pues lo vamos a ir viendo, ¿no? Estoy recibiendo aquí un montón de mensajes. Así que permitidme que lea alguna cosa en caso de que haya alguna cosa urgente, pero seguimos adelante. A ver si puedo escuchar lo que dicen.
Interior
of Vavilov, and so you can see that terrain is, there's some real variation in the terrain there, that there's a nice peak where those peaks intersect, where those rings intersect, and we'll get a picture of that.
Love the description, Victor, especially the comparison and
Bueno, pues está
relationship
hablando
you
de
just described
algunas
about
sombras
topography, and if it's easier
y les está Victor Glover, pues está ya describiendo lo que están viendo al control de la misión en Houston. Y o sea que incluso la gente de Houston no está viendo porque se lo está describiendo Victor Glover, ¿no? Bueno, vamos a volver, mientras tanto, a la descripción de los mares basálticos que os decía, ¿no? Hay una serie de cráteres frescos, hay una serie de cráteres degradados, y es que el equipo científico ha elegido estos cráteres de impacto por las distintas edades que tienen, ¿no? Hay cráteres que son jóvenes, que tienen decenas a centenares millones de años. Algunos tienen, fijaos, rayos eyectivos brillantes que irradian desde el centro, desde esos bordes afilados, y es material completamente inalterado, ¿no? Y luego hay otros cráteres que son más antiguos, con miles de millones de años, repito, miles de millones de años, que tienen unos bordes erosionados por impactos que han sucedido después, ¿no? Interiores rellenos, rayos desaparecidos, y cuando tú los comparas, pues se reconstruye el ritmo prácticamente del bombardeo que ha sufrido la Luna a lo largo de la historia, ¿no? Ese bombardeo constante. Es que la Luna es nuestro disco duro fósil, casi, si lo piensas. En la Tierra la erosión y la tectónica borran los cráteres, pero en la Luna todo se queda ahí, registrado. O sea que es como... Ay, me gusta esto, lo del disco duro. Disco duro fósil. Pues lo dejamos ahí, nos quedamos con eso, del disco duro fósil. Voy a ver si leo alguna pregunta. Y tú dices, oye, alguien en el otro streaming nos decía que para qué sirve esto. Bueno, ¿qué es lo que queremos aprender? Pues está bien que la gente pregunta, ¿no? Primero, para datar mejor la historia de la Luna. Porque fíjate, cuando cuentas los cráteres de tamaños distintos, en superficies de edades distintas, se calibra el reloj geológico, ¿no?, del sistema solar interior. Y ese reloj se aplica después a Mercurio, Marte, a los asteroides. O sea que solamente por eso a todos nos gusta ver las fotos de cuando teníamos 4 o 5 años, ¿no? Pues aquí estamos datando nuestra historia. Estamos reconstruyendo el bombardeo intenso tardío, ¿no?, que fue ese periodo de hace 3.900 millones de años, en el que el sistema solar interior fue literalmente masacrado por asteroides. Y eso coincide, curiosamente o no, con la aparición de la vida en la Tierra. Vamos a pensarlo juntos, ¿eh? Lo voy a repetir. O sea, esta reconstrucción del bombardeo tardío, intenso, ese periodo de hace 3.900 millones de años en el que el sistema solar, como os decía, fue masacrado por asteroides, coincide curiosamente con la aparición de la vida en la Tierra. ¿Casualidad o no? Pues esto es la teoría de la panspermia, ¿no? Pues ahí queda. ¿Y qué más? ¿Para qué sirve esto? Pues para Artemis II. ¿Quién que levante la mano? Me encantaría ver quién lo levanta ahora. Quien esté deseando que bueno, no acaba Artemis II y ya estamos. Por favor, ¿cuándo es Artemis III? 2027-28, Artemis III, 4, las imágenes van a ayudar a seleccionar dónde van a pisar los próximos humanos en la Luna, ¿no? Que seguro va a ser cerca del polo sur lunar, donde hay cráteres en sombra permanente. ¿Por qué? Porque contienen agua helada. Yo recuerdo, cuando yo era un imberbe, que había un científico que me decía, no, es imposible que haya agua fuera de la Tierra. Y fíjate, ahora hay agua por todos lados, ¿no? Qué importante es ser humilde y admitir que lo que no sabemos, empezando por los océanos, ¿no?, es mayoritario. Y os decía que para preparar Artemis III, Artemis IV, las imágenes nos van a ayudar a seleccionar estos lugares, ¿no? Agua helada, el combustible y el aire del futuro. Porque eso es combustible, amigos, no os olvidéis. Nos van a permitir estudiar la dicotomía de esta cara visible y no visible, ¿no?, que es uno de los misterios más grandes de la geología planetaria. Hay un misterio no resuelto. Nos van a permitir, es que yo voy aquí pensando y os estoy soltando esta retahíla, pero nos van a permitir reconocer sitios para futuros experimentos. Os hablaba antes del radiotelescopio en Daedalus, que no tiene interferencias, ¿no? Minería de helio 3, laboratorios lunares permanentes. O sea, imaginad lo que va a venir, ¿no? Yo es que ya, si dejo volar la imaginación, pues la próxima generación de geólogos planetarios. Y todas estas imágenes, amigos, van a ser públicas. Eso luego NASA va a subir todos esos archivos, todas estas miles y miles de fotos, estos vídeos en 8K, lo vamos a poder ver, nos los vamos a poder descargar, que es lo bonito, ¿no? Hay mucha gente que yo alucino cuando nos dicen, mira, están mostrando imágenes precisamente de lo que estoy hablando. Oye, qué casualidad, ¿no? Nos dice alguien, somos extraterrestres. Pues seguramente, malo. Seguramente la vida en la Tierra procede de alguno de esos asteroides, ¿no? Y Nacho Sevilla apuntando en tiempo real, según datos de la NASA, se estima que la Luna caen 1,4 toneladas de material meteórico al día. Al día. ...510 toneladas al año. Eso es casi todo... Bueno, casi todo partículas diminutas, pero bueno, algunas más grandes, ¿verdad, Nacho? Seguro que sí. Esto es una visualización, es una recreación, pero no sé, chicos, me dice Óscar Carreres, hola Óscar, amigo, desde Holanda o Madrid, no sé, como estás siempre viajando, me dice, es un placer escucharte. Pues es que yo me fascino con todo esto, Óscar, y me encantaría que a la vuelta de la Semana Santa en el cole pues se pusieran vídeos como esto para que los niños se fascinasen con lo que está a disposición gratis en la página web de la NASA. Miles de vídeos, fotos para soñar, ¿no? Dice, una carpeta en el ordenador con esas fotos y esos vídeos. Dice Bohemio Love, dice, no nos los pueden enseñar en directo porque no habrá señal y lo veremos después en vídeo. Bueno, pues lo hemos explicado, ¿no? Vamos a poder ver seguramente alguna cámara de GoPro desde fuera, pero luego bajarán esas... No lo sé, igual nos sorprenden, ¿eh? Vamos a ver lo que vemos y lo que no vemos en este periodo de observación lunar. Yo sí que os puedo decir que yo estuve en la rueda de prensa en el Kennedy Space Center cuando hablaron de qué es lo que podrían y no podrían mostrar y por qué y cuándo. Y dieron informaciones técnicas completamente convincentes, ¿no? de cuáles son las dificultades. Me dice Javi, qué alegría oírte de nuevo, no sabía que estabas de vuelta. No sé si te refieres de vuelta hoy o si estoy de vuelta aquí. Este es mi canal, ¿no? Vamos a ver qué más gente está sintonizando con nosotros, gente de diferentes lugares. Ahora están, yo creo que es Víctor Glover. Están con ese, fijaos, con ese mapa lunar que nos ha mostrado antes en pantalla, y por supuesto los astronautas conocen al dedillo, están describiendo a Houston lo que ellos ven de sus 4 ventanillas. Cuando miras al polo norte, hay un corredor que se puede distinguir perfectamente. Toda esa área que va hasta el horizonte tiene un albedo altísimo. Está intentando encontrar el nombre. Que tiene una geografía muy interesante. Está hablando del termidor, que es esa línea entre la luz y la sombra, ¿no? En el horizonte, y le hace comparaciones con el polo sur. Está hablando de Copérnico, que está en la zona más hacia el este. Está describiendo, está siendo los ojos, esto es increíble, ¿no? Los ojos de la misión para los humanos que estamos aquí en la Tierra, ¿no? Y dentro de poco lo vamos a poder ver cuando esos datos se puedan transmitir y nos lleguen. Estoy seguro que vamos a ver imágenes muy pronto, ¿no? No sé si hoy o en directo, no creo, pero... Es que tenéis que pensarlo. ¿No veis? Le está diciendo Houston. Houston les está dando las gracias por ser sus ojos en todo esto. Ahí veis ese mapa lunar. Y os decía es que Artemis II va a tener más píxeles de luna en una sola misión que todas las misiones Apolo juntas, ¿no? O sea, van a traer más fotografía, material videográfico que todas las misiones Apolo. O sea, va a ser increíble, ¿no? Y la cara que todo el mundo llama oculta, que es la cara no visible de la luna, solo se ha fotografiado desde sondas automáticas. Os hablaba antes del Lunar 3 en 1959, pero luego fue el Lunar Orbiter, el RO, el Change 4 de chino, y nunca, jamás antes por ojos humanos a baja altitud hasta hoy, ¿no? En una entrevista para una televisión chilena que me han hecho hace un rato, alguien me preguntaba, el periodista, si los astronautas habían recibido algún tipo de entrenamiento específico para esto. Por supuesto, tienen miles y miles de horas de entrenamiento para la misión, ¿no? Pero para esto en concreto, y digo, por supuesto. De hecho, Victor Glover, que es el que oíais hablar, y Christina Koch han recibido cientos de horas de entrenamiento en geología planetaria, que está impartida por los mismos científicos que preparaban a los astronautas del Apolo, ¿no? O sea que se saben ese mapa que nos estaba mostrando la NASA, se lo saben al dedillo. Yo creo que las fotos, estoy leyendo aquí algunos datos, yo creo que van a llegar en menos de 24 horas. Vamos a poder estar viendo estas imágenes en España. Mañana seguro van a ser portada de todos los periódicos. Esta ventana de observación lunar que bueno, pues va a durar un buen rato, 7 horas de trabajo científico ininterrumpido, o sea que tiene una jornada laboral de cinematógrafos y de fotógrafos bestial. Y a la 1:15 hora peninsular en España es cuando vamos a perder la señal completamente. Ese blackout, 40 minutos de silencio absoluto, donde vamos a perder las comunicaciones con ellos, y va a ser uno de los momentos de mantener la respiración, ¿no? El lanzamiento fue uno, el momento de la inyección translunar fue otro, cuando deciden encender esos motores para inyectar, por así decirlo, a la Orión en la pues comprometerse, ¿no? Para ir hacia la Luna, porque una vez que haces eso no hay vuelta atrás. Entonces tenían que estar todos muy seguros. Ese fue otro de los grandes momentos. Este es otro de los grandes momentos. Hace un ratito batían el récord de los humanos que más lejos han estado de la Tierra en la historia. Ahora están tomando fotografías que pronto vamos a ver. Y luego, pues claro, cuando vuelvan en esa maniobra de retorno libre, vamos a poder contener la respiración. En el momento de la reentrada. Momento comprometidísimo, porque son miles de grados, más de 2700 grados, que eso que veis tan prístino ahí, eso blanco, ese escudo que les protege, pues va a tener que aguantar la reentrada a una velocidad de 11 kilómetros por segundo, que eso es como ir de Madrid a Barcelona en 45 segundos, ¿no? Y ahí se condensa una cantidad de energía que hay que disipar y temperaturas altísimas, ¿no? Para que os hagáis una idea, eso es la mitad de la temperatura de la superficie del Sol. Fijaos, alucinante, ¿no? Y tuvieron en la misión Artemis I, que era una misión no tripulada, pero en que se probó este escudo. Sí que es verdad, antes de las modificaciones que se han hecho ahora, pues este escudo se vio que tuvo algún problema, ¿no? Con lo cual sabemos que uno de los momentos comprometidos es el regreso de nuestros astronautas, y de hecho NASA y los ingenieros del JPL han modificado la trayectoria de reentrada para minimizar los riesgos, pero aún así va a ser uno de los momentos delicados. Pero hoy vamos a disfrutar de todo esto. Os voy a dejar un ratito, que tengo compromisos. Hoy tengo un montón de cosas, entrevistas, llamadas, pero vamos a ir conectando, no quito el ojo, y por favor seguís fascinándonos, seguís leyendo unos a otros y compartiendo conocimiento, Nos dice Malu J6X, va a salir todo bien. Por supuesto, Malu, claro que va a salir todo bien. Y dice Galaica, y usan la gravedad para dar la vuelta sin usar motores. Pues eso se llama una maniobra de retorno libre, y es que cuando den la vuelta ya la gravedad les va a traer de vuelta, como dices tú, de forma libre, ¿no? Entiendo que el cálculo de la trayectoria, nos dice TM Herrera 4829, nos dice, entiendo que el cálculo de la trayectoria se ha hecho con las leyes de la física clásica. Pues fíjate, seguro que sí, y además con españoles haciendo esos números. Españoles que además hemos tenido y entrevistado en Radio Respeto desde el JPL en California. Así que podéis recuperar alguna de esas entrevistas. Gente joven, gente menos joven, pero mentes brillantes, que del mundo está lleno. Españoles por el mundo, haciendo buena ciencia y, entre otras cosas, calculando las trayectorias de las que habla TM Herrera. Nos dice Galaica otra vez, la geología terrestre y del sistema solar es una de mis ciencias favoritas. Claro que sí, también de las mías. Bueno, amigos, voy a dejarlo aquí, luego volvemos a conectar, ¿os parece? Gracias por estar ahí, no os vayáis, que van a pasar cosas seguro, y puedo aparecer en cualquier momento para contaros algo que igual os interesa. Gracias por compartir también este stream con vosotros, ¿eh?
The near side is an albedo of 5 and looks quite smooth from here. And then along the same edge of the mare, the edge of the mare that kind of Grimaldi's just outside of, Glushko is just outside of, Carroll Crater is just outside of, and you start to see the stark differences between the darker 7/8 and the 5s and 6s. The 4s and 5s. If you follow that line up to the north, that line is also where the change in topography happens at the North Pole. The line defining the light and dark on the edge of the mare that you can see from Earth. Draw that line, roughly the midpoint of all that, straight to the North Pole. And on the side facing the Earth, you see smoother topography and dotted by Pythagoras and its next door neighbor crater. And then on the far side, you see a lot more cratering and a lot more topography. And again, the far side has the benefit of a little terminator there, but I am seeing a variation in the topography. It seems to be more jagged and a more challenging place to find a place to land and to even traverse in the south. All around the South Pole, and at the North Pole, it would be more challenging to translate on the far side of the North Pole compared to the near side of the North Pole around Pythagoras.
Copy all, Victor. You really help paint a contextual picture of what you're looking at. We really appreciate the way that you're guiding us into the areas you're seeing by drawing comparisons between recognizable features. Thanks for that.
Kelsey, another little science sit rep moment, something I just heard from the window team is the more I look at the moon, the browner and browner it looks. I thought that was an interesting observation. The two observers have been on timeline, no hardware issues. They did start to talk a little bit about another feature that you'll hear more about on the recordings that they call the handprint. That was at the end of their Glushko and before they moved into their current target. They thought that was worth chatting a little bit more about. And they're preparing to switch after this.
Houston copies and concurs.
Hey, Houston Science, actually Houston and Science Integrity, another just observation from the human. My eyes have shifted a little bit since I've been up here. I've been wearing my reading glasses to look at the PCD. Well, this is a very taxing event on the eyes, looking out the window and seeing the very bright moon, then coming back inside to the dark cabin and trying to work cameras and microphones and logistics and lunch and those kinds of things, and then looking at the PCD, which is dimly lit. It's just been an exercise. It is a difficult thing to manage it. I'm up and down on the glasses and then having to wait as my eyes adjust when I come back in. As soon as I look back into the cabin from looking out the window, I can feel my eyes adjusting, and I just have to work through it as they adjust.
Appreciate that report, Victor, and know that we are prepared to read you up targets from the ground if that would give you the ability to keep your eyes focused on the moon and not having to swap between that and the PCD. Just let us know.
Yeah, we appreciate that, science, and we will also do that for the window teams, and we'll back each other up that way as well. But we appreciate that. We may take you up on that. Thanks.
Continued detailed descriptions from the Artemis II crew aboard Orion. Again, this is a test flight, the first time we've flown humans aboard this spacecraft. So every detail, even that it's difficult to look outside the window and then back at the PCD, that portable computing device, every single detail is appreciated as we prepare for future missions. Glover also mentioned that he is now wearing his glasses now that he's in space and that his eyes have shifted a bit. This is something that happens when our astronauts go to space. There is a fluid shift from the lower half of your body up into your head, and that can cause changes in your eyes. It's something that we have seen over time for some crew members, especially now that we have been living and working on the International Space Station for over 25 years. Again, it's clear that these Artemis II astronauts have undergone extensive lunar science training, including classroom instruction, fieldwork, and high-fidelity simulations. Training expeditions even took place in analog environments like the Icelandic Highlands and the Kemassassin impact crater in Labrador, where crews practiced identifying and describing geologic features under varying conditions. Additionally, here at Johnson Space Center, Orion mock-ups were used to rehearse crew choreography, including three-dimensional space management with an inflatable moon globe to simulate the flyby. And while on Earth, the crew also used that small lunar passport that I mentioned with descriptions, photos, and prompts to help them study the features we hope they'll see. Now, this is a view from their lunar targeting package at this time, helping them determine what they're seeing on the moon, as well as on the left, keep up with what their next target will be. As you can see, we have got a long list and an exciting day ahead of us. It's now been 4 days, 20 hours, and 53 minutes since Orion launched atop the Space Launch System rocket from Kennedy Space Center in Florida with our 4 crew members aboard. NASA astronauts Reid Wiseman, Victor Glover, and Christina Koch, and Canadian Space Agency astronaut Jeremy Hansen. The Artemis II crew passed a major milestone today when they passed the Apollo 13 distance record at 12:57 p.m. Central, 1:57 p.m. Eastern. That Apollo 13 distance record was 248,655 statute miles from Earth.
And Houston, another observation, whole moon. When you look at the moon, something I've never seen in photographs before, but is very apparent, all the really bright new craters. Some of them are super tiny. Most of them are pretty small. There's a couple that really stand out, obviously. And what it really looks like is like a lampshade with tiny pinprick holes and the light shining through. They are so bright compared to the rest of the moon.
We copy, Christina. Thank you. Looks like you guys might be doing it, but remind you to swap positions at the window and take your SD cards with you. We're loving everything that you're calling down, so keep it up.
Again, Orion previously surpassed that the Apollo 13 greatest distance from Earth by humans. That was 248,655 statute miles from Earth, and Orion now 250,294 miles away from our home planet. The spacecraft is 9,033 miles away from the moon and growing ever closer. At its closest approach, it'll be about 4,070 miles away, and we will make sure we confirm what that distance ends up being. This is an approximation and an estimate ahead of that moment. We're anticipating them to make that closest approach at 6:02 p.m. Central, 7:02 Eastern, when they are in a loss of signal, transiting behind the moon. They will be the first humans in over 50 years to fly behind the moon and lose contact with Earth. We will regain that contact about 40 minutes later as they reconnect to the Deep Space Network, emerging from behind the moon, and we will look forward to seeing an Earthrise. Again, the crew is currently in their position swap portion on their timeline. This allows crew members the opportunity and the experience of all roles necessary during today's flyby. Right now, those two crew members at the window have swap positions. Again, the crew at the windows swapping positions. Right now, that crew is Commander Reid Wiseman and Mission Specialist Jeremy Hansen, while Victor Glover and Christina Koch serve as their support flyby crew members. That's why you are hearing Victor and Christina during those science situation reports. Those voices will change in about 30 minutes when they take a turn taking photos and making annotations while at the window.
Houston, integrity. I wanted to provide an observation or a little bit of descriptive nature on something that we saw on the first day we had good moon views. This was when we saw more of the near side, and the ground helped me out with identifying Mare Imbrium. Mare Imbrium, when you have the western limb also in view, looks completely different than the normal view we have of the near side. It is the most striking feature of the western limb view that we had, and the mountain chains that form its eastern side are very prominent, but they actually stand out more than I'm used to seeing even on the western side, and the whole thing just feels like a big bump. it actually looks like a large healing wound with a high albedo forming the mountain chain around the impact basin. And I just don't think I had enough chance to describe how striking it was on that western limb view as we were coming in a couple days ago.
Christina, science, absolutely love that, especially since that's a feature that all of us here on Earth can observe from home. So I'm sure tonight everyone's going to be going out and looking for evidence of that beautiful topography you just said. Thanks for those words.
The view on your screen coming from Orion, a camera mounted on the spacecraft's solar array wing. Toward the right of your screen, the near side is the hemisphere we see from Earth. That is identifiable by those dark splotches, which are ancient lava flows.
Science integrity. A question and a comment. Question is it possible that we're seeing a Schrödinger basin from this vantage point in the Terminator at the South Pole? And the comment is the rays coming out of are less distinct. We are not seeing the bright rays coming out of it, but the sort of 9 o'clock wedge that is formed by the change in albedo from the interior portion that is to the northeast to the surrounding lighter mare that's 270 degrees to the west. That 90 is very distinct and interior. You got some great descriptions from the two at the window about the colors in there, but in that darker part, in that wedge, you've got some really interesting color, even though the rays, the distinct difference in the albedo almost look like rays, but it's not the rays coming out, it's the just change in that albedo.
Integrity science, that is very intriguing, those color rays coming out of rather than sort of albedo. And as answer to your question, we do not think you can see Schrödinger. It's in darkness as of now. But thanks for that description, and it sounds like the pair at the window's got great descriptions that we're definitely going to dive into tonight.
Okay. If you could help me, I would still love to know what it is. There's a very nice crater. You're going to likely have a lot of pictures of it. What would be right in the Terminator at the South Pole or close to the South Pole where it's intersecting the Terminator right now?
Yeah, Victor, we're assuming you're talking about, kind of if you're looking at the Terminator, it's basically like 70% down from the North Pole. Is that where you're looking?
Contact, yes, that is where I'm looking.
Integrity Houston, that is an enabled caution for wastewater dump required. We have hit our limit. As expected, no crew action.
Copy, no crew action.
You are.
And integrity science, we're trying to figure out what you're looking at there. Is it like right on the terminator, or is it in the eliminated portion next to the terminator?
While we wait for a response from the crew, the terminator is that difference between day and night, or brightness and darkness, that you see on the moon. We see this from the International Space Station as well, looking down at Earth.
And science from integrity, excuse my space orientation adaptation. If you draw a line between Glushko through the center of Oriental, and then another line from Glushko through the southern tangent of Oriental, that line would almost perfectly intersect tangentially the crater that I'm talking about, and it is on the terminator. So yeah, I think I'm not looking at the South Pole. I was a little twisted.
That line description was really helpful. I have eyes on the SIR right now, and they are actively discussing lunar geography. We will be back with you shortly.
You're hearing a couple of voices today in Mission Control Houston. One of those is Dr. Kelsey Young.
Integrity science, we believe that's Zeeman crater.
Oh, I floated away from the speaker. Say it again, please.
We believe that that is Zeeman crater.
Zeeman. Okay, and can you say the first letter? I may be pronouncing that wrong. What's the first letter of that word?
Zulu. It's Z-E-E-M-A-N.
Copy. Thank you for that. Yes, we've got a great view of that. And when I went back to the window just now, the view has completely changed. Our trajectory is taking us to a new view, and I'm looking more into Babalov. I've got a nice, great view into Babalov. I'm actually away from the window right now, so I'm going to go try to give you some bounding words on the view that we're seeing, but I've got to get back to a window in a minute.
Understood, Victor. You're defining new views of the moon in more ways than one.
Again, when you hear calls down to science or from science, that's Dr. Kelsey Young, the Artemis Science Flight Operations Lead here at a console in Mission Control. You also hear communications with the crew from Canadian Space Agency astronaut Jenny Gibbons. She is the Capcom for today. She is a backup Artemis II crew member. Those calls from pilot Victor Glover asking about a feature he was seeing, specifically a crater on the moon. Meanwhile, the team here in the science evaluation room was actively working together to determine which feature he was describing. The teams at the window have continued to move through their targets, including Ohm, Aristarchus Plateau, Reiner Gamma, and we are preparing for the cabin and window teams to swap. That's when we'll hear more from Reid, Wiseman, and Jeremy Hansen when they take on these support roles, while Christina Koch and Victor Glover are at the windows photographing and annotating. As we briefly mentioned, if you look towards the right side of the moon, essentially, This live view coming from a camera outside the Orion spacecraft, and if you look on the right side of the moon where you see those dark patches.
Wow, yeah, I wish I had some more time to just sit here and describe what I'm seeing, but the Terminator right now is just fantastic. It is the most rugged that I've seen it. From a lighting perspective, there are little islands. There are islands of terrain out there that are completely surrounded by darkness, which indicates some real variation in terrain. Up to the north, there is a very nice double crater. It looks like a snowman sitting there. You know, in the 5-10 degrees below the pole in the Terminator, and then on the southern edge there's almost like a hole. Looks like a hole, and it's the diameter of Vavilov size, just blackness, and then a wall of bright, and then it goes back to the black beyond the Terminator. So there's just, it looks like there's just a gigantic hole right there. 1 Vavilov diameter east of the Terminator, and as you go south, the Terminator is not a nice smooth arc. It's just jagged. There's almost a 110-degree turn in the shadow as opposed to the nice smooth arc, again indicating some really interesting variations, and I'm sure we'll get some photos of that. And then one of the craters further to the south of Vavilov, maybe halfway down to the South Pole, is not only a very, looks like just a deep hole, and then there's like 2 island rays pointing off to the west and north that indicate very high ridges and very deep canyons coming up out of that crater. So again, just some really interesting visual illusions going on with the shadows there. Like I said, they look to be islands out beyond the Terminator, because some of the things, maybe even a Vavilov diameter into the Terminator are catching sunlight on the peaks up to the north and to the south. It's very, very interesting to see.
Integrity Science, oh my gosh, that was an amazing picture you just painted. I glanced over at the SIR video and I literally saw fist pumps in the air. Those types of observations are things that humans are uniquely able to contribute, and you just really brought us along with you, so thanks for that.
That's awesome, Kelsey. Did you get a SITREP updating you on a slight change in logistics for PCD use?
Christina, this is Houston. We did not, but we will take it now.
We slightly changed the PCD plan for the window observers. The 2 window observers kept their PCD. So in other words, the one at window 2 went to window 3, and the one at window 3 went to window 2 when they swapped, rather than staying at the window. We'll plan on all observers keeping the same PCD for all observations.
Copy, Christina. That makes sense to us, and good plan. We are coming up here on a cabin and window team swap. Let me know when you're ready for a quick vehicle status.
As you heard, science.
Houston, go for the vehicle system update.
Howdy, Reid. We don't have much for you. We just wanted to let you know that toilet right now is no-go for use as we stick with the predetermined limit for now. All crew members, please use CCUs. Otherwise, Orion is looking very good. And you have 15 minutes in this handover time where we expect Victor and Christina to switch to the windows and you and Jeremy to be in the cabin assisting. Let us know if you have any questions.
No questions at all, and they're in the swap right now. The first thing I'll tell you, I floated up to the docking hatch window and just what I'm going to call the Mare around Oriental just looks so different out the docking hatch right now. It's quite a bit darker. It's the same darkness, if not a little darker than Grimaldi, but it's cool after just being in the 400 mil for the last half hour. Looking up close, I got pictures of everything Ike was just describing on the Terminator. It really is a fascinating Terminator. And then Oriental just looks so dynamic right now. It's very three-dimensional out the docking hatch compared to what I was just looking at through the 400 mil.
We love it. We are getting a sneak preview from one of our SAW cameras at what you're looking at, and we see some of what you're describing. We cannot wait to see your photos. Thanks.
Yeah, Jenny, I wish you had some longer lenses on those solar arrays so you could see the whole moon, but man, it is, or the up-close moon, not the whole moon, but it is just fascinating here. It's so cool.
All right, MPO and INCO, take notes. We want a zoom lens on those saws next time. Thanks, Reid.
Affirmative.
As the crew gets ready to switch positions from the window crew going back to the support crew and the support crew flying up to the windows, this view inside the room, Capcom Jenny Gibbons speaking with the crew, Canadian Space Agency astronaut. The crew has continued to provide excellent descriptions of what they are seeing on the lunar surface. In this picture, or in this live view actually, from Orion and a camera mounted on its solar array wing, if you look at the dark portion on the right side of the screen, those are visible from Earth. That's considered the near side. Those are ancient lava flows from a time early in the moon's history when it was volcanically active. And if you look towards the left, there's that dark, large crater that appears to the left of those lava flows. That's Oriental Basin. It's about 600 miles wide, and it straddles the moon's near and far side. And this mission is the first time that humans have ever been able to see this with their eyes in the daylight. Again, you hear conversation about that Terminator. You have a great view of that as well. That's the difference between light and darkness on the moon. Victor Glover explaining that as a very jagged looking Terminator due to the peaks that they're seeing and the craters that they're seeing as they prepare to cross over the far side. You also heard science officer, the Dr. Kelsey Young, Artemis Science Flight Operations lead, sharing with Victor Glover that his responses are truly something that only human eyes can discern or provide. So we've previously discussed how having humans observing the moon on this mission is being combined with lunar robotic data to help us maximize what we know about the moon. So part of that data comes from the Lunar Reconnaissance Orbiter, or LRO. This orbiter provides the robotic foundation that makes Artemis II lunar science possible. LRO has been orbiting the moon for 17 years, which makes it the longest operated lunar orbiter in history. And it's also the only American spacecraft dedicated specifically to lunar science and exploration. Artemis II lunar observations are designed to complement data like the detailed surface images from LRO. So while LRO provides those detailed high-resolution maps of the moon's surface, the Artemis II crew adds human observations that focus on regional context and relationships between features, giving scientists a larger geologic picture. Now, this combination of robotic and human observations strengthens lunar science. LRO delivers precise and repeatable measurements over long periods of time, while the Artemis II crew contributes real-time visual descriptions and context that robotic instruments alone cannot provide. The best description I've heard while preparing for this mission is to compare the difference in looking at the moon with your own eyes on Earth and trying to take a picture with a camera. The camera truly never does it justice, and it's much easier to describe and perceive what you're seeing with your own eyes than to take a photo. These Artemis II astronauts can rapidly scan wide areas and adjust their focus in real time, as well as describe relationships between features. The crew will also observe the same regions multiple times under changing lighting conditions during the flyby and provide perspectives that would take robotic missions years to accumulate. During the Artemis II mission, LRO is also attempting to observe some of the same lunar features that the astronauts are studying. Collecting this data simultaneously highlights how different instruments and human eyes provide complementary information about the moon. This LRO data plays a direct role in preparing for future Artemis missions. Its measurements of topography, surface temperature, composition, radiation, and lighting conditions are used to assess hazards, identify safe landing sites, and locate potential resources such as water ice near the lunar South Pole. This mission, Artemis II, represents the point where years of robotic preparation are paired with human exploration for the first time in the Artemis era. So together, LRO, the Lunar Reconnaissance Orbiter, and Artemis II are demonstrating how NASA moved from mapping the moon robotically to exploring it with humans. We are laying the groundwork for future Artemis missions and sustained lunar operations. A check-in with Orion. We are now 4 days, 21 hours, and 22 minutes into the flight of Artemis II, our crew aboard the Orion spacecraft. We are now 8,153 miles away from the moon, 250,742 miles away from Earth. The spacecraft is traveling at 1,030 miles per hour.
The professional science update giver is now in seat 2. That is where Victor is, and Christina is nestling into seat 1 with the long lens, and we're just getting ourselves oriented here. It's a cool view in the cabin. It's actually a cool view to be off the camera now and looking at my crewmates getting up to their observation post and looking in. It's super fun.
Copy, I'll read. We like it.
As we heard confirmation from NASA astronaut and commander of Artemis II, Reid Wiseman, they are now switching positions of the support teams and the observation teams. So initially, Reid Wiseman and Jeremy Hansen were at windows 2 and 3 in the Orion spacecraft, taking photos and making annotations in their PCDs, portable computing devices. They were also giving audible descriptions into their PCDs, wearing headsets with microphones and providing recordings that the science team will be able to listen to later. We were hearing from NASA astronauts Christina Koch and Victor Glover as they made observations as part of the support team. Now, as these teams are swapping, we anticipate hearing more from Reid and Jeremy as they'll be on the support team, while Victor and Christina will be at the windows taking photos and making annotations.
Jenny, for the science team, if they can mark this time, I just covered up window 4 to block out the ambient light from a very bright planet Earth. And it'll be interesting to see if in the data Victor and Christina see any differences from me and Jeremy with that window blocked. It's a lot darker in the cabin now.
Copy, Reid. We're taking note, and we'd be curious too.
We are live in the Artemis mission control room during the lunar flyby of the Artemis II crew, the first humans to fly by the moon in over 50 years. Orion launched 4 days, 21 hours, and 30 minutes ago atop the SLS rocket, Space Launch System rocket from Kennedy Space Center in Florida. Our 4 crew members inside the spacecraft are transitioning their positions. The cabin and window teams have swapped. Currently at the window, we have Victor Glover and Christina Koch, NASA astronauts, and serving as support, Reid Wiseman and Jeremy Hansen. For our crews at the window, they are using handheld Nikons with an 80 to 400 millimeter zoom lens. There are also GoPros on each of the solar arrays on Orion, and that's where this view is coming from right now. We have an interior camera of the crew as well, but they have dimmed the cabin lights. They've actually turned off the cabin lights to allow them to better see outside of the spacecraft. This also helps prevent any reflections from lights inside the spacecraft reflecting onto the windows while they are photographing the moon. Talked a little bit about the views and the cameras being used on the Orion spacecraft. And again, we do have GoPros on the tip of each solar array wing. Now, the bandwidth is a little bit limited because having a crew on board, we do have to downlink a lot more data. That includes their environmental control and life support system. We are not the only data, this view that you see, coming down from the spacecraft, and so we do rely on sharing some of that with the other flight controllers in mission control. This helps the team monitor all systems aboard the spacecraft and ensure the safety of our astronauts. We are standing by for a situation report from the crew aboard the spacecraft. They've been imaging the whole moon. There is now a new crew at the window. That would be Victor Glover and Christina Koch, and so being it's their first time since they have moved up to the window positions, they have a chance to orient themselves and describe and take pictures of any color or albedo variations across the surface. Reminder, albedo is the brightness or reflectiveness.
Integrity science for a science sit rep when you're ready.
Houston Integrity, we have no external view of the moon right now for the floating crew members, so my only science sit rep is that we have Victor in window 3 doing observations and Christina in window 2 with the long lens.
Integrity, we copy. Are the shrouds still on windows 1 and 4? And if so, would you consider trying to get a view through one of those windows?
We cannot take the shroud off of 4 because the Earth is too bright and it's impacting Ike's peripheral vision. And then I can get a grazing glimpse out the docking hatch window. I can see Oriental south down to the South Pole. And the primary thing that I see from Oriental right now is just the long trenches that come out. And, you know, when you come out the north side of Oriental, the ejecta kind of boulders across the northern half of the far side. But coming out the southern half of Oriental, I just see those large, here they look like gorges. They're almost like rain when it comes down the Grand Canyon and fingers off into the desert, kind of what it looks like. Also, Burgess Alpha is extremely bright. It's the brightest thing that I can see. Even brighter now than Aristarchus, which is heading off to the Terminator. It's almost impossible now to see Aristarchus, the thing that Jeremy and I looked so much at. I can just barely see the crater rays from Ohm, and I would say for albedo right now, I would go back to Grimati is still extremely dark, especially in that southwest corner, and there are parts of Oriental and the outer ring of Oriental that reach that same level of darkness, especially the rings of Oriental reach the same level of darkness as Grimati. And then south of Grimati, Jeremy and I were noting a few other just really dark areas of cratering, mare there, and those have that same darker albedo, but Burgess Alpha is the brightest, and Grimati is the darkest.
Integrity Science, that was a great description. Thank you, and thanks for the docking window geometry to give us that description. Any comments before you go on the annular ring in Oriental?
The annular ring, which I think everybody kind of describes as like a pair of lips or a kiss on the far side of the moon from here, is very circular in nature. The northern part of it is wider, darker. The southern part is much lighter. It is very neat looking, and but it is far more circular than I remember it looking in our training. The darkness of the northern side of the annular ring is the same darkness from here out this docking hatch window as the center mare in Oriental. Not quite as dark as Grimati, but it is probably only because dust and lunar regolith has kind of impacted over time.
Reid, that's exactly what we were looking for. Thanks so much. You have heart hands coming out of the SIR.
Say that again. Kelsey?
Just saying that the sir was really excited about that. That annular ring was something we were really eager to hear about, so thanks.
Yep, you bet. And now Victor and Christina are moving on to Oriental. I got them situated over there a little bit late.
That was NASA astronaut Reid Wiseman, now providing a science sit rep as he is away from the windows most of the time. He is working as the support person along with Jeremy Hansen in the spacecraft, as Victor Glover and Christina Koch are now at windows 2 and 3, able to photograph the moon. Christina and Victor are also providing recorded information to their portable computing devices, that's their PCDs, and the science team will have access to that at a later time. They will then review it and compile all of this data to help further our understanding of the moon. One of the items you heard mentioned was Oriental Basin. This has been a very exciting opportunity for the crew. They have all been very excited about seeing Oriental, as well as the science team has been looking forward to it. It is known as the Grand Canyon of the Moon, as we discussed earlier. From the pictures, the science team is hoping that the crew will take centered images of the entire basin and surrounding craters in a single frame, but also use those 80 to 400 millimeter zoom lenses to create a mosaic entire basin. With their unaided eyes, the science team is hoping the crew will describe southern dark annular ring, which you heard Reid just describing, as well as any color, albedo, texture, or topography across the mare patches and ring mountains. Science team reports that the observations will be used to study the geologic evolution of the youngest lunar basin and to inform formation hypotheses for the annular ring. And again, another fun fact about Oriental is the diameter is the same distance between Johnson Space Center, where we are today, and Kennedy Space Center, where the crew launched on April 1st.
Venga, chico, gracias. Buenas tardes de nuevo, buenas noches para vosotros. Aquí son las 4:20, las 10:20 en España. Y bueno, os quiero contar algunas cosas de lo que estamos viendo. Primero, ¿por qué la cara oculta? Esto es correcto. El nombre correcto es cara oculta, no cara oscura. Cara oculta sí. Bueno, yo decía, a mí me gusta el lado lejano, ¿no? Y en español la traducción técnica acuñada por la comunidad astronómica es la cara oculta. ¿Por qué oculta? Porque desde la Tierra nunca la vemos, ¿no? Jamás. No la vemos con telescopios, no la vemos con prismáticos, no la vemos a simple vista. Está como literalmente escondida, ¿no? Y la cara oscura... ¿Os acordáis del disco de Pink Floyd? The Dark Side of the Moon. Bueno, pues también tiene un significado así como desconocido, ¿no? Pero Roger Waters reconoció incluso después que el título era una metáfora de la locura humana, ¿no? No como un dato astronómico. La realidad es que la cara oculta recibe tanto sol como la cara visible. O sea, me preguntaba antes un periodista, os lo decía, ¿no? Que si recibe sol o no recibe sol. Y digo, pues la cara oculta de la Luna recibe exactamente la misma cantidad de luz solar que la que vemos cada noche desde nuestra ventana. Ni un solo fotón menos. La diferencia es que cuando una está iluminada, la otra está a oscuras, y al revés. Así que cuando aquí en la Tierra vemos la luna llena, la cara oculta está en plena noche, y cuando vemos la luna nueva, que no la vemos, prácticamente no la vemos, la atisbamos por ahí, la cara oculta está bañada al sol al 100%, ¿no? Y hoy, 6 de abril, estamos en una fase intermedia, como podréis ver, y por eso Artemis II puede fotografiar la cara oculta con una luz bastante generosa, ¿no? Y ¿qué más preguntas tenía antes? Alguien me ha dicho, oye, ¿la luna rota sobre sí misma? Y fíjate que hay un mito muy extendido, que es que la luna no gira. Y eso es falso, la luna sí gira sobre su propio eje, pero lo hace exactamente al mismo ritmo al que la órbita de la Tierra, que es una vuelta sobre sí misma cada 27-32 días, ¿no? Exactamente lo que tarda en dar una vuelta a nuestro planeta. Así que el resultado es siempre nos muestra la misma cara. Es alucinante, no sé si esto lo sabíais o no, ¿no? Es como, por poner así un ejemplo un poco absurdo, ¿no? Pero es como si bailaras un vals con alguien dándote la vuelta a su alrededor sin dejar nunca de mirarte a los ojos, ¿no? Y esto se llama acoplamiento de marea, o también se llama rotación sincrónica, ¿no? Y no sé, podemos hacer un experimento si queréis. Voy a coger una taza de café. Esta soy yo, la Tierra, ¿vale? Luego en mi puño de la otra mano, esto es la luna, da una vuelta a la taza, así, ¿no? Siempre estoy mostrando los nudillos hacia la taza, y hemos dado la vuelta completa a la otra mano sin que la taza haya visto nunca el dorso, ¿no? Y eso es exactamente lo que hace la luna alrededor de la Tierra. ¿Y esto por qué pasa? Os decía, el tema de el acoplamiento de marea, ¿no? Pues esto es física, y si tenemos a algún profesor de física, pues lo sabrá perfectamente, ¿no? Y es que hace miles de millones de años la luna giraba mucho más rápido sobre sí misma. Pero la gravedad de la Tierra deforma ligeramente la luna, que no es perfectamente esférica como os contaba antes, está un poco aplastada hacia nosotros, crea como un abultamiento que la Tierra agarra, por así decirlo, gravitacionalmente, ¿no? Y ese tirón frenó la rotación lunar durante miles de millones de años hasta que se sincronizó con su órbita. Y ahora, o sea, atención a esto, la Tierra le está haciendo lo mismo a la Luna que la Luna nos hace a nosotros, que son las mareas oceánicas, ¿no? Y de hecho la Tierra también se está frenando por el efecto recíproco. Así que cada siglo los días terrestres pues se alargan unos 1,7 milisegundos, y eso significa que así rápidamente en 200 millones de años los días durarán 25 horas en lugar de 24 horas. Tranquilos, en 200 millones de años, que yo creo que ninguno de nosotros va a estar aquí. Pero bueno, los que lleguen, si es que llegamos y no nos matamos a palos antes, pues van a poder dormir más, trabajar más, depende, ¿no? 25 horas, joder, ojalá me dieran a mí una hora más al día. Una hora da para un montón. Pero un montón. Ay, qué bueno. Estoy mirando aquí las imágenes. Estaba escuchando antes, entre llamada, reunión, estaba escuchando cómo describía Víctor Glover y Christina, cómo describían todo eso, ¿no? Lo que estaban viendo, y yo estaba absolutamente maravillado, ¿no? Y oye, la cara oculta hasta hace muy poquito era un misterio total, ¿no? Antes de 1959 nadie había visto la cara oculta, ¿no? Durante toda la historia, desde los primeros homínidos hasta la generación de de nuestros abuelos, nadie supo cómo era la otra mitad de nuestro satélite, ¿no? Y era literalmente como el gran secreto, ¿no? que la Luna le guardaba a la humanidad. Galileo, Newton, Einstein, Kepler, antes, ninguno de ellos vio jamás la cara oculta. Y os contaba en la anterior conexión, en el directo, que Luna 3, 7 de octubre de 1959, mientras Estados Unidos perdía la primera fase de la carrera espacial, la USSR, ¿no? La USSR, pues lanzó Luna 3, ¿no? Una sonda automática del tamaño de una nevera. Pues si queréis, conectamos en un ratito y os sigo contando más cosas, porque ahora a y media tengo otra entrevista. Me está llamando de todos los sitios y digo, oye, yo soy un mero curioso. Así que nos vemos en un ratito, amigos.
The moon preserves a near-continuous record of solar system history that has been erased on Earth because the moon doesn't have an atmosphere. So things that we experience on Earth, like weather or plate tectonics, don't really apply. So the lunar surface retains evidence of ancient impacts, volcanism, and solar activity that scientists can study today. And studying the moon helps scientists understand how planets formed and evolved, how the moon influenced our own planet Earth's history, and how the sun shaped conditions across the inner solar system. The moon also serves as a unique platform for studying the broader universe. Artemis science is designed around questions best answered by humans, working alongside robotic systems, combining decades of robotic lunar data with real-time judgment, context, and adaptability that only humans can provide. This mission, Artemis II, is serving as a proving ground for lunar science operations, which allows NASA to test how science is planned, executed, and supported during a crewed deep space mission ahead of our future Artemis flights.
Integrity, time for a window team position swap. So Victor and Christina, please switch places if you've not done so already, and remember your SD card for the camera.
We're in the swap right now. They're wrapping up their last comments, and they'll switch over and change guards in the long lens.
Copy.
As you heard in that call, it is now time for the team members at the window to swap positions. That means Victor Glover and Christina Koch will be switching roles. One of them has been photographing the moon with a Nikon with an 80 to 400 millimeter zoom lens, while the other was making annotations on their portable computing device. And both are recording audio that the science team will be able to listen to. We are now 2 hours and 10 minutes until we expect to lose signal with the spacecraft as they fly behind the moon. And the next target for the crew is considered a crew choice event. They have the option to focus on any regions or patterns or features that interest them. The science team has asked the crew to capture pictures that illustrate their choice, as well as at different zoom levels, and to describe why those certain features or regions caught their eye. Those recordings are part of what are being saved on their PCDs, portable computing device, that will be sent to the science team for analysis. The crew has been allotted 8 minutes for this crew choice event, and it's also a time for a scheduled sit rep or situation report. So we expect to hear them calling down what they are seeing soon. Something that the crew, or that the science team has used to help prepare the crew, is a cue card. These ask for a feature ID if they happen to know the type or name, and if it is a target. Of course, in this situation, when they have a crew choice, they do not need to, it may or may not be a target. They want to know the location and the observation style. They've also asked for the geometry of what's being captured, the size, shape, boundary, and preservation, as well as the color and shadow, so the color tone, the albedo, that reflection or brightness, and any shadows or illumination. Next, they're interested in structure and texture. That includes slopes, structures, and textures, of course, and geologic relations, like association to other features, any contact to those features, and of course, their thoughts, impressions, or interpretations. They are interested even in emotions and excitement that the crew may be having. This flyby day has been practiced in many ways, even in Sims here in Mission Control Houston. The team also conducted some field work, learning how to look for specific geologic features. They also photographed a large globe, and the science team helped them determine which features they would be targeting and how to look at those. We have a few more minutes that the crew would be photographing their crew choice. Again, this is NASA astronauts Victor Glover and Christina Koch at the windows. They will then move on to another discussion portion. This is for the far side albedo, that reflectiveness, and color that they are seeing. We heard earlier about some browns seen on the moon, which is very interesting, especially here from Earth, where we are just seeing whites, grays, and maybe even black at some points. When they get into that discussion for far side albedo in a few minutes, the theme is looking to know how that color and albedo is, what those variations look like across the far side. On the right side of your screen, the Science Evaluation Room, or SIR, where team members are looking real time at what the crew is seeing. And even earlier, we're...
Houston Integrity, ready for science zero?
We'll take it.
Okay, the crew has swapped positions. They're in their crew choice. Element. I've been listening to both of them for a little bit, and they're really enjoying, they both decided to pick the Terminator, and they're spending a lot of time looking at the Terminator, just talking about the resolution that they can see, the depth of the craters, and the various interesting and unique excavations that they can see. So Victor is on the long lens, and Christina is just looking out the window, and I'm sneaking a peek in T-shirt window. It looks like, I don't have the best angle here, but it looks like Aristarchus is on the limb of the moon now. It's amazing how quickly it changes as we speed around the far side of the moon, stuff that's leaving our field of view, and now we have a lot of the dark side of the moon that, you know, it's missing for us right now, but it would be in view if it was lit at all.
Jeremy, Science, thanks for that sit rep. Do have a question. A few times we've heard you and the other crew describe change during the course of your flyby. Would be interested in future descriptions of more verbosity about how it's changing. Thanks for the great sit rep.
Yeah, Kelsey, sounds good. We are definitely keeping an eye on that. My eyes have just not readjusted. The moon is so bright when you come back to the window. I was just in the interior of the cabin. I've come back to T-shirt window, and it's just overwhelming brightness. And my viewing angle is a bit challenging, so I won't be able to give you great observations from this window. But I will talk about something that I was talking a lot about in my recordings earlier, which was we've been talking about some shades, and so we have obviously the dark and the light gray, and then we've talked about naming some colors, a brownish hue and a greenish hue. And I'll tell you, like right now, Aristarchus, the plateau is hard for me to see from this window, but that had greenish hues to me and was very unique. I didn't see anything like that anywhere else on this side of the moon. And then I see a lot of these, what I would call brownish hue areas. There's a number of them. And they, for example, in the northwest corner of the highlands, to me it looks like the brownish hue is caused by ray or ejected material landing on the highlands, and then we obviously see the ray areas as a lighter albedo, but in between the rays where the deposit would be thinnest, that is what it looks like is causing the brown to me. So I saw that in the northwest side of Aristarchus, or sorry, that dark area of the highlands, northwest side of the highlands. I saw it in the highlands to the east of Glushko, and then I see those same brownish hues west of Oriental, and I drew a contact there on OneNote, but that's a huge region, kind of like a piece of pie with the point of the pie pointing at Oriental and then going up towards the northern side of Hertzsprung. And that is an area that just looks like a different, that brownish albedo.
That was fantastic, Jeremy. We had heard rumors of the green and brown hues, and so you really read my mind on asking about those. Understand they likely didn't have any contact with each other the way that you described them, but please correct me if I misunderstood that. And then last thing, I'll make the same offer we made to Victor earlier. If it would be helpful for us to verbalize any targets so you can stay at the windows and keep your eyes adjusted to the moon, please let us know.
If you got something you want us to look at, Kelsey, you can send it on up.
definitely not looking to interrupt your flow, Reid and Jeremy, only offering assistance if you guys want to keep your eyes off of the PCDs.
Oh, I see what you're saying, okay. Not really science related, and we definitely learned this at Apollo, but the thing that is just most fascinating, I think, to me and Victor right now is even as rugged as the far side looks, when you look at Oriental and home, it's rugged, but man, when you look at the Terminator, it is just like impossibly rugged, and it reminds you that the whole far side is that way, and just the Terminator is really bringing out the shadows and the hills and the valleys, and it is just, it's unbelievable. It's like no surface of the Terminator is not marked by meteor impact, and it's just, it is very impressive to look at that, and you realize that that is true across the whole far side. You just can't see it due to sun illumination right now.
Reid, Houston copies, and we were commenting on the same thing. Even from our view, the Terminator looks absolutely alien because there's just so much texture in there that we're just not used to seeing. So thanks for sharing that with us.
There's also, I don't know the name of it, coming out the south-southwest of Oriental, right on the southern Terminator, is just a massive crater. I don't know the name of it. Maybe you can look on the solar array wing video and tell me it's right. It's the southernmost crater you see on the Terminator right now.
We're looking for you. We're loving that picture. Thanks for showing us. And Reid, as an answer to your last question, we believe that that is Chebyshev crater. And the sir agrees with that.
Okay, that picture I was just showing you is an 8X iPhone out the docking hatch for the high grazing angle. It's just amazing.
We love it. Thank you.
This is Artemis Mission Control in Houston, Texas. Mission elapsed time, 4 days, 22 hours, 12 minutes into the flight of Orion. This is Lunar Flyby Day for the crew aboard the spacecraft. Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen are now the farthest people to have ever traveled from Earth. This a live view from inside the spacecraft. They have turned off the lights so they're able to see outside and photograph the moon better with no reflections from inside. And for a very brief moment there.
Integrity Science, thanks for those iPhone views. It's helpful to see what you're seeing.
We very briefly saw NASA astronaut Reid Wiseman showing a picture he took on his phone of the moon. We do expect to get all of the photos that the crew is taking today, and we cannot wait to share some of those with you. But pretty cool in the meantime, just to see one quick shot from what the crew is seeing. And this view from outside the spacecraft on Orion's solar array wing. Orion is now 6,643 miles away from the moon and continuing to grow closer. Again, their closest approach will be about 4,066 miles. The best comparison is if you held a basketball at arm's length. That's about what it would look like to the Artemis II crew at their closest approach.
Bueno, y aquí estoy de vuelta después del día de locos que llevamos y del día tan bonito, porque estamos viendo, pues dentro de poco vamos a estar viendo fotos que el humano nunca ha visto antes, ¿no? Y nos habíamos quedado, no sé lo que os estaba contando, yo creo que estábamos hablando de todo lo que, de la cara oculta, de si está bien o mal dicho, de si era un misterio, y os comentaba, yo creo que me había quedado os contaba que Galileo, Newton, Kepler, Einstein, ninguno de ellos vio jamás la cara oculta, ¿no? Y que fue el Lunar 3 en 1959, el 7 de octubre del 59, con esa Lunar 3, esa sonda de la Unión Soviética, una sonda del tamaño de una nevera, os contaba, ¿no? Pues que llegó hasta detrás de la Luna y fotografió la cara oculta con una cámara analógica de película. Se reveló la película a bordo en pleno espacio. O sea, tenían un mini laboratorio fotográfico. Escaneó las fotos con un sistema muy parecido a un fax y luego las transmitió por radio a la Tierra, ¿no? Imaginaos, ¿no? Qué alucinante. Esto está en 1959, Lunar 3. Y las imágenes eran horribles, claro, para los estándares actuales, ¿no? Mucha gente se queja ahora de cosas borrosas. Bueno, pues eso sí que eran borrosas, con poco contraste. Claro, pero oye, capturaron pues el 70% de la cara de la oculta, ¿no? O sea, que fue una revolución absoluta. Y por primera vez en la historia de la humanidad, pues lo vimos. Y además vimos que la cara oculta era completamente distinta a la cara visible, ¿no? Casi no tenía mares oscuros, los famosos Mariano. Estaba con muchos más cráteres, con la corteza más gruesa, que es lo que comentábamos antes. Y como los soviéticos llegaron primero, se quedaron con el derecho de bautizar todo lo que iban descubriendo. Por eso, todavía hoy, cuando los astronautas de Artemis II miran por la ventana, cuando estaba mostrando esos mapas, que si os habéis fijado, Houston estaba mostrando los nombres en pantalla antes, pues hablamos de Tsiolkovsky, hablábamos de Korolev, Mendeleev, Lomonosov, Mar de Moscú, Mare Moscoviense, lo veíais ahí en la foto, ¿no? Oye, Mendeleev, que fue el químico de la tabla periódica, y Lomonosov fue otro científico del siglo XVIII, ¿no? O sea que esto es uno de los pocos mapas del sistema solar donde los nombres rusos dominan los sajones. Y todo eso, fijaos, gracias a esa pequeña sonda del tamaño de una nevera lanzada hace 67. Cuando los astronautas de la misión Artemis II estén disparando sus cámaras hoy, van a documentar, ya están documentando, lo que pasa que todavía no lo hemos visto, uno de los grandes misterios de la geología planetaria, ¿no? Unos caras de la Luna parecen dos distintos. Y si queréis os cuento un poco las diferencias, ¿no?, de lo que nosotros vemos y lo que no vemos. Os decía, los mares basálticos, la lava oscura, en la cara visible, que es la que nosotros vemos, cubren el 31% de la superficie, y en la cara oculta solo el 2%. El espesor medio de la corteza, en la cara que vemos, tiene unos 50 kilómetros. Y el de la cara oculta tiene 70, o sea, es un 40% más, si no me equivoco. Y luego hablábamos de esos cráteres gigantescos, ¿no?, de hasta miles de kilómetros de diámetro, ¿no? Pues en la cara visible, cráteres grandes como esos hay menos, y en la cara oculta hay muchos más. Cuando miramos la Luna desde la Tierra, para la cara visible, el aspecto que tiene es como ojos y boca de la cara, y la cara oculta, si la pudiésemos ver, que la vamos a ver muy bien, se va a parecer más como a una pelota de golf, ¿no?, como con muchos cráteres. ¿Y por qué son tan distintas? Ya os decía que hay distintas teorías, ¿no? Y esta es una pregunta sin respuesta todavía definitiva, ¿no? Y los astronautas de Artemis van a aportar datos clave, ¿no? Y os decía, hay varias hipótesis principales. Una es la que se llama el impacto gigante doble. Y esto fue en una hipótesis del año 2011 de la Universidad de California, que lo que promulga es que hubo en realidad dos lunas orbitando la Tierra al principio, tipo Star Wars. La pequeña fue absorbida por la grande en un choque suave, por así decirlo, y formó una corteza extra gruesa en la cara oculta. O sea, que es como una capa de queso fundido sobre una pizza. Y la otra hipótesis es la del calentamiento desigual. La Tierra primitiva, recién formada, estaba al rojo vivo y emitía calor, y la cara que miraba la Tierra, la visible, se mantuvo más caliente durante millones de años. Y luego eso lo cambió. Lo que cambió es cómo se solidificó, ¿no? Y luego la tercera hipótesis es la del impacto en el polo sur. Y ¿os acordáis cuando antes os hablaba de la cuenca Aitken-Polo Sur, que tiene 2.500 kilómetros de diámetro, que es el cráter más grande del sistema solar? Pues estamos hablando precisamente de eso, ¿no? de un monstruoso impacto que fue lo que creó esa cuenca. Y lo que se cree es que ese impacto habría redistribuido el calor interno de la Luna e influido también en la simetría, ¿no? O sea que los datos que en este momento están recogiendo Wiseman, Glover, Koch y Hansen, nuestros héroes de la misión Artemis II, van a ayudar seguro a resolver en los próximos años una de las preguntas más antiguas de la geología planetaria. Seguro, segurísimo. O sea que ahí lo lleváis. ¿Os queréis que os cuente alguna cosa más de la cara oculta? Es que hay tantas cosas. Esto es apasionante, amigos, no me digáis. Mira, la primera vez que algo aterrizó en la cara oculta. 3 de enero de 2019. O sea, esto fue anteayer. Y la sonda china Change 4 se posó suavemente en la cara oculta de la Luna. Nadie lo había hecho antes en la historia. Aterrizó en el cráter von Karman, dentro de la cuenca Aitken Polo Sur, la misma zona que va a ser explorada por Artemis II en los próximos años. No solamente alunizaron, que creo que he vuelto a haber dicho aterrizado, que es alunizar, y llevó un pequeño rover, el HITOS 2, que significa conejo de jade. Sabéis que los chinos pues les encanta el jade, ¿no? Es muy bonito el jade, una piedra semipreciosa. Bueno, pues se llamó el HITOS 2, que sigue funcionando a día de hoy, ¿eh? Ojo. Y como la Luna, os contaba antes, que bloquea las comunicaciones por radio entre la cara oculta y la Tierra, que es lo que luego les va a pasar a nuestros astronautas, que van a estar 40 minutos incomunicados, China lo que hizo, sabiendo eso, por supuesto, es lanzar antes un satélite repetidor que se llama, y que me perdonen mis amigos los chinos, Hueqiao, que significa puente de urracas. Me encantan los nombres. Imagínate llamar que la NASA o la ESA, la Agencia Espacial Europea, lanza que lanzan un satélite repetidor y dicen, vamos a lanzar el puente de urracas. Suena más a pueblo de Extremadura, puente de urracas, que a un satélite, pero bueno, los chinos lo han llamado así, ¿no? Y hay que respetar. Y ponerlo en órbita, bueno, pues ¿para qué lo hicieron? Para que ese Change 4, ese rover, pudiera hablar con China rebotando la señal. El puente de urracas, ese satélite, el Hueqiao, hace referencia a una leyenda china en que las urracas, que por eso de ahí viene el nombre, formaban un puente sobre la Vía Láctea para reunir a dos amantes que se habían separado. Así que los chinos, románticos como ellos solos, pusieron poesía en la ingeniería espacial, ¿no? Y hoy, en este momento, donde solo un pequeño rover chino ha rodado y va a fotografiar todo eso con una calidad que ese rover no puede ni soñar. Y seguramente, casi seguro, alguna de esas fotos va a capturar el Hueqiao, el puente de urracas. ¿Qué os parece la historia? Y yo creo que podéis contar un montón de cosas, ¿eh? Después de haber asistido a este directo, ¿no os parece? No sé cuántos amigos somos más de 400 viendo aquí. ¿Y queréis que os cuente más? A ver, ¿quién está aquí? No sé si tenemos alguna pregunta. Ya han dado la vuelta, creo que hay cortes por cobertura, no sé si de Pablo o de la NASA. Bueno, pues puedo ser perfectamente yo, porque el internet aquí en Estados Unidos es bastante malo, ¿eh? Bastante malo. Pero bueno, espero que se esté... A ver si me dice Fernando Sevilla o Fernando Sierra o Nacho Sevilla me dicen algo. Yo creo que se escucha bien. Espero que sí. Y antes alguien preguntaba Oye, Pablo, ¿puedes contarme algo más? Sí, hubo un momento en que se cortaba. Bueno, pues esperemos que no se corte más. Me preguntaban si podría contar algo más sobre por qué la cara oculta era el paraíso de los radiotelescopios, ¿no? Y la Tierra es que es un infierno de ondas de radio. Y el Kennedy Space Center retransmitiendo el lanzamiento Artemis II fue el infierno en la Tierra, porque se nos cortó, como bien sabéis, el audio, porque estábamos utilizando micrófonos inalámbricos. Nunca más, Santo Tomás. Pablo aprendió la lección. Voy a llevar micrófonos con cable a partir de ahora. Y la Tierra, como os digo, es un infierno de ondas de radio, de wifi, de móviles, de televisión, de radio, FM, de radares militares, de satélites. Bueno, pues cualquier radiotelescopio terrestre tiene que filtrar, imaginaos, ¿no?, enormes cantidades de ruido para captar las débiles señales del cosmos. Pero la cara oculta de la Luna es distinta, porque la Luna, claro, interactúa como un escudo gigante que bloquea físicamente todas las emisiones de radio terrestres, ¿no? O sea, que es si lo pensáis, es el lugar más silencioso, radioeléctricamente hablando, del sistema solar interior. O sea, que por eso os decía que en el cráter Daedalus, ¿no?, el centro geométrico de la cara oculta de la Luna, ¿no? Y este es uno de los grandes objetivos de las fotografías que están tomando en este momento nuestros astronautas. Y NASA ya está estudiando además seriamente este proyecto. O sea, lo llaman el LCRT, el Lunar Crater Radio Telescope. He puesto mi mejor acento americano. Y consistiría en estirar como una antena gigante a través de un cráter, usándolo como un plátano natural, ¿no?, por así decirlo. Y lo que permitiría es observar señales del universo primitivo, las llamadas las edades oscuras, los primeros 100 millones de años después del Big Bang. Imaginaos, ¿no? Eso es imposible de captar desde la Tierra. Así que las imágenes que están captando estos 4 astronautas hoy podrían ayudarnos a elegir dónde construir ese radiotelescopio. Un telescopio capaz de oír el eco del Big Bang. O sea que... ¿Cuántos humanos han visto, pregunta, cuántos humanos han visto la cara oculta de la Luna? Bueno, pues vamos a ver si alguien lo sabe. Vamos a ver, os voy a dar un ratito. Mientras voy a beber agua, ¿eh? Tenemos más preguntas. Luego alguien nos dice: Óscar, Pablo, ¿la velocidad es constante en toda la travesía entre la Tierra y la Luna? En la travesía, en las proximidades de la Luna y Tierra, entiendo que no, por supuesto. Pues no, muy bien lo dices, porque no es constante. Esto, Óscar, no sé dónde lo contaba antes, ¿no? Que era para que os hagáis una idea, esto es como tirar una pelota. Cuando la tiras hacia arriba, la pelota sube a toda velocidad, de repente se empieza a frenar, de repente como que hay una pausa en el aire y vuelve para abajo, ¿no? Pues con la Orión pasa lo mismo, ¿no? Mucha gente me decía: oye, Pablo, hay algo mal porque la nave va muy despacio, ¿no?, a medida que se acerca a la Luna. Pues no, pero es completamente el pozo de gravedad, ¿no? Os tenéis que imaginar que el espacio es como una sábana elástica que la ponéis en plano y la Tierra es como una canica muy pesada que va en el centro. Pues Orión sube como esa pared, ese pozo de gravedad, sube, y luego hay un momento en que llega a la gravedad de la Luna, en vez de caerse, porque si no se caería, si no tuviera un satélite o si no estuviera la Luna ahí, u otro ente con gravedad, pues la nave Orión se caería de vuelta a la Tierra, ¡pum!, para abajo. Pero llegan a la órbita de la Luna y la gravedad lunar pues hacen que se quede ahí, ¿no? Orbitando, y que luego cuando giren puedan volver a toda velocidad. Y eso es la explicación así prácticamente, ¿no? ¿Cuántos humanos, que Pablo, que se te va la pinza, va? ¿Cuántos humanos han visto la cara oculta de la Luna? Pues antes de hoy, solo 24 personas. Solo 24 seres humanos habían visto la cara oculta de la Luna directamente con sus propios ojos. No estamos hablando de fotos, de... ¿Y quiénes? Los americanos. Americanos en Apolo 8, 10, 11, 12, 13, 14, 15, 16, 17. Entre 1968 y 1972. Y de esos 24, muy poquitos, lamentablemente, siguen vivos, ¿no? Cada año perdemos más de los pioneros del Apolo. Y esto es... Por eso la generación que tocó la Luna se está apagando, ¿no? Y ya era hora de revelarla. O sea que yo creo que esta misión llega en buen momento, ¿no? A partir de esta noche, 28 personas habrán visto con sus propios ojos la cara oculta de la Luna. O sea, se van a convertir en los astronautas 25, 26, 27 y 28 en ver la cara oculta de la Luna directamente con los ojos humanos. Y entre ellos, por primera vez, hay una mujer. Gracias a Dios, mujer, Christina Koch. Hay una persona de color, el afroamericano Victor Glover. Hay una persona no estadounidense, Jeremy Hansen. Y es que hasta hoy, todos los humanos que habían visto directamente la cara de la Luna, aparte, eran blancos estadounidenses, ¿no? O sea que esta estadística cambia hoy para siempre. Ya ha cambiado, de hecho. O sea que... ¿Qué fue antes, el huevo o la gallina? ¿Cuántas veces me habéis preguntado hoy eso? Terraplanismo, lo de que la gente dude de que hemos ido a la Luna, cuando hay innumerables pruebas. Esto da para hacer programas, pero da igual lo que se diga, ¿no? Esto es la famosa teoría de Bandolín, ¿no? Que cuesta más esfuerzo desmitificar esto que... Pero en fin, no vamos a gastar ni un minuto en esto. Lo vamos a dejar por aquí, luego conectamos si queréis otra vez, porque tengo que saltar a otra llamada. Vaya día, ¿eh? Vaya día. Bueno, amigos, vamos a seguir fascinándonos con todo esto. Gracias por seguir ahí. Y luego os acabo de contar... Tengo más anécdotas, ¿eh? Si queréis, luego os cuento lo que Bill Anders dijo por primera vez que vio la cara de la Luna. Luego os lo cuento. Tripulación de Apolo 8. Primera en sobrevolar la Luna. Lo dejamos ahí. Conectamos en un ratito.
and we identified some really unique texture areas as well. At one point, towards the end of the images of my time in window 3, I just had an overwhelming sense of being moved by looking at the moon. It lasted just a second or two, and I actually couldn't even make it happen again. But something just drew me in suddenly to the lunar landscape, and it became real. And the truth is, the moon really is its own body in the universe. It's not just a poster in the sky that goes by. It is a real place. And when we have that perspective and we compare it to our home of the Earth, it just reminds us how much we have in common. Everything we need, the Earth provides, and that in and of itself is somewhat of a miracle, and one that you can't truly know until you've had the perspective of the other. I'll switch into some logistics stuff. The Peltors, both their batteries stopped providing the active listening, but we have verified they are still recording, and so we are able to have discussion time and hear outside our recordings by just moving the ear cup off of the ear. Other than that, everything's working well technically, and we've been able to find all our targets, and we're having a really great time.
Thanks, Christina. We copy those logistics for the Peltors, and also thanks for bringing us into the cabin with you with that description.
Right on time, NASA astronaut Christina Koch, a mission specialist for Artemis II, calling down a science a situation report. Good news, reporting that she and her teammates have been able to capture all targets that were listed. Christina also gave a vibrant description of just how it feels to be there and to see the moon up close and not just something passing in our night sky. Currently, the team members at the window are Reid Wiseman and Jeremy Hansen. Meanwhile,
Integrity cabin team for window shroud.
We're listening. Go ahead, Jenny.
Hey, Victor, we have a temperature constraint on the windows, and the shroud might be getting us close, so we just want to check on the state of window 4's shroud, whether you believe it's still necessary because maybe things have changed with our viewing, and if so, we would like to request to have the shroud removed.
Houston, we believe it is necessary. We pulled it off just as a corner. It is very bright. It definitely would affect our night vision and maybe comfort. But is there a time? Can you tell us when we would have to take it off by?
Unfortunately, since it's been on for a while, we are going to have to request that the shroud is removed, and we can recommend something that could block the light but just create a bit of distance between the window and whatever is covering it. Something like a t-shirt would do the trick and help.
Okay, we're removing the shroud, and we will we'll make it work. Thanks.
Thank you, Victor. We know it's pretty bright in there now with that window uncovered. We will also offer that airflow on the window would be helpful. So if you want, you can also retrieve the condensation hose, which should be friction fit onto one of the diffusers. And that on the window would also help.
We can easily point a diffuser at the window, so we're going to start with that. And it's pointing at the window now.
Okay, we'll take that, Victor. Thank you. Please keep us updated.
That call from Capcom, Jenny Gibbons, CSA astronaut and Artemis II crew backup to the crew aboard Orion, letting them know that they will need to remove the window shroud they had placed on window 4. They initially placed that shroud there to block out some of the light from the Earth. It was extremely bright coming in the cabin and interfering with some of their viewing opportunities out at the moon. This was a request from ground teams to ensure that they are protecting other systems, and the crew has been offered the opportunity to use something else to cover the window. Meanwhile, Reid, Wiseman, and Jeremy Hansen continue with their lunar flyby observations. They have just looked at Glushko crater. That's about when we heard that call down from Christina Koch with that description of everything she had been seeing during her observation period and what she was seeing at that time. The science team asked this crew to take centered images of the entire crater and their ray system in one frame. They're also interested in knowing the brightness, texture, and extent of Glushko's rays and how they differ in the mare, or that sea area, versus the highlands. Glushko is considered a young lunar crater, and these observations can help understand material properties of those craters.
Integrity. First, I wanted to start off with connecting with what Christina said, that it was very moving to look out the window. I had the unfortunate sequence to start looking out the window and then moved to the long lens, and it was hard to speak looking through the zoom because I went straight where Christina went, and I was walking around down there on the surface, climbing and off-roading on that amazing terrain. I also want to underscore something that she said. As we continue to explore, when we actually do go down there to the surface, I know for safety reasons that we would never send someone alone, but I just want to really emphasize how important the discussion time was. When we started to talk, we not only got better science discussion, we got better human connection, and so doing this as a pair, we just learn and grow together, and that's just super important, so thank you for adding that to this plan. Has a similar albedo to the center, but a different color. It has more brownish tones in it, and he said it's very distinct now that he's been staring at it.
Victor, thank you. You got a cheer from science there, and we all just went on that moonwalk with you, so highlighting how important it is to talk about these things. I also want to let you know that we have Deanna Glover with us in the viewing gallery. She's all smiles.
Well, you just got to you cheers up here. Hey, babe. I love you from the moon.
We love that we got a hey babe too, and we also have one of your lovely daughters here watching you guys work.
Thank you guys for doing that and for supporting them through this. And to all of you, Genesis, Maya, Joya, and Corinne, I love you. And Deanna, I love you. I'm glad you get to be there.
We've had some really sweet words from the crew members aboard Orion today, as their families have been able to filter in and out of the viewing room here at Artemis Mission Control at Johnson Space Center in Houston. Victor Glover also giving a great science sit rep and just a description of how it must feel if you were down on the lunar surface while he was looking through that 80 to 400 millimeter zoom lens. He also expressed how important it was to be able to talk through that real time with Christina Koch and stress the importance of that on future missions, that it not only made their discussions better, but also more human. Glover and Cook are in the support roles right now, not taking photos or making annotations at the windows, but they are also encouraged to have their midday meal at this time. For lunch today, those two crew members have options of beef ravioli, salmon, butternut squash, sweet and savory kale, pickled beets, cherry blueberry cobbler, tuna noodle casserole, tomatoes and artichokes, broccoli, and chocolate peanut butter bar. Once Glover and Cook return to the window portion of into their midday meal. Again, this is the third of 5 scheduled blocks for our lunar viewing today, and if you were watching at the start of the broadcast, you can definitely tell the difference in the distance from the moon. We are now 5,518 miles away from the lunar surface, and again, expecting the crew to get about 4,066 miles away. They are currently 252,050 miles away from Earth, and every mile is a new record, having surpassed the Apollo 13 milestone for furthest distance earlier today. If you look down to the bottom right of the moon in that darker looking area, that is Oriental Basin. We have continued to lose views of the near side. It is just barely visible over towards the bottom right side of your screen. And then you'll also hear later about that terminator. That's the line between light and darkness while on the moon. It is really exposing some of those craters at this time. A couple of the other features in view right now are Hertzsprung Basin and Vavilov Crater. Hertzsprung Basin is nearer to the center of the moon, closer to that terminator line right now, and Vavilov Crater is just on the outskirts of it, closer again to the terminator. Towards the bottom of the moon and to the left of the terminator line, or currently shadowed in darkness, is Apollo Basin.
Science from integrity.
Let me find out how far we are from the moon right now. But our view is about a third of the moon is in eclipse. That beautiful Terminator is out there called, and what looked like in the Terminator about a third of the way up from the southernmost part of the Terminator looked like a dinosaur print if one was running to the northwest. Now is clearly a crater with a bunch of craters around it. And that Terminator, I can only see about half of it. I'm looking through the docking hatch window right now because we have the Z9 in window 1. But that Terminator has moved. I guess I've been using Vavilov the whole time, so it's gone 2 more Vavilov craters to the west. And so a few more features are starting to peek out into the sunlight there with that low sun angle, and so you still have ridges and valleys showing up very clearly, a very jagged Terminator, and a few islands of light out there with some high elevation shining in the sunlight in that darkness. And on the eastern side of the moon, let's see, Grimaldi appears to be one of the farthest east features, and that is maybe 5 degrees from being right on the limb and going off over the horizon. It is interesting, just looking at Oriental, that my first impression of it is all of the dark areas appear lighter, which I think makes sense because it is now facing, well, it's still relatively the same to the sun, but my angle to it is different. So I'm looking at it from a little more, even further to the side as we pass it. But all the darker features appear to be just a little bit lighter from this vantage point. The darker ring structure in the outer and inner ring and the interior, as well as the annular ring portion, everything seems to be just a smidge lighter at this point.
Thanks for that description, Ike. Any additional words you can provide on Oriental would be wonderful, as that is such a high priority target for us. And while I have you, as we get closer to target 15, which is the Terminator target, if you can find Zeeman crater again that you were looking at earlier, everything to your left of Zeeman would be getting into the South Pole Aiken area to help you orient yourself.
Zeeman is a great waypoint out there. I definitely see it. Yeah, Zeeman is very easy to find, and that is awesome. Thank you for pointing that out. Feel free to do that as often as you think of things. Let's see, looking back at Oriental. Okay, another thing, after looking through the zoom camera, man, you guys are smart. You probably did this on purpose, but after looking with my plain eyes and then going to the 400 millimeter zoom, now looking at it, I see the cliff face as if you were standing in the center. That inner and outer ring have definitely some real terrain to them, and now I can see that as terrain. Now that I look at it even with my naked eye, I can tell that there's a lot of elevation and that, like I said, a cliff face on that eastern edge where all the darker deposits are. And it's just the scale now. Looking at it from far away before, it seemed like flat with color painted on it, but now that I look at it, I can definitely see that there is, different depositional characteristics, and so the darker is some other material, but there's also some shadowing going on because of the cliff face that is a part of that crater wall.
Great description, Victor. Thanks, and really interesting to hear now the distinction between shadow and color. Before I let you go back to other observations, you mentioned that Reid saw a browner hue to the annular ring than the rest of Oriental. Are you seeing that from your vantage point?
looking at Oriental. Again, I'm still in the docking hatch window. There's like a thermocouple right here in the center of the window, and it is the orange Kapton tape color, and so it is unfortunately it's like trying to look at stars, you know, next to a metropolis. I think it's drowning out any color that I could pick up from the moon. I am not able to see that color, but I have not looked at it through one of the forward face, from one of the windows 1 through 4. I think when I get away from this Kapton tape strip that I would be able to see the variation that Reid's talking about.
That is great feedback operationally. Thanks, Victor. I'll leave you to it.
Science integrity with a question from the window team.
Integrity, this is Science, here with you.
Yes, they have a question to help inform a theory that they're sort of tossing back and forth. What is older, the Mare seas of the near side or Oriental?
Stand by, Integrity. We're going to get you a little geologic history here. Integrity Science back with you for some lunar volcanism when you're ready.
Go ahead.
You're making our day down here getting to talk about lunar volcanoes. Oriental, as far as Mare go, is younger than almost all of the Mare on the near side. The exception are features like Aristarchus, which really pop out to you guys and really pop out to us here on Earth. That is younger, but other than that, Oriental is pretty young as far as Mare go.
And Kelsey, thanks for that. We love lunar volcanism too. How about when the actual crater was formed?
Yeah, we're going to get you an age for Oriental, and while we're getting that, Christina, can you, maybe you've heard the window team talk about the sort of contacts around Oriental, but because that material is so much younger, if anything pops out to you about physical relationship between that and surrounding terrain, we'd love to hear it.
Yeah, definitely. They are discussing a contact relationship that could explain some of the color that they're seeing in certain areas. And so it was really about the ejecta of the creation of the
Pues estamos de vuelta.
understanding
Aquí estamos para seguir contándoos cosas de lo que estamos viviendo hoy, que es un día absolutamente histórico. Y nos habíamos quedado, estábamos contando cosas de la cara oculta, estábamos contando los diferentes misterios, las diferencias entre la cara oculta y la cara no oculta. Estábamos hablando de cuántos humanos han visto la cara oculta de la Luna. Hoy van a ser, ya son 28 humanos en total. Y me había quedado con lo que dijo Bill Anders, ¿no?, de la tripulación Apolo 8, que fue la primera persona en sobrevolar la Luna en una misión tripulada sin aterrizar, igual que Artemis II. Y cuando Bill Anders miró por la ventana y vio la cara oculta por primera vez, dijo por radio a Houston: la cara oculta parece un montón de arena que mis hijos han estado jugando con ella durante mucho tiempo. Está toda picoteada sin definición, como un cubo de arena de playa. Y luego cuando volvió a la Tierra, cuando lo contaba, ¿no? Pero cuando estaba llamando a Houston en aquel momento y vio la Tierra salir por encima del horizonte lunar, el famoso Earthrise, ¿no?, que Wiseman, Glover, Koch y Hansen van a ver esta madrugada sobre la 1:25 hora de Madrid, pues Anders sacó la foto más famosa del siglo XX y dijo: oh my god, mirar esa foto por ahí, ¿no? Eso es la Tierra que está apareciendo, ¿no? Mirad qué preciosidad. Bueno, pues esa fotografía, Earthrise, que está considerada como un icono visual del movimiento ecologista moderno, por primera vez es cuando por primera vez vivimos nuestro planeta como lo que es, ¿no?, como una pequeña esfera frágil flotando en el vacío negro más absoluto, ¿no? Y eso cambió nuestra forma de vernos, por lo menos durante un rato, ¿no?, porque yo no sé si lo hemos rellenado o si eso nos dura a día de hoy. Hablamos de lo de la cara oculta, y de ahí en algunas culturas, en lugar de hablar de cara oculta, se habla de el otro lado. En ruso, por ejemplo, es el lado de atrás, y en chino es la espalda de la Luna. O sea, que cada uno lo llama de una manera, ¿no? Y aunque la cara oculta nunca mira a la Tierra, un astronauta parado en su superficie sí vería la Tierra, pero solo si caminase hacia el borde, ¿no? Justo en el ecuador entre el visible oculto hay una franja de unos pocos kilómetros donde, gracias a un efecto que se llama libración, eso es que la Luna se balancea ligeramente en su órbita, pues se puede ver la Tierra asomándose y desapareciendo en el horizonte de forma rítmica. Es un fenómeno que solo se da ahí, es un fenómeno único en el sistema solar, ¿no? Se llama libración. Y la libración se produce por culpa de este pequeño balanceo, ¿no? Desde la Tierra no vemos exactamente el 50% de la Luna, sino aproximadamente el 59% a lo largo del tiempo. Es decir, que la cara oculta de verdad es solo el 41%, no la mitad. Lo que pasa es que ese 41% nunca lo ves, ¿no?, porque las zonas de los bordes solo aparecen ocasionalmente. Y luego hay otro misterio, que es el de los terremotos lunares en la cara oculta, porque las sondas que han detectado que la cara oculta tiene menos sismos lunares que la cara visible, o sea, y nadie sabe por qué pasa eso, ¿no? Hablábamos también de que el manto es distinto, ¿no? O sea, que podría ser una de las explicaciones. Así que otra pregunta abierta a la que Artemis II puede seguramente contribuir con toda esta investigación, ¿no? Estaba escuchando ahora la radio y estaba escuchando cómo se van turnando los 4 astronautas. Hay 2 en las ventanas, 2 luego cambian, otros 2, y mientras estaban los otros 2 que no estaban en la ventana haciendo fotos estaban comiendo, y han tenido un momento bastante emotivo, incluso aunque han llorado, ¿no? Y han tenido la oportunidad también de expresar lo que han sentido viendo la Luna tan de cerca, ¿no? Y Christina Koch decía, adquiere una nueva dimensión completamente distinta al estar tan cerca y te das cuenta de que al final lo privilegiados que somos en la Tierra, ¿no? De que nos podría haber esperado un destino parecido al de la Luna, ¿no? Y fíjate qué lugar maravilloso en el que vivimos. Bueno, el centro de masas de la Luna no coincide con su centro geométrico. Esto es otra cosa que está desplazado unos 2 kilómetros hacia la Tierra, ¿no? Y esto es otro indicio de la simetría y refuerza la hipótesis de que esa corteza de la cara oculta es más gruesa, ¿no? De lo que hablábamos antes. Y ahora que pensaba y ahora que estaba escuchando a Christina Koch sobre lo que ha sentido al pasar por detrás de la Luna, me he acordado de Frank Borman, que fue el comandante del Apolo 8, ¿no? Que dijo: por unos minutos no pertenecíamos a la Tierra, no pertenecíamos a la Luna, no pertenecíamos a ninguna parte. Es el silencio más absoluto de mi vida. Estábamos literalmente solos en el universo. Y esta noche, hacia la 1 menos cuarto más o menos, pues Wiseman, Glover, Koch, Hansen van a vivir exactamente lo mismo durante esos 40 minutos de blackout, de 40 minutos sin comunicaciones. Pues van a vivir el silencio más absoluto de sus vidas, ¿no? Seguramente. Mientras tanto, en esta página web que he construido este fin de semana, en artemis.orbitainfinita.com, que podéis visitar, artemis.orbitainfinita.com, podéis ver de lo que hablábamos antes de la conexión española, ¿no? Robledo de Chabela, el oído de España en el espacio profundo. La Sierra de Guadarrama, unos 60 kilómetros al oeste de Madrid, hay pues un complejo de antenas gigantes que se llama el Madrid Deep Space Communications Complex, el MDSCC, y lo gestiona conjuntamente la NASA y el Instituto Nacional de Técnica Aeroespacial Español, y es una de las 3 únicas instalaciones en todo el planeta que compone pues ese Deep Space Network de la NASA. Y las otras 2, como os comentaba, están en Goldstone, en el desierto de Mojave, en California, y en Canberra, en Australia. ¿Y por qué en esas localizaciones? Bueno, pues las 3 están separadas 120 grados de longitud alrededor del globo. ¿Y por qué? A mí me encanta la gente que pregunta, ¿y por qué, Pablo, por qué? Bueno, porque así, sin importar cómo rote la Tierra, al menos una de esas antenas siempre tiene una línea de visión directa con cualquier nave en el espacio profundo, ¿no? Así que cuando España se queda de espaldas al espacio, Australia ya está orientada, y cuando Australia se pone, Goldstone ya está apuntando, ¿no? Que es como una coreografía planetaria perfecta. Y en Robledo de Chabela hay una antena que es la DSS-63, que es la campeona, ¿no? como España campeona del mundo. Pues esta es la DSS-63, es un plato parabólico de 70 metros de diámetro, más ancho que media manzana de tu casa, una de las 3 antenas más grandes del planeta para comunicaciones espaciales, y fue esta misma antena la que recibió en directo las señales del Apolo 11 en 1969, cuando Armstrong puso el pie en la Luna. La mitad del mundo vio las imágenes de Armstrong retransmitidas gracias a estas antenas españolas, aunque entonces España estaba bajo Franco y casi nadie lo contó. Pero esta madrugada, cuando Orión reaparezca detrás de la Luna a la 1:25, cuando salgan de ese blackout, hay muchas probabilidades, y lo podéis ver en la página web artemis.orbitainfinita.com, bajáis un poquito y pincháis y lo veáis y lo vais a ver. Pues hay muchas probabilidades de que esa antena DSS-63 sea la que reciba primero las señales de Wiseman, Glover, Koch y Hansen. O sea que España tiene un asiento de primera fila en la historia de nuevo. Y no solamente España, ¿no? El módulo de servicio, la cápsula Orión es estadounidense, pero el módulo de servicio que va pegado detrás es el europeo, ¿no? Se ha construido por Airbus en Bremen, en Alemania, bajo un contrato de la ESA, de la Agencia Espacial Europea, y es el corazón propulsivo de toda la misión, ¿no? Proporciona oxígeno, agua, electricidad, propulsión y control térmico para que no se congelen. Y sin ese módulo pues no se puede ir a ningún lado. Literalmente es el primer vehículo europeo que viaja a la Luna con humanos a bordo. Y es la primera vez desde la creación del programa Apolo en los años 60 que la NASA delega una pieza tan crítica de una misión tripulada a una agencia extranjera. O sea que es un voto de confianza enorme para Europa, ¿no? Oye, hablábamos antes de cosas que nos esperan así, aparte de los hitos, ¿no? De hoy. Bueno, pues la reentrada. Alguien me ha preguntado, me ha mandado un mensaje a alguien diciendo, Pablo, cuenta más cosas sobre la reentrada. Bueno, pues cuando Orión regrese a la Tierra el 10 de abril, en 4 días, van a entrar a 40.000 kilómetros por hora, ¿no? Eso son 32 veces la velocidad del sonido. Para que os hagáis una idea, un Boeing 747 vuela como a 900 kilómetros por hora, un caza F-16 a Mach 2 vuela a 2.400 km por hora, pues Orión entrará a Mach 32, más de 13 veces más rápido que un caza. En un solo segundo recorrería Madrid entero de lado a lado, ¿no? Madrid, España prácticamente. Y el APCOAT, que es el material que les va a salvar la vida, que es el escudo térmico de Orión, está hecho, pues lo inventaron originalmente en el programa Apolo. Pero el de Artemis es una versión que se ha modernizado, que se ha mejorado después de décadas de investigación. Tiene 16 metros cuadrados de superficie, más o menos como una pared de una habitación. Son 186 bloques ensamblados, son bloques ablativos, ensamblados como un rompecabezas. ¿Y cómo funciona esto? Bueno, pues es un material que se quema controladamente. Cuando entra en contacto con la atmósfera, se va desintegrando capa por capa, se va llevando el calor, disipando el calor con cada capa que se pierde, y es como una piel de cebolla al revés, ¿no? Se va sacrificando para protegerlo de dentro. La temperatura pico, como os decía antes, va a alcanzar 2.760 grados, la mitad de la temperatura de la superficie del Sol, que está a 5.500 más o menos. Y lo increíble es que mientras ese escudo aguanta los 2.700 grados, la cabina se mantiene a 22 grados, ¿no? Como poner el termostato. Y hay menos de 10 centímetros de separación, ¿eh? Entre el infierno y el salón de su casa. Pues oye, podría seguir hablando, pero estoy enrollando tanto. Yo no sé si estáis aprendiendo cosas, si os parece interesante. Todo esto nos va a llevar a Marte en algún momento, ¿no? Porque Artemis II no es el objetivo final, este es el concepto clave que tiene que entender todo el mundo, no es el destino, esto es un entrenamiento, ¿no? El objetivo de la NASA es poner a seres humanos en la Luna y luego en Marte en algún momento, ¿no? Imaginad, Marte está entre 54 y 400 millones de kilómetros, dependiendo de las órbitas, y comparado con la Luna, Marte está entre 140 y 1000 veces más lejos, ¿no? O sea que un vuelo tripulado a Marte puede durar entre 6 meses y 3 años, no 10 días. Lo que siempre se intenta, claro, son que sea lo más corto posible, ¿no? O sea que todo lo que está haciendo Artemis a día de hoy, pues es resolver un rompecabezas de futuro, ¿no? Me dice Fernando que mire algo. Explica un poco la herramienta que la meto en pantalla. A ver si veo la herramienta que mete en pantalla. porque yo solo veo una preciosa vista de la Luna. ¡Ah! ¡Qué bueno! Pues fijaos, esta es la web que he construido este fin de semana, ¿no? Aquí, pues tenéis primero arriba los días de la misión, 4 días, 23 horas, 18 minutos. Y luego tenéis la posibilidad de ver la cobertura en directo de NASA directamente. Podéis seleccionar entre las dos cámaras principales. Podéis seleccionar entre lo que es la sala de control y las imágenes de la Orión cuando funciona, porque a veces está en azul. Y un poquito más abajo podéis ver la trayectoria. ¿Veis? Aquí Fernando ha cambiado de vistas. Pero oye, nosotros queremos que os quedéis en nuestro directo, ¿no? O sea, que también lo podéis ver con nosotros. Aquí podéis ver la trayectoria, que además podéis ir pinchando los diferentes hitos, y con ese puntito que se desplaza hacia la derecha o la izquierda podéis ver el recorrido que ha hecho la Orión, ¿no? No sé si Fernando puede moverlo. Esa barra horizontal con ese punto azul, Fer, no sé si se puede desplazar. Yo es que estoy a 7.000 kilómetros de Fernando, fijaos. Y ahí os va contando todos los hitos, ¿veis? Todo lo que ha ido pasando. Y luego arriba, pues, vuelve a hoy, ¿no? Un poquito arriba a la izquierda. Si le pinchas, vuelves a ahora. Luego tenéis toda la cronología de la misión, porque hoy me han llamado de todo, no sé si 15 o 20 teles, de radios, de Pablo, cuéntanos, mándanos cosas. Y digo, pero que lo tenéis todo aquí, que para eso me he currado esto. Pues, ¿qué es lo que va a pasar? ¿A qué hora? Y además os he puesto la hora española también, para que lo veáis. De cuáles son los siguientes hitos. Y si pincháis en cada uno, podéis obtener más información. Veis que hay una flechita a la derecha. Y cuando pinchas, pues se abre una cosa y te lo explica. A ver si Fer puede pinchar en alguno. Ahí, ¿veis? Y además podéis ver las cosas antiguas. Estos son los eventos pasados. Pero luego están los eventos que van a venir, ¿no? Y si seguís bajando, pincháis en cada uno. Y ahí tenéis las explicaciones. Hay algún periodista, de deciros, bastante vago, Alguno no, varios. No voy a dar nombres, está muy feo. Pero es Pablo, por favor, no, cópialo y me lo pegas en un documento y me lo pasas. Y digo, hombre, que yo estoy muy liado. Tenéis clima espacial, si tienen alguna llamarada. Y luego llegamos a lo que os estaba contando ahora, la red del espacio profundo, que si pincháis ahí, cargar en directo esas antenas. Vamos a ver si veis qué antena. Ahí veis la de Robledo de Chabela, y cuando pone A2 es que está hablando con Artemis, ¿no? Y tiene que haber alguna, yo desde aquí no lo veo muy bien, pero tiene que haber alguna en este momento hablando con Artemis obligatoriamente. Vamos a ver cuál es. Es Canberra. Canberra, ¿veis que pone ART2? Pues están en este momento hablando con ellos. No hablando, sino que están recibiendo información de Artemis 2. Y luego eso, a la 1 de la mañana, cambiará. Oye, no me digáis que no mola todo esto, ¿no? Luego tenéis información sobre la tripulación, un poquito más abajo. Podéis ir pinchando Víctor Glover, en qué expedición ha estado, sin enrollarme mucho, pero os cuento lo mínimo y luego hablo un poco del cohete. Y esto de cada uno. Fijaos, Jeremy Hansen, primera misión espacial y va a la Luna, ¿no? Los hay con suerte. Y aquí tenéis el cohete. Y luego, si cambiáis y ponéis artemis.orbitainfinita.com/resumen, no sé si Fer va a poder hacer eso. artemis.orbitainfinita.com/resumen, llegáis a algo que podéis ver en vuestra televisión, ¿no? Que tenemos un directo las 24 horas del día. Tenemos dos directos, este y luego tenemos otro con toda la telemetría en tiempo real, que he conectado con el JPL vía API y estoy capturando sus datos en tiempo real. Hay un pequeño retraso, unos 2 minutos más o menos, que hay gente que dice, oye, no cuadra exactamente, y digo, hombre, son 2 minutos, mira, aquí lo tenéis, ¿no? Y además podéis ver el directo. Si Fernando clica en ese play que hay arriba, también puede ver el directo desde aquí, y luego veis los datos principales. En este momento, hito actual a la derecha, inicio de las observaciones lunares. ¿Cuál es el próximo hito? Que es que a las 18:44 hora de aquí, ya 6 de abril, 7 de abril en España, a la 1:45 de la mañana van a perder la señal. Estamos el día 6 de la misión, vamos al 55% de la misión. ¿A qué distancia están de la Tierra? ¿A qué distancia están de la Luna? Se van a quedar a 6.500 kilómetros más o menos. Luego veis ahí Artemis abajo a la izquierda, ese punto naranja que os dice dónde está, la velocidad actual, y el récord del Apolo ya superado como los humanos que más lejos han estado a lo largo de la historia. Estoy fijándome que ese en vivo, esas noticias en vivo no se han actualizado, así que eso lo voy a actualizar ahora. En cuanto deje este directo, os lo voy a empujar y lo actualizo, que hay aquí programación, o sea que espero que os guste, amigos, y yo creo que hemos pasado un muy buen rato. No sé si conectaremos luego, pero por si acaso me despido de vosotros. Los que sigáis viendo el directo, que disfrutéis. Luego vamos a estar esos 40 minutos sin comunicaciones, así que bueno, si queréis conectamos mañana, vamos viéndolo, pero disfrutar mucho. Quiero dar las gracias a Fernando Sierra desde León, que se ha pegado una paliza pues brutal, preparando el programa ayer, todos los vídeos, el directo del otro día, ahora aquí toda la tarde. O sea, esto es un trabajazo, así que por eso agradecemos que compartáis este directo, que esto es gratis y que todo lo que se saca de este canal se reinvierte en pagar a la gente, en comprar equipo. No se saca ni un duro más para nadie, solo para la gente que trabaja en esto. Y a mi amigo Nacho Sevilla, que ha estado ahí haciendo sus notas como siempre, y que tengáis una feliz noche, que soñéis con la luna, que os asoméis ahora por la ventana a ver si la podéis ver, que es lo que voy a hacer yo esta noche, y pensar, hay 4 humanos que están viendo con sus ojos, se han convertido en el humano 25, 26, 27 y 28 en ver algo que nadie por ahora ha podido ver con sus propios ojos, nadie más, ¿no? Esos 28 privilegiados, pero dentro de poco, cuando compartan las imágenes, los vídeos, las fotos, pues los vamos a poder nosotros también ver. Que seáis felices, acordaos de elegir siempre actos de amor, siempre. Por eso yo esta chapita, no me veis, pero llevo en la camisa siempre una chapa que pone amor, y me preguntan, Pablo, ¿qué significa eso? Y digo que hay que elegir actos de amor, que esto es lo que nos lleva a las estrellas y más allá como humanos, y que todas las peleas, las críticas, eso no vale de nada. Gracias por estar ahí, amigos. Sed felices, siempre.
Artemis II. All of the flight controllers here, each monitoring a different system aboard the Orion spacecraft.
Integrity Houston, we are ready for our cabin and window teams to swap again. We have a 15-minute handover time here, and I have a couple of items I want to read up to you. They'll require you to write something down on your knee boards, so let me know when you're ready.
Okay, Houston, we are ready.
Copy, Integrity. First of all, once you start this next shift here, during this lunar observation shift, we will begin our lunar LOS, so you can expect a call from me a few minutes prior reminding you. And second of all, Fido just sent us updated altitudes and METs for lunar closest approach and max Earth altitude. Let me know when you are ready to write those down. They differ slightly from Optimus.
Thanks, Jenny. We are ready to copy.
Lunar closest approach will be at MET 5 days, 0 hours, 25 minutes, 34 seconds, and the altitude will be 4,067 statute miles. Maximum Earth altitude will be at MET 5 days, 0 hours, 27 minutes, 39 seconds, with an altitude of 252,756 statute miles.
The crew really wants to ask for that in kilometers and in parsecs, but thank you for those. That is great. Thanks for that update.
I'll send Fido to work, and I appreciate the metric. Other than that, I have no new vehicle statuses to pass to you. Enjoy your handover time, and we're looking forward to picking back up with you shortly.
All right, we'll talk to you shortly.
Those words called from Capcom Jenny Gibbons, CSA astronaut and Artemis II backup crew member, to the crew working aboard the Orion spacecraft. Had a little bit of a view inside the cabin. As you can see, it is very dark. The crew has turned off the lights, and the light that you were able to see is coming through the window, a reflection of Earthshine and from the moon. The crew is moving into their next observation block, meaning they are taking time to switch cabin and window teams. We've had Reid Wiseman and Jeremy Hansen at the windows taking pictures and making annotations and recording some audio files that will be downlinked later to the science team. Meanwhile, Victor Glover and Christina Koch were in the background serving as support. They were also timelined to enjoy a little bit of their midday meal. Now that we are swapping positions, the support team becomes Reid Wiseman and Jeremy Hansen. They will be in the background helping with SD card swaps, as well as providing those situational reports to the science team. Victor Glover and Christina Koch will be the astronauts at the window, photographing and speaking into those PCDs, portable computing devices, about what they're seeing on the moon. As you heard Capcom Jenny Gibbons call to the crew, this block is also when we will lose communications with the crew. That LOS, or loss of signal, scheduled to be less than 35 minutes from now. We anticipate to be out of signal with them for about 40 minutes and will regain that communication once they've flown around the other side of the moon. Now, even though the crew will be flying behind the moon, their observation period does not stop. They will still be taking pictures and making annotations of what they are seeing. They'll be looking for the limb of the moon, Earth set, and then Vavilov crater, which we have previously seen. They'll swap positions at the window before moving into a crew choice option. They will get to pick things that are interesting to them on the surface, take pictures, and explain why they find them that way. They'll also be looking for any impact flashes. These are short-lived flashes on the lunar surface caused by impact bombardment. Just before Earthrise, the crew will be looking for lofted lunar dust. This may be lofted just above the lunar surface, and we could only see it just before Earthrise along the dark western limb. Any Earthshine would illuminate potential lofted dust. But once the crew is all the way around the Earth, the brightness of the Earth will wash out any of that dust they might be able to see. These were based on observations from Apollo missions and orbital spacecraft, and so we're very interested to see if the crew might be able to capture some of that lunar dust today. Following that lofted lunar dust target, the next will be Earthrise. We will regain communications with the crew shortly after Earthrise. There will be a short observation break period where the moon is not in view. That's because we are also anticipating the crew seeing an eclipse today. The moon won't be in view because the team here in Mission Control Houston will need to change the attitude of the spacecraft and ensure that its solar arrays are gathering light from the sun heading into that eclipse period. So we will have communication with the crew, we just won't be able to see the moon. However, we will have views during that eclipse time frame. During that time, the science team is looking to know it will only be illuminated by Earthshine at that point, so they want to know what the whole moon looks like overall, but they also want the crew to look into deep space and potentially see if they can spot any planets. Once the eclipse is over, the lunar flyby period will have ended. We are live through the whole thing, and even once flyby is over today, we remain live 24/7 on NASA's YouTube.
Integrity, you got a moment?
Go ahead.
I don't know if Catherine and Devin are still there, but if they are, just wanted to just let them know how much fun we're having out here. It's extraordinary to be on the far side of the moon right now, just seeing hanging out there and looking back at the Earth. And Ashley and Kaylin, I know you're back in Canada, but if you happen to be watching too, just wanted to say hi to all you guys. Love you guys, and we'll be heading back your way shortly.
Thanks, Jeremy. I hear they are watching, and your family is still here. So thanks for passing that along.
this view inside the Orion spacecraft, and it's a little hard to make out, but on the left there, that is Jeremy Hansen, just calling down some well wishes to his family, joining us in the viewing room and watching online. Currently in the window are Victor Glover and Christina Koch. They are taking pictures outside of the window as they are now in their flyby observation block. At this time, Reid Wiseman and Jeremy Hansen are serving as support crew members, and they are also going to have an opportunity to enjoy their midday meal at this time. On the lunch menu today for Reid Wiseman and Jeremy Hansen, we have vegetarian chili, salmon croquettes, chicken with peanut sauce, sweet and savory kale, pickled beets, chocolate pudding, barbecued beef brisket, spaghetti and meat sauce, Italian vegetables, butternut squash, candy-coated chocolates, and maybe even a little bit of coffee. And if you look closely, you can see it looks like they are getting into some of their food for the midday meal. All of the food on the spacecraft is rehydratable. We don't have an option for fresh food as there's not a refrigerated section of the Orion spacecraft. So all of this food can either be rehydrated or eaten straight from the package, just depends on what the food actually is. And for food that needs to be rehydrated, there is information on each package of how much water needs to fill that bag and what temperature it needs to be. We are now 4 days, 23 hours, and 39 minutes, 40 minutes actually, into the flight of Artemis II, the spacecraft now under 4,500 miles from the moon. We are now also under 30 minutes away from loss of signal with the astronauts. We will regain that communication about 40 minutes later. They will still be photographing the moon and documenting what they're seeing while they're behind the moon. And we especially look forward to potential Earthset and Earthrise views. As you can see on the left side of your screen, we are streaming this solar array camera view throughout the flyby. And the science team also plans to capture an occasional still photo with the solar array intermittently, perhaps one every 8 to 10 minutes. Still photos represent the highest resolution imagery from those GoPro cameras. So starting 5 minutes before Earthset and loss of signal, the science team will capture a series of photos, one every 30 seconds, to include Earthset, all the way through 5 minutes after Earthrise and acquisition of signal. In order to capture these frequent photos, the solar array camera that we were streaming will need to switch to time-lapse photo mode. So during this time, the streaming video quality won't be as sharp as you have it right now, but we want to ensure that the science team captures the data that they need during these time frames. And we really look forward to seeing those higher resolution images once they're available. But with the view you are seeing right now, we are sharing bandwidth on the Orion spacecraft with every system that is keeping the spacecraft powered and the crew alive, especially the environmental control and life support system. As this is the first flight with crew, this is also the first flight of a life support system, keeping the crew healthy and safe on the way to the moon and the way home. On the timeline, we're getting towards the end of the cabin and window team swap period, but it looks like our astronauts, Victor Glover and Christina Koch, are already photographing the moon outside of those windows. The next target is Ohm crater, and this is something that they have photographed previously during the flyby. This is a small, complex crater with a prominent ray system, and as referenced earlier, it's the size of the Eye of the Sahara. That Eye of the Sahara is a feature in Mauritania. Seeing this crater more than once throughout the flyby allows the crew to photograph it at different lighting conditions. Those different lighting conditions help expose different portions of the target and can help the science team learn a little bit more about how it formed and what it is today. Again, this view inside the spacecraft as the crew continues photographing the moon outside their windows. They have turned the lights off to allow them to better get photos of the moon, preventing any reflections from coming in from the spacecraft. We expect the crew to be targeting Ohm crater for another 6 minutes or so before they move into a discussion of the limb. Now, the science team has asked for a science sit rep or situation report during that time, so we hope to hear calls from the crew on what they are observing. If you've been following along, at the start of the day, we did have much more of the moon visible. And even just an hour or so ago, we could see about half of the moon. We are now continuing to see more of the far side and that darkness where the moon is not reflecting light from the sun. Earlier, we were also able to see some of those darker portions, that old lava flow that we often see on the near side of the moon and that we can all see from Earth. That has mostly gone away. We are now just seeing very little of Oriental. That's down to the bottom right of the moon. You can see just a small dark portion near the limb. We are now about 18 minutes away from loss of signal with the Orion crew. Again, we use the Deep Space Network to communicate with the crew members when they are this far from Earth. This is the first mission since Apollo when we have had humans on the Deep Space Network. As you recently heard Capcom Jenny Gibbons call to the crew, we expect their closest approach to the moon to be at MET, or mission elapsed time, of 5 days, 25 minutes, and 34 seconds. At that time, their altitude would be 4,067 statute miles above the Earth's surface. Just over 2 minutes later, they will reach their maximum distance from Earth at mission elapsed time 5 minutes, 5 days, 27 minutes, and 39 seconds. The altitude at that time would be 252,756 statute miles. These are our latest numbers, and we'll make sure to verify and confirm those once those milestones have been achieved. Obviously, we will be without communication to the spacecraft at that time, so once we regain communication, we will make sure to find out those numbers and report those to you. Checking in on the lunar targeting package, the crew is now in their discussion of the limb, seeing the limb of the moon, that illuminated part. Currently at the windows taking photos and making annotations are Victor Glover and Christina Koch. We are expecting loss of signal in about 13 minutes. We will regain that signal with the crew about 40 minutes later. A milestone worth mentioning that this day marks the first time in more than 50 years that humans will observe the moon directly, a critical opportunity to practice how lunar science will be conducted during future Artemis missions. I've continued to reference the lunar targeting package throughout this broadcast, which is the primary tool guiding the crew observations, and that consists of two key components. The first of those is the Lunar Geography Review, which helped the astronauts study major lunar features in advance. That also helped them learn to orient themselves during the flyby. The Lunar Targeting Plan provides a detailed timeline of observation targets, background science context, and specific instructions for the picture the crew should take, and verbal descriptions of what will be helpful to the science team reviewing those pictures later. That's what we've been tracking real time and what the crew is using right now to keep up with their next milestones.
Integrity Houston, 10 minutes till the LOS. We'll take a snappy sit rep from the cabin if you have one.
Okay, Jenny, that came, we missed most of that, but just a 10-minute warning, is that what you're saying?
10-minute warning for the LOS, and I'll take a quick sit rep from the cabin, please.
All right, cabin is still full of excitement. We've got Christina in window 2, Ike in Victor in window 3. Reid's actually been trying to get some images out of the docking tunnel. We can see the Earth and the Moon and part of the Moon out of the docking tunnel, which is pretty good. And I'm just grabbing some footage right now with our interior cameras.
Copy, Jeremy. We'd like to know what camera Reid is using and also the status of window 1. Looks like there might be a shroud removed.
Okay. Reid was using the Z9, and the T-shirt shroud is still on window 1, but we took the camera out of it, so maybe that's what you're noticing. But when I looked in there, I saw a lot of sunlight reflecting around.
Copy. That makes a lot of sense to us, Jeremy. I want to remind you, coming up on this LOS, it will take sit reps in the blind, and as more and more of the moon is in darkness, we will take any report you have on impact flashes.
You have to say again your last. There's a lot of conversation here, and I was on the other side of the cabin, so I missed all of it.
Look out for impact flashes, and we'll take sit reps in the blind.
Okay, impact flashes, sit reps in the blind. We got it. And yeah, just so you understand what's going on with window 1, there is light coming through the outer hall from window 2 into the inside of window 1, if that makes sense. Like, I can see the inside of the vehicle when I look between the 2 panes of glass.
Copy.
You're getting your first live look at Orion, the moon, and the Earth. Everyone in this picture. This is a live view from the Orion spacecraft. Currently aboard Orion, 4 crew members: Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen. And on the Earth, all of us, all of humanity. You can see the moon is starting to get a little bit dimmer as the astronauts are going to pass behind it, now 6 minutes and 26 seconds away from that loss of signal. Again, we will be out of communication with them for about 40 minutes until they come around the other side of the moon and we can re-establish contact.
Integrity Houston, you are 6 minutes from your 40-minute lunar flyby LOS. From all of us, it's a privilege to witness you carrying the fire past our farthest reach. Thank you. Godspeed.
Thank you for that, Jenny. And thank you to all of you for allowing us the immense privilege to be on this journey together. It's quite amazing. And as we go on this journey, thinking about the NASA mission to explore the unknown in air and space, to innovate for the benefit of humanity, and to inspire the world through discovery. And as you've gone along on this journey with us, hopefully we're doing just those things. And as we get close to the nearest point to the moon and farthest point from Earth, as we continue to unlock the mysteries of the cosmos, I would like to remind you of one of the most important mysteries there on Earth, and that's love. Christ said in response to what was the greatest command, that it was to love God with all that you are. And he also, being a great teacher, said the second is equal to it, and that is to love your neighbor as yourself. And so, as we prepare to go out of radio communication, we're still going to feel your love from Earth, and to all of you down there on Earth and around Earth, we love you from the moon.
Houston copies. We'll see you on the other side.
We will see you on the other side.
Poignant words from NASA astronaut Victor Glover, and a little bit of a love letter from the other side of the moon all the way to Earth. Glover touching on the teachings of Jesus, including to love your neighbor as yourself. We are now less than 3 minutes away from loss of signal with the Orion astronauts. The Artemis II crew will be out of signal for about 40 minutes as they are on the other side of the moon, continuing their work photographing the lunar surface, and they will re-emerge, and we will also get this view on the other side. Just about a minute and a half now until we lose communication with the astronauts aboard Orion on the Artemis II mission. Now 5 days and 6 minutes since their launch on April 1st. Again, we'll be out of communication for about 40 minutes. And this really beautiful view of a crescent moon and a crescent Earth. How great thou art. "30 seconds now until we expect loss of signal. And we have confirmation of loss of signal of the Orion spacecraft as it flies behind the moon. We expect to regain communications with them in another approximately 40 minutes. This was expected as their spacecraft is now out of direct line of sight with Earth and behind the moon. And this is a poignant moment as it's the first time in over 50 years that we have humans completely unreachable by anyone else on Earth. No matter how distant or secluded, we could reach anyone living on Earth, but while the crew flies behind the moon, it's simply impossible to make contact with them. This is a live view inside the Science Evaluation Room here at Johnson Space Center and just down the hall from Mission Control. This team has been monitoring the flyby all day as the team has continued capturing targets on the lunar surface. We even got to see this team in action as they were helping the astronauts identify some of the features they were seeing on the moon but not expecting. There will be a couple of milestones during this loss of signal. The first will be when the astronauts make their closest approach of the moon at MET 5 days, 25 minutes, and 34 seconds, when we expect they'll be 4,067 statute miles above the lunar surface. Their maximum Earth altitude will be reached just 2 minutes later, at 5 days, 27 minutes, and 39 seconds, when their altitude should be approximately 252,756 statute miles. Once those milestones are reached and we have confirmation, we will report the official numbers. Throughout the Artemis II mission, astronaut voice, images, video, and vital mission data must traverse thousands of miles, carried on signals from NASA's powerful communications systems, the Near Space Network and the Deep Space Network. Let's learn a little bit more.
NASA's Artemis II will send 4 astronauts around the moon, preparing humanity for a long-term lunar presence and future journeys to Mars. Enabling communication and navigation for this test flight are NASA's Near Space Network and Deep Space Network. With antennas around the world and a fleet of relay satellites, the networks will deliver vital data to and from Earth through all phases of the mission. The networks are seamlessly integrated at NASA's Johnson Space Center in Houston, Texas, where Mission Control coordinates the network handovers. These transfers represent a delicate dance between the two networks, exchanging support as the mission shoots toward the moon. On the launch pad and during their early orbit phases, NASA's Orion spacecraft and Space Launch System rocket will rely on communications and tracking services from the Near Space Network. After its translunar injection burn, the Deep Space Network's global array of antennas will serve as Orion's primary communication support during lunar orbit. As the mission journeys farther into space and away from Earth, signal strength weakens and bandwidth is conserved for crew communications. The astronauts will have a near constant connection to Earth, ensuring their safety on a journey farther into space than ever before. We say near constant because as Orion goes behind the moon, a planned loss in communications will occur. The Deep Space Network will be standing by to reacquire the signal as Orion reappears. The Artemis II mission also provides an opportunity to test new capabilities. Using laser links, NASA will periodically transmit Orion data to showcase the benefits laser communications could have for future human spaceflight missions. The data from Orion, sent by radio signals or laser links, is massive. The mission is gathering images, data, and video, while also generating details about mission health and crew voice files. All of that data gets processed here on Earth, where systems compress it for efficiency. In the future, we'll upgrade these systems on Earth so that image and video clarity improve with each moon mission. With the Artemis II test flight, we're evaluating the communications infrastructure that will help carry us into the future as we explore the moon and journey forward to Mars.
We are now about 33 minutes until we expect to regain communications with the astronauts aboard Orion. And in the meantime, I've got Dr. Kelsey Young, Artemis Science Flight Operations Lead, here with us. Thanks for joining me, Kelsey.
Thanks for having me. This is such an exciting day.
Oh, no kidding. It has been so cool to hear you communicating directly with the crew. And I know that you have been preparing for this for years, so I am so excited for you and for your team. So just to get into that background a little bit, tell me about your background and what you've been doing on console.
My background is as a field geologist. Actually, I studied impact cratering in the field for my PhD, so all these descriptions of impact craters have me just absolutely swooning. How I got into this, though, is, during my PhD, I got an internship at NASA and ultimately never left to integrate science into flight operations. So we developed the Science Officer Console, for which this is the first mission we're supporting. We developed the Science Evaluation Room that's right upstairs, and so it's so gratifying to see this operation structure come to fruition, especially on a day like today.
I would have to imagine so. And we've got a great view of the Science Evaluation Room right now. Is there anything that has stood out to your team so far?
Absolutely. So as you might have heard in some of the press briefings and content that, we've been putting out, color and albedo were really exciting targets for us. We've heard several amazing color descriptions so far. Just to highlight maybe one of them, we heard about greenish and brownish hues near Aristarchus, which is actually a feature that we can see here from the near side. And those greenish hues could actually tell us something about the volcanic evolution of that area. So you can bet that the science team is going to be prioritizing downlinking those images and the crew audio that we didn't hear that went into those recordings to learn a little bit more.
Wow, that is fascinating. I was hearing those colors and very interested just from a personal standpoint, because looking at the moon from, 250,000 miles away, we don't see green or brown. So just hearing that, them being so close and getting to see that, fascinating, and I know very exciting for you. So what are you expecting to see in the upcoming portion of the flyby?
The upcoming portion is actually going to be really exciting. So right now, as we speak, while folks in the room are kind of taking their, their stretch breaks and everything, the crew are still hard at work. They still have targets to image and describe during this LOS. But when we come out, the first thing, of course, we're going to hear about is Earthrise. We're really looking forward to hearing about the crew's experience with something that we can connect with and that, Apollo 8 brought us such amazing images from. But then we start to get into describing the Terminator, as well as looking for things like lofted dust, which tell us about the modern lunar environment. Then the vehicle's going to orient away from the moon for an hour and then pivot back for the eclipse observations, which is a whole different set of science observations that we're really looking forward to.
It's kind of nice that the crew will get a little break in there, because they have been hitting it hard today with photos and videos and annotations. What are you hoping that the crew sees coming up? Is it that lunar dust?
Oh my goodness, that's a hard question to answer. I mean, we've already gotten such great descriptions. I mean, the Terminator seems to just be like one of their favorite things to look at and describe. So I feel like, that was something we were looking forward to. I feel like we've really gotten some great descriptions. So absolutely, I'm looking to the human moment of Earthrise. Lofted dust is an exciting one, and lofted dust will be a target for them in the right around the time of Earthrise, but again in the eclipse period. So I'm really looking forward to seeing. I mean, they've already highlighted just in the course of their flyby so far how the moon has changed, and this is going to be an even more dramatic change to go from their end of this kind of lunar illuminated piece of the flyby into the eclipse time frame. And I can tell you they're going to be experiencing a very different moon during that time, and I can't wait to hear what their observations are.
Yeah, that's absolutely fascinating, and what a privilege that we get to do that on this mission, because that's not always the case. If we had launched on a different day other than April 1st or 2nd, we wouldn't have gotten to see that eclipse. Is that right?
That's correct. April 1st and 2nd. I will say, I was asked a lot in the weeks leading up to the launch, well, what's your favorite day? And my answer truly was, there is no bad day to launch to the moon. We were going to get great science out of it no matter what, but it's a really neat opportunity to, bring the sun into the picture, bring different planetary bodies into the picture while still literally keeping the moon in center stage.
Fascinating. So what differences are we looking for at each site? We're hearing a lot of different terms. We're looking at craters, we're looking at mare. What are the differences that you're hoping to see?
We do have, as you highlight, kind of different prompts for each target. That's what they're looking at in their lunar targeting plan, which I know you've been showing. And we have even different prompts for the person with the, the really long lens on the camera versus the people with the unaided eye. And you've heard the crew talk about, oh my goodness, when I go from one to the other, I can really detect different nuances. And that's something that we experienced in simulations, but hearing them actually, see it for real has been really gratifying. But we're looking for different things based on the target. Sometimes we're looking for color. Sometimes we're looking for texture. For the Terminator, we're looking at kind of what texture and morphologies pop out to you and what kind of diversity you see along the Terminator. You've heard, Victor especially make some comments about future impacts for exploration. So already I think that their descriptions in this first part of the flyby have told us something scientifically, but also about future surface missions.
Well, it was so interesting to hear Victor talking about he was imagining in his mind's eye being down on the surface and walking around. That was very cool to hear. And when we're thinking about targets, I know some of them are determined based on the launch day because that determines the lunar illumination. So the ones that we're looking at today, how and why were these selected?
Such a wonderful question. This really gets at at the heart of some of our really highest priority science questions. Illumination conditions is a big one, right? So of course we need the targets that we're interested on the lunar feature to be illuminated by the sun in order to view them, but the timing in which they see them during the flyby enables us to ask different questions. So you heard in the pre-flyby crew conference talking about, well, the same pair, Reid and Jeremy, will get to actually look at Glushko crater twice, and that looking at it from different illumination angles allows us to understand that feature better and connect color and albedo with topography and morphology. Then you have other craters where you want to look at it with the sun shining on it obliquely versus straight on, and that tells you something different about the scientific objective that drove the target being on the targeting plan in the first place.
We've talked a little bit with the viewers today about what the crew is able to capture in this short time frame of those craters in different lighting conditions. Could take years for something robotic to be able to do based on attitude maneuvers and where the sun is at. So can you just talk a little bit about the importance of having both the robotic operation and having the crew?
Absolutely. We definitely don't want to minimize the impact of orbiting spacecraft. Lunar Reconnaissance Orbiter is the one that's often referenced. Data from LRO and its payloads have really been instrumental in getting us, frankly, to this point for Artemis II and future missions. But the human experience, the crew observations that we've already been hearing about, it is such a perfect complement to the orbiting spacecraft data because they are able to have this unique perspective. They are far enough away where they can make these contextual observations. You've already heard it. How many times have we heard the crew and their science sit reps say, if I track this feature from all the way up here in the northern hemisphere down to the southern hemisphere, here are comparisons I can make. That right there is not something we had the ability to do with the Apollo missions, and it allows just literally in the blink of an eye to synthesize observations that it would take, a really significant effort to coordinate with different orbiting platforms, and they're making it like that.
Wow. It has been very, very exciting to hear all of their calls so far. And so I've heard they were able to capture every single target so far too. Is that correct?
I think that's correct. And I think it's important also to remember that, and I know the science team is anxiously awaiting this, we've been hearing from the crew members who are not at the forward windows, right? Those crew who are, really in the thick of the observations, they are recording minutes-long observations per target on their crew tablets. We will be getting those down starting here in a couple hours, and that's going to contain really meaty science information that we haven't heard live yet, and that's going to form the basis of my conversation with them tomorrow morning, where we're going to have a really deep dive into the science and absolutely nerd out about what they were able to do today. One of the most gratifying things for me today is hearing multiple crew members say, thank you for putting the discussion times in the targeting plan, because when we have had the ability to put multiple brains on a problem, we have elevated each other. And I'm looking forward to them, sleeping on it overnight and then us actually being able to really, truly have an elevated science discourse tomorrow.
Well, we're looking forward to it too, and I cannot wait to hear everything that you guys get to learn overnight from some of those audio recordings and just everything that they'll be able to share tomorrow. So Kelsey, I know you are very busy. You've done a great job today, and thank you so much for joining us for this interview.
Thanks for having me. It's such an exciting day.
We are now expecting acquisition of signal in about 24 minutes. As a reminder, the Orion spacecraft has flown around the other side of the moon, where they are out of contact with our deep space network. And we just heard confirmation here in Mission Control Houston that we have reached the closest point of our destination to the moon at MET 5 days, 25 minutes, and 34 seconds. And we anticipate the spacecraft's altitude is approximately 4,067 statute miles above the moon. We're continuing to track what the crew is doing while around the other side of the moon. They are continuing to take pictures of the Earth, of the moon, the Earth now out of sight. What they are in right now is a crew choice event. The science team has encouraged them to find interesting features on the surface, to take photos of those, and describe why they were interesting. Something else that they'll be looking toward next, just momentarily, will be impact flashes. They've got a few minutes allotted to look at the darkest portions of the moon. They're interested in short-lived flashes on the lunar surface because these would be caused by impact bombardment. After their impact flash targeting, the team is interested in if the crew can see lofted lunar dust. This would only be visible just before Earthrise. Now 20 minutes until we expect to regain communications with integrity and the astronauts for Artemis II. We're live in Mission Control Houston at NASA's Johnson Space Center, but there's a team over 750 miles away also monitoring today's operations. And of course, just like us, they are in LOS, or loss of signal, with the spacecraft. This is LUCA, the Lunar Utilization Control Area, and it's joined by LISA, the Lander Engineering Support Area, which are twin control rooms that will support missions and operations in lunar orbit or on the moon's surface in real time at NASA's Marshall Space Flight Center in Huntsville, Alabama. The Luca and Lisa are right next to each other and just a short walk away from the SLS Engineering Support Center, which is used during launch, and the POIC, where science on the International Space Station is monitored. Luca primarily supports Artemis science operations, while Lisa will provide engineering support for landing astronauts on the moon. During this mission, Artemis II, teams in the Luca will use the facility to support first-of-its-kind science operations to better understand the deep space effects of microgravity and radiation on the crew's physiology, immune systems, and ability to complete various tasks. The data from these science operations will inform future crewed flights to the moon. For future crewed missions to the moon, members of the NASA Human Landing System Mission Insights Support Team, a group of engineers, safety leads, flight operations experts, and technical authorities will work in the LISA. There, they will monitor lander systems in real time and be involved in key decision-making processes throughout the mission. Teams are using the LISA during Artemis II to observe mission operations and using the opportunity to inform and prepare for future crewed landings to the moon's surface. We now expect to regain communications with the astronauts aboard Orion in about 17 minutes. In the meantime, a little overview of how our crew members flying by the lunar far side at an altitude of between 4,000 and 9,000 miles are testing the capabilities of the Orion capsule. Artemis II visualization lead Ernie Wright has simulated views of the flyby using detailed topographic maps of the lunar terrain and photorealistic lighting scenarios. The Artemis II crew members have been using these visualizations to prepare for this historic mission, which is paving the way for future exploration of the moon's surface and beyond.
So the most exciting thing to me about Artemis II is just the return to the moon. We haven't been there in 50 years. Human eyes are going to see parts of the moon that haven't been seen by anyone before. It also recommits us to exploring the solar system in a way that we haven't in a long time. And I think it provides an opportunity for younger generations to understand the excitement of doing that kind of exploration. Artemis is our return to the moon after 50 years. The emphasis of Artemis is going to be, first of all, science, but second of all, learning to sustain a presence on another world. First on the moon, but we're hoping that that's a stepping stone to Mars and other destinations in the solar system eventually. Artemis II will be a flyby mission. It's not going to land. We're testing all of the technology that we've created for flying to the moon since Apollo. A lot of systems have been modernized, and we need to make sure that all of those work. The astronauts will be looking out the window at parts of the moon that have never been seen by human eyes before. They will be flying by the moon at an altitude that's much higher than Apollo's orbits. And so they will see the entire disk of the moon, including areas that are closer to both the North and South Pole that astronauts from Apollo never saw. All of that depends on the lighting, which we really won't know until launch day, but we can practice with different lighting scenarios. It's hard for people to sort of picture that in their mind. If you can make a visualization of it, show them a movie, that helps everybody choose the targets and also practice aiming at those targets. The astronauts have actually been looking at these visualizations through the lens of the camera and practicing aiming at the various targets. This is a map of the surface of the moon, obviously, but it shows what the Apollo astronauts could see in sunlight while they were in orbit. The brighter parts are the parts that they could see. The darker parts, like this entire area here and places that are farther north and south, are places that they couldn't see in sunlight, either because it was nighttime there or because it was beyond the horizon of the astronauts. All of the Apollo flights orbited the moon at a distance of about 110 kilometers. Because the astronauts were flying at such a low altitude, their horizon was actually quite close, and they couldn't see the North and South poles. And this whole area over here was not in sunlight at the time. And it includes this amazing impact feature here called Oriental. Oriental is a very large impact feature. It's about 650 kilometers wide. It's got multiple rings. These are rings that form like ripples in a pond from the impact, but of course it's on a huge scale. The middle of Oriental has that sort of dark basalt lava covering it, like the dark spots that we see on the near side. It's one of the biggest ones that's more on the far side than near. So seeing it with human eyes and sort of picking out features that maybe you don't even see in robotic cameras is an important goal for the mission.
This live view in the Science Evaluation Room, or the SIR, here at Johnson Space Center in Houston, Texas, just down the hall from where we're at in the Artemis Mission Control Room. Teams continuing to monitor the flyby. The crew continues their observations of the moon, even though they are out of touch with Earth. We expect to hear from them in 12 minutes and 26 seconds. Again, this is approximately 40 minutes loss of signal while they are out of reach of the Deep Space Network. Right now, they are imaging or attempting to image lofted lunar dust. Throughout our coverage, we've talked a lot about the science and engineering behind today's lunar flyby, but we also spoke to the crew about what the moon means to them and how they see its place in human history.
I remember being a little kid lying in bed at night and just looking out at the moon and whatever phase it was in, I was thinking, man, my friends that live like 20 miles away, they can probably look out and see that same exact moon. And then when I was in the Navy and I would look out at the moon and I'd be halfway around the planet, and I would think, man, my brother can see that moon where he is, and he's halfway around the planet from where I am. And it's a connection of life on Earth. We can all look up and see that moon.
It represents history. It is a witness plate. Everything that's ever happened to the moon is still written on the moon. There's no processes of wind or change in the Earth, geologic processes like we have here that change it. And something that's been telling and can read out the story of its own evolution, there's something beautiful about that.
I've also learned from my indigenous mentors that they refer to the moon as Grandmother Moon. So you've probably heard of Mother Earth. They use Grandmother Moon because Grandmother Moon is responsible for the water in their community. The grandmothers, sort of protect the water source, just like the moon moves the water around the planet, affects the tides. It's something that represents something different for each individual culture around the planet. And that's really neat because we all share that same moon in the night sky.
We all have seen the same side of the moon in different lighting conditions our whole lives. And so it seems very familiar to us, but it's also kind of unknown. When we get up close, some of the imagery that we'll get to describe and to share with people will be very unique. And that nature, both of those things being true about this one entity that we all know, just is really special.
It's just the epitome of a symbol of both something that's in each of our hearts, but that's also represents exploration and reaching.
You're looking at a live view inside Artemis Mission Control here at Johnson Space Center in Houston, Texas. We are currently out of contact with the Artemis II crew. This was a planned, or not really a planned, but a tracked loss of signal that occurs when the crew flies behind the moon. We use the Deep Space Network to communicate with the crew, and when they are behind the moon, they are out of reach of that Deep Space Network. And when you consider our nonstop communications during the time in which we live, this is even more striking. For the Artemis II crew, they're only currently communicating with each other. Now, we expect to regain those communications in under 9 minutes from now, and we also are hopeful for a view of Earthrise. Despite being out of communication, the crew is continuously capturing imagery of their predetermined lunar targets. Now about 7 minutes, 25 seconds until we anticipate regaining communications with the Artemis II crew aboard Orion. In the meantime, Artemis II lunar science deputy lead Marie Henderson is trained these astronauts to capture and document their views of the lunar surface for all of us to enjoy back here on Earth.
I cannot wait to hear their voices when they get to the far side of the moon and I can hear them talk about seeing the moon out their window. I try to imagine it now and just like tear up thinking about it. Ooh, now I gotta hold on a second. We have human eyeballs connected to wonderfully smart brains our astronaut friends have. They are going to be able to observe the moon in multiple different ways. They can use their eyes, they'll look through their camera and snap pictures, and just looking out the window getting that human experience. But during Apollo, the astronauts were so much closer to the lunar surface. Our astronauts are going to be doing a flyby at a higher altitude, so they're going to be able to see the whole moon as a lunar disk on the lunar far side. That's a brand new, unique perspective that humans haven't been able to look at before. We are doing a lot of lunar geography training with them. They have study sessions and quizzes they can do that are assigned to them. You know, even if you're an astronaut, you still get homework. We actually get in the mock-up. In that enclosed physical space, we have to think through the hardware that they have, the cameras, the computers, their microphones to make these observations. There's 4 windows up front. Through one of those windows, one of our astronauts will be using a Nikon D5 camera with an 80 to 400 millimeter lens. So something that allows them to zoom in really far and actually take more detailed observations of the surface. It's almost like looking through a pair of binoculars as well. It's just like being a geologist out in the field. They're telling us what they're seeing, looking for colors, textures, different morphologies, and comparing the region that we're having them look at to the regions that are around them. We have a science team that is planning the targets that are going to be observed, putting them all on the timeline of how they're going to be observed, and then taking the first look at the data when it comes down. The Apollo astronauts were only on the moon for 300 hours total, and they only went to the equator. That's like going to places that were safer landing sites, and they only saw so little, 300 hours total. And so we have so much more to explore and so much more to learn, and we are the beginning of the next generation that gets to start being a part of these discoveries.
We are now 4 minutes and 28 seconds until we expect to regain communications with the astronauts flying aboard Orion on the Artemis II mission. They are now flying behind the moon. While behind the moon at an MET, or mission elapsed time, of 5 days, 25 minutes, and 34 seconds, we expect this was the point in which they made their closest approach, 4,067 statute miles above the lunar surface. We're live in the Artemis Mission Control Room in Houston, but we are not the only room monitoring today's flyby. As you can see, this is the SIR, the Science Evaluation Room. It's in the same building and just down the hall. It's a multidisciplinary science team supporting the Artemis II crew in real time, including experts in lunar geology, impact cratering, volcanism, polar science, imaging, and visualization. You can see the SIR here. That's the Science Evaluation Room. It's embedded within Mission Control to provide science input during live operations like what we see today. But additionally, the Science Mission Operations Room is a back room that processes data, evaluates imagery, and supports rapid analysis. We also have our science officer, Kelsey Young, here on console today. She's serving as the primary interface between the science team and the flight controllers, ensuring science priorities are represented during mission execution. Coming up on 1 minute and 36 seconds until we contact Orion. Meanwhile, aboard the spacecraft, the crew has continued executing their lunar flyby tasks. As we discussed earlier today, these activities have been precisely timelined, and this is the fourth of 5 blocks of time during which the crew will be observing the moon from Orion's windows. At this time, pilot Victor Glover and mission specialist Christina Koch are observing the moon at windows 2 and 3. One crew member is in window 2 with a blue shroud over the window, taking photos and using an 80 to 400 millimeter zoom lens, while the other astronaut is in window 3 using their portable computing device, also known as a PCD, to make annotations. And both of those crew members are making audio recordings of what they are seeing. They are wearing headsets connected to their PCDs, and those audio recordings are being sent to the science team tonight. We are not hearing those live. However, we have been hearing quite a lot of great descriptions from the crew who have been serving as the support. Right now, the support team members are Reid, Wiseman, and Jeremy Hansen. Those team members are providing science sit reps, situation reports, calling down a few times each hour to discuss what they're observing. And even though we're out of contact with them right now, they are still conducting those science sit reps as they'll be available once they come back around the moon. The situation reports include how the crew is positioned, any missed targets, or anything unexpected they saw. They're also including lunar target descriptions, any hardware issues, and their emotions and reactions. Again, we are standing by to acquire signal from the Orion spacecraft. We're in the Artemis Mission Control Room at Johnson Space Center, getting our preliminary contact with Orion, that acquisition of signal coming after a 40-minute loss of signal, during which the crew was flying behind the moon, out of contact with anyone on Earth. We are getting our first views from Orion after the loss of signal. Orion has come back around the other side of the moon, and that little crescent that you see is Earth, over 252,000 miles away. With this transit complete, lunar flyby continues, but Orion has also technically begun its journey home. Right now, the crew are getting a few moments to enjoy and take photos of Earthrise for themselves, and we expect to contact them shortly. But we do have good signal coming from Orion. This view from inside the Orion spacecraft, all 4 astronauts now back on the other side of the moon and in contact with us on Earth. Their tasks for lunar flyby did not stop as they went behind the moon and out of contact with us. We anticipate during that time they were attempting to image some impact flashes, short-lived flashes on the lunar surface, which would be caused by impact bombardment and potentially even lofted lunar dust. Right now, of course, they are getting pictures of Earthrise. After this target, they will get a short observation break. It's about an hour long, actually.
Houston, integrity, comm check.
Integrity, we have you loud and clear. How many?
Houston, we have you the same, and it is so great to hear from Earth again. To Asia, Africa, and Oceania, we are looking back at you. We hear you can look up and see the moon right now. We see you too. When we burned this burn towards the moon, I said that we do not leave Earth, but we choose it. And that is true. We will explore, we will build ships, we will visit again. We will construct science outposts, we will drive rovers, we will do radio astronomy, we will found companies, we will bolster industry, we will inspire. But ultimately, we will always choose Earth. We will always choose each other.
Integrity from Earth, our single system, fragile and interconnected, we copy. Those of us that can are looking back.
We are happy to say we copy.
Those first communications back with the astronauts aboard Orion. Christina Koch calling back to what she said just before translunar injection burn, that with this burn, we do not leave Earth, we choose it. The translunar injection burn served as not only what put them on this trajectory to fly around the moon, but what also committed them to splashing down in the Pacific Ocean on flight day 10. At this time, the crew is entering an observation break. We expect this to last about an hour, and it's probably a welcomed break following their very, very busy day taking pictures, making annotations, making audio recordings, and communicating all of the wonderful things that they are seeing on the moon. This observation break is also partially due to the fact that we will be entering an eclipse later. This will be the first solar eclipse that humans have seen from the moon. The astronauts will need to wear eclipse glasses for the first 2 minutes until the sun is completely covered by the moon, and then they have additional targets that the science team is hoping that they will photograph. We will have communications with them during that eclipse time frame. Because of that eclipse, Orion's attitude must be changed right now so that its solar arrays are in the sun. This will help it charge the batteries needed to power it through that eclipse time frame. This view on your screen is a visualization. The spacecraft now 4,224 miles away from the moon, and that number will now continue to grow, while the number of distance from Earth, 252,699 miles, will continue to shrink all the way until our crew is back home. Again, we are MET, mission elapsed time, 5 days and 58 minutes since the launch of Artemis II. We have reestablished communications with the crew and the Orion spacecraft, now entering a little bit of a break while they are out of visibility, or the moon is out of their visibility. The spacecraft will be reoriented to view the moon ahead of an upcoming eclipse. This current attitude maneuver helps charge the solar arrays and batteries aboard Orion that will power them through the eclipse.
Integrity, Houston. In mission control, all of your flight controllers and your flight director have flipped There are Artemis II patches around. We are earthbound and ready to bring you home.
That's great. See the light of day as we head back to sea.
A very special moment just now in mission control ahead of the crew's flight to Kennedy Space Center, and during one of their last sims or simulations here, they visited the mission control team in Artemis Mission Control in Houston and brought us each a patch. Everyone in the flight control room has had these on their signifiers at their console. On one side of the patch that you've probably seen is the moon with the Earth behind it. Now that we've passed behind the moon and we are returning home, the flight control team has instructed everyone in the room to switch their patch around so that the Earth is closer and the moon is behind us. We are really looking forward to seeing the Artemis II crew, and the Capcom Jenny Gibbons did call that update up to the crew that the flight control team here has turned their patches around as was instructed by the crew during that last sim, and we are counting down the days until they get home. They are now 5 days, 1 hour, and 3 minutes mission elapsed time into the Artemis II mission. Joining me here in the room, Artemis Mission Control, I have Angela Garcia, Artemis II Science Officer. Thanks for being here, Angela.
It is an honor to be here. What a day. Everyone's been buzzing. I can't contain myself. So it's been a really awesome day.
So you're sitting on console at the Science Console now. Have you been in the SIR earlier today?
There's a lot going on. So I went here first, and then I'm going to go there after.
Clear, Houston.
All right, Integrity, we hear you. That was a little clipped, but I think we have a better link now. We experienced some blockage from a solar array. We moved it, and we are in bias tail to sun.
Okay, Houston, you're coming in loud and clear, and copy, we're in bias tail to sun now.
Affirm and Integrity, just so you know, we did not hear your response once we flipped our patches. Jeremy, we heard you call down, but you were clipped, and then we briefly lost comm. Glad we're back.
Okay, copy that. We were just excited that we got to share in that you, the MER, and Mission Control flipped your patches around, and that side of the patch is getting to see the light of day. Thanks for sharing that with us.
Our pleasure.
Okay, Angela, so can you tell me a little bit about your role supporting Artemis II and the science preparation for the mission?
Yes, so I'm one of the 3 science officers. So Kelsey's been on console all day. I'll take over kind of closer to the end of the day. And then Trevor Graff is on the planning shift. And so it's the 3 of us in this 24-hour cycle supporting the mission. And so the science officer console is a brand new console to Mission Control. And it's not every day that you get a new discipline incorporated into Mission Control, so it's been such a significant milestone for us. And it's just a testament to like the commitment that the Flight Operations Directorate and NASA have, that they're going to be integrating science and maximizing science throughout Artemis. So it's really exciting. And then the science preparation. So I'm on the operations team, but I'm also on the training team. So all the incredible training and shout outs that you've gotten today, it warms my heart. It warms everybody's heart in the science evaluation room. I promise you that. But so all the classroom training, the field training, the mission simulations, right? We were part of all of it, and that is what we did to get the crew to be. They are a part of the science team, and they are the forefront, that nice edge, and they're just been doing such a great job today.
I know. I imagine that you have to be pretty proud of them. Their reports have been fantastic. So I would like to know a little bit about how you have developed procedures for this crew. What kind of science activities are they carrying out inside the spacecraft?
Yeah, so the procedure development has been a unique challenge. I would say the exploration science that we're doing is inherently pretty flexible, and operations is, I'd say, inherently has more structure and rigidity. And so to marry the two and to operationalize the science that we want to get done has been a challenge. But I think we've been able to go through these processes and create good products at the end and have a good plan. And yeah, it's been really great. What was the second part of your question?
Just what kind of these science activities that they're performing, which of those have you really had a hand in?
Yeah, so a lot of the procedures help organize what the crew is doing in the cabin. And I know we've talked a lot about what they've been doing, and they've been doing a lot, and it's been a little dark, so I can re-explain what some of those things that they're doing. So the observation blocks are about an hour long, and the crew is organized, the 4 crew members are organized into 2 pairs of 2, the window team and the cabin team. And the lunar targeting package that you've been showing up and that the crew have on their handheld tablets is really the instructions for the window team. So the window team, the 2 crew members are looking out the window. One has the camera with the long lens, one has, they're just looking out the window with their unaided eye, and they're taking these detailed observations. And then halfway in that observation block, they do the window team position position swap. So that's what you've been, what Capcom's been calling out, and they'll switch positions. So each crew member has a chance to have that long lens, and then that's just what the window team is doing. There's also the cabin team where they also have duties that they're doing. We're asking a lot of the crew in this time, and then the cabin team, they have the interior camera and they're taking images inside the cabin. They're also supporting the window team where, you've heard some call outs where looking out at the bright moon and then looking inside the dark cabin and looking at their LED screen is a lot. So the cabin team is also helping support, target, and guide the window team into specific targets on their plan. They're also helping call out these science situational reps. So they're looking out a different window and listening in to what the crew who are really down and in the science on the window team are doing, and they're giving us insight. And those recordings that the window team is doing are going to be uplinked or downlinked overnight, and we're going to be able to chew on that data. But yeah, they're helping. They're doing a lot. And so making sure we have a plan that's flexible, but also make sure that we check off all those boxes was really important.
So tell me a little bit more. You talked earlier about the analogs that the crew has done. What kind of analogs or environments were really useful for this?
Yeah, so for procedure development, right, you have so many different environments that you can do. You have classroom, like we said, you have the Orion mock-up, you have simulations, and at least for developing the plan, we kind of did it in a tiered approach because each of those different analog environments helps us answer a slightly different question and has a little bit of a higher fidelity. So we would start with the classroom. So we would get we would just get into a classroom, we would put all the hardware on the table, and then we'd almost role play of like, you be Victor, you be Reid, you be Jeremy, and I'll be Christina, and like, let's just do the plan how we think we should do it, write that down, and then just keep iterating on that, and then...
Integrity Houston for a tag up pre-forward link LOS in place of the Flight Director Conference.
Okay, Jenny, we're ready.
All right, crew, I'm going to roll through a couple of topics here. The first two are for timeline. First of all, Reid for your toilet maintenance. It is a shortened toilet maintenance where you do not have to do the oxone changeout. That portion of the procedure is canceled. Victor, you have an HHP stop activity on your timeline. We need you to perform that as scheduled for bandwidth reasons. For your next portion of the flyby, in particular the eclipse, we want to remind you that you can take off the eclipse glasses when the sun sets and you are simply looking at the corona. And then finally, for the D5 with the long or zoom lens, which is set for solar corona, we want to remind you that when you are capturing Earth shine, you will likely have to adjust the exposure. That's all I have for you. Let me know if you have anything for us.
Okay, Houston, we copy all. Thanks for those words, Jenny.
All right, just a quick call up to the crew ahead of a forward link LOS, meaning that we won't be communicating with them, but we will be receiving their communications and data during that time frame. So Angela, we were talking about analog environments. You were telling me about the classroom and getting in there and pretending who's Victor, who's Reid. Tell me more about this.
Yeah, it works pretty well. So you're going to do the plan how you expect it to be, and then once we finalize that plan, we'll give it to a completely new group of people and have them practice it, and then they'll be like, these steps don't make sense, and we'll reiterate on it over and over. And then we'll take it to a higher fidelity environment like the Orion mock-up, and we'll do the same thing because that volume is smaller, the window placement, their seating, what things have we forgotten with this addition of this this environment. And then once we reiterate on that, we'll take it then, we'll give it to the crew and have them execute off of it during mission simulations. That's the highest fidelity that we can do before we send it to space. So is the first time we've had to do this because we're a brand new console. And it just sparks so many neurons of like, how are we going to do this for surface missions and integrate this in so many different ways. So excited to have kicked off this process, but there's so much more to come.
Fascinating. And I think it was really well thought out too, because each crew member gets an opportunity to do each task. And so you're getting different perspectives and different insights from each crew member, maybe even about the same target, but something that one person sees could be completely different than something another person notices. So we also know that Artemis II has traveled. They're now on their way home, but they traveled farther from the moon than the Apollo missions did. So what makes that vantage point scientifically interesting?
Yeah, observations are so fundamental in the scientific toolkit, particularly observations from different perspectives, different scales, and with different techniques. And so for this, so we really tried to make the plan to optimize those. There's pros and cons for all those things for this mission. So we really just focused the plan to have all those pros. So in terms of scale, this zoomed out scale, you can learn different things. This different perspectives. So their perspective, as Kelsey talked about, photometry around when they orbit the moon. And then also just their different the different things they're able to observe. So yeah, let me talk a little bit about scale, because I think observations at different scales, you can gain a lot of different information. So like, for example, if you were an astronaut on the surface looking at a rock, and you describe at this micro scale. So in training, we kind of talk about observations from micro to macro, or from outcrop to orbit. So looking at a rock at this scale, you can describe its components, you can describe what it's made of and its colors and its minerals, and you're like, okay, and this rock came from this boulder, and it's this part of this boulder, and these are the different things that I'm observing around. That gives me context to this sample. And then you zoom out a little bit more, and you're like, okay, well, I can see that this boulder came from, it rolled from this mountain ridge, or this high ridge feature. And then because I can see the trail that it came from, okay, now let me describe this ridge and different parts in it, and maybe other boulders that I'm seeing. And then you zoom out further of the orbit scale, and you're like, this ridge is a part of this larger crater. So all of those different steps give you different information, and so that's why observations at these different scales and these different perspectives are so important. So this zoomed out kind of far view is this full lunar disk view. It's the full lunar. On Earth, we see the full lunar disk as well, but now we're able to see it on the far side, and we're able to see it, all at the same time, which enables the astronauts to compare very quickly to different parts of the surface. And the color particularly is very compelling, because you can just be able to very quickly compare from 3 different regions. Is it in the same family? Is this actually a little bit different? Compare that to what they see in their orbital data that they have access to on their portable computers, and really just be able to tease out that nuance and information.
Yeah, we heard them make a lot of those connections today, and especially the color. We talked with Kelsey about this a little bit, just how exciting it was to hear the browns and greens and things like that. I cannot wait to see those pictures. Yeah. So one last question. We are coming up on the last lunar flyby observation block, and this is when we are going into a solar eclipse. So can you tell me what you're interested in the crew learning during that time frame?
Yeah, so the data set. So yes, there's so many things. How to pick one. So I'd say the thing that I'm most interested in seeing is some of their annotations that they're taking. So in this opportunity, it's a very dynamic type of experience, in that we don't normally see this activity. And so being able to have crew observe the solar corona, and then also annotate it in their on their portable computing device is just such a unique thing that humans can give to missions, and also particularly being able to annotate what they're observing while they're talking about it is also unique to being able to have astronauts in orbit as well, because we won't be able to have annotations on the lunar surface, because the astronauts will be in suits. They're going to be collecting samples, they're going to be deploying instruments, and so personally, I'm really excited to see some of these annotations and to see how that develops over time, because you've heard a lot of descriptions, and I think when people are describing something that's unique and different, you can interpret it differently. But if you're drawing and you're marking, particularly just going back to like the color provinces, for example, and those boundaries, you know exactly what they meant. And really, I'm just very excited about those annotations. There's been some famous annotations that the Apollo crew have made, particularly about solar coronas and the structures that have, and lofted dust that have given a lot of debate within the scientific community of they're observing this phenomenon, and now it's our job to hypothesize of like why are they observing this, like what is going on. So I think that's just a really cool part of exploration and science, and this beautiful thing that we're about to do.
Well, now you've got me excited about the annotations too. I mean, I've been excited about the pictures and the audio, but now
don't sleep on the annotations. I am very excited to see these little sketches that they're able to draw out, and we have pictures that they can just draw right on. It's like this particular thing is different than what we've seen. So I'm excited about that.
I'm excited too. Angela Garcia, thank you so much for joining us today, and have a great time tonight on Console.
Thank you, and you've been doing a great job, and it's so excited to see where we go from here.
Thank you so much. Integrity Houston, you have 3 minutes until we go into a forward link LOS. We will be back up with you in about an hour during the eclipse on Madrid.
Thanks for the heads up. Look forward to seeing you on the other side.
Likewise.
We're live in Artemis Mission Control at Johnson Space Center in Houston, Texas. This a live view from the Orion spacecraft with our Artemis II crew inside. That's Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen. We are still live for our lunar flyby coverage. The crew is in a short break while the spacecraft is pivoted away from the moon. We are going to be going into a solar eclipse. This is the first time anyone has ever seen a solar eclipse from the moon. So it's going to be a unique vantage point for our crew. But ahead of heading into that solar eclipse, we need to charge the batteries on the Orion spacecraft. Therefore, we have positioned the solar arrays into the sunlight to allow time for those batteries to charge. We will get back pointed at the moon just in time for that solar eclipse. We are also in a forward link LOS. What that means is essentially we cannot send calls or commands to the crew right now from the ground. However, we clearly get all of their data and communications. The spacecraft is now 4,632 miles away from the moon, and that number will only continue to grow as the distance from Earth shrinks, now 252,523 miles away. Our closest approach to the moon today was approximately 4,067 statute miles in altitude. Our maximum distance from the Earth is suspected to be 252,756 statute miles. Both of those moments came while Orion was flying in their loss of signal time frame behind the moon. The crew also set that new record today, beating the Apollo 13 record of distance from Earth. This is an animation or a visualization that you can track anytime, day or night, by visiting nasa.gov/track-Artemis. This shows you how the spacecraft is positioned as well as their distance and velocity, now traveling 930 miles per hour. During this break in their time today, the crew is working on a couple of other tasks. Some of those include their National Geographic timeline test. National Geographic was selected through a competitive process by NASA to help tell the story of Artemis II. So you've seen the crew with some GoPros inside the cabin, taking videos and pictures, and with other cameras as well. National Geographic plans to leverage its portfolio of media assets, including magazines, social and digital content, and television programming for engagement opportunities. Throughout the flight, the crew has been timelined a little bit each day to film from a shot list provided by National Geographic, and that includes their morning routine, talking with their families, exercising, and just their overall thoughts about the mission. And I cannot wait to see that footage. Teams on the ground reporting that the spacecraft is looking good and that the power aboard is good as well, all setting us up in a proper position before eclipse. The crew is in a little break during our flyby coverage for today. They will resume their flyby momentarily in about 30 minutes once they get into their observations during that solar eclipse. Now, the moon is our nearest celestial neighbor, orbiting Earth at less than 250,000 miles on average. When our astronauts venture there for future Artemis missions, they'll target landing sites near the lunar South Pole. There, ancient rocks, minerals, and trapped water ice will not only provide resources for human explorers, but they may also contain clues to the formation and evolution of our planet and the solar system. Let's learn more about the lunar South Pole with this video featuring Dr. Kelsey Young, Artemis Science Flight Operations Lead.
We learned a lot from the Apollo samples, but we still have a lot left to learn about the moon. The Apollo missions visited only a pretty narrow swath of the moon. All the missions were concentrated near the near-side equator. Really interesting and really critical insights were unlocked with the Apollo samples, but we have so many questions still to answer about the moon and the evolution of the moon.
And liftoff of Artemis I. We rise together, back to the moon and beyond.
NASA's Artemis missions are NASA's plan to send people to the surface of the moon. We'll be sending people and roving assets and scientific equipment to, among other things, answer a lot of really compelling science questions. Scientists have a lot to learn about the moon. It's our nearest celestial neighbor here to Earth, so what the moon has experienced, we've experienced. Except here on Earth, we have things like plate tectonics, oceans, forests, people that erase the rock record. Whereas on the moon, that whole record of our planet's history, of the moon's history, is just kind of waiting there at the surface for us to explore. The South Pole, which is where Artemis missions are going to target, is specifically interesting for a couple key reasons. We think there are volatiles at the South Pole of the moon that are not present near the equator. Things like water and water ice that are trapped in the lunar regolith, which basically just means lunar soil, that can easily become untrapped from that lunar regolith, and scientists can scoop up and study for return to Earth. The lunar South Pole is a really exciting scientific target, and it also comes with some challenges for operating. For example, the lighting environment will change drastically within the course of one mission, and even over sometimes the course of one spacewalk. So preparing the crew members, preparing the hardware that we're sending to the moon, and preparing the mission control teams is really, really important. The South Pole Aitken Basin is particularly exciting. We think it's one of the oldest and largest impact basins in the solar system. And if we can get the right rock from the South Pole Aitken Basin and bring it back to our labs here on Earth, we can use that sample to constrain the entire evolution of our solar system and really understand the timing of how the moon and our planet and the entire solar system evolved.
You're looking at a live view aboard the Orion spacecraft of the Artemis II crew, working in the middle of one of their breaks, or really their only break today during this lunar flyby period. Coming up next will be that solar eclipse. Throughout the Artemis II mission, and of course throughout today, you've likely heard the crew being called with the name Integrity. The Artemis II crew members named their Orion spacecraft Integrity during a news conference, September 24th, 2025. The name Integrity embodies the foundation of trust, respect, candor, and humility across the crew, and the many engineers, technicians, scientists, planners, and dreamers required for mission success. They said this name is also a nod to the extensive integrated effort from the more than 300,000 spacecraft components to the thousands of people across the world that must come together to venture to the moon and back, inspire the world, and set the course for a long-term presence at the moon. The crew also said that integrity is rooted in a shared core value of NASA, the agency's astronaut office, and the CSA, the Canadian Space Agency. We are 5 days, 1 hour, and 38 minutes mission elapsed time into Artemis II. In this view on the screen, you can see the crew starting to even look through some photos that they may have captured today. We really look forward to sharing these photos with you as soon as we possibly can. And the best way to keep up with those is to follow NASA on social media. You can do so at NASA, and for this mission specifically, at NASA Artemis. Again, we are in a forward link LOS, or forward link loss of signal with the crew, meaning that we're not able to communicate or send any commands to them right now as they were. This is a tracked event that occurs at times, but they could still provide communications down here to us, and we are obviously still receiving their video and their data.
Houston integrity in the blind. High priority PAO activities on Reid's timeline are on PCD1 in a folder imagery for downlink, and then high priority standby imagery for downlink, and then lunar flyby for PAO, and then high priority PAO. Thank you.
This is Artemis Mission Control. You heard Reid Wiseman, commander of the Artemis II mission aboard Orion, make a call in the blind. This means he knows we cannot call back and that he knows we may not receive his call. However, we have good communications with the spacecraft. They just cannot hear from us right now due to a forward link loss of signal. Again, we were tracking that this would occur, and we will regain that momentarily. But that call that came down from Wiseman mentioned some imagery, so we are very much looking forward to getting pictures taken from the moon today. Again, to see those images, make sure you follow NASA on our social media at NASA and at NASA Artemis. The view on your screen right now is an animation. This is called Arrow, or Artemis Real-Time Orbit website. You can visit this for yourself at nasa.gov/trackartemis, and you can watch as we continue to grow closer to Earth and farther away from the moon. It's all seemed to happen so fast so far, and we're coming up on splashdown now in 3 days, 23 hours and 31 minutes. This is Artemis Mission Control. We are in a forward link LOS with the spacecraft. We're not able to send commands or communications to them right now. However, they could send them to us, and we do get spacecraft data. This is tracked as we are on the Deep Space Network. This is the network that we use to communicate with the spacecraft now that we are so far from Earth, over 252,000 miles. We are still in our lunar flyby coverage. The crew still have a very important and very exciting flyby milestone coming up when they will see a solar eclipse from the moon, the first humans to ever do so. Something that we also have to consider when it comes to our missions and launches is space weather. So since the Apollo 16 and 17 missions, there were some solar eruptions near that time frame that could have been dangerous to our explorers. Over those 50 years since those storms, the data, technology, and resources available to NASA have improved, enabling advancements towards space weather forecasts and astronaut protection, which is key to NASA's Artemis program to return astronauts to the moon.
Across our planet, billions of people depend on the invisible networks that connect us to space. Every day, those networks are at the mercy of our temperamental sun and the space weather that it unleashes across our solar system. That's why NASA's space weather program tracks solar storms from the moment they erupt, modeling their paths, anticipating their impacts, and leading the research that the world's industries rely on. NASA's space weather research and modeling is driven by the needs of society and enables critical decision-making that equips pilots to reroute around high radiation areas, farmers to adjust GPS-based precision planting and harvesting plans, and power grid operators to mitigate the impacts of potential surges. For those exploring other worlds, NASA provides 24/7 space weather monitoring for Artemis crews at the moon and future Mars astronauts who may be exposed to dangerous levels of radiation during solar storms. Whether you're a pilot or a passenger, a farmer or a consumer, a power grid operator or energy customer, a satellite controller or GPS user, space weather impacts us all.
This is a live view from the Orion spacecraft on the Artemis II mission. It's now been 5 days, 1 hour, and 54 minutes since we launched. We are still in our flyby coverage, and the crew is on a short break right now as we have changed the attitude of the spacecraft to help charge the batteries aboard. We use the solar arrays to gather energy from the sun and store it in the batteries. That way, when we are not in the sunlight, we have those batteries to continue powering Orion. Now we're doing so because the Artemis astronauts are about to experience a solar eclipse from their capsule. And this is a solar eclipse that no one else on Earth will experience. This eclipse is about 54 minutes, and to the astronauts it'll look a lot like a total solar eclipse on Earth, except the moon is going to be huge compared to the sun, unlike when you watch one on Earth and the moon and the sun appear about the same size in the sky. We're interested to learn if they see the outer corona when the sun is fully obscured by the moon. And because of how big the moon will be from their perspective, the total phase of the eclipse will last nearly an hour. The astronauts will see a partial solar eclipse as the moon covers and uncovers the sun, which is before and after totality. So, much like us on Earth, they will have eclipse glasses so they can safely view that portion. The astronauts will also be using cameras to capture images of the corona during the eclipse. There also may be some other planets visible during the eclipse, including Venus, Saturn, Mars, and Mercury. If they can identify what part of the sky they're looking at, this can help train future Artemis astronauts on what part of the sky they're seeing. This provides useful knowledge in challenging situations when they may need to rely on that information instead of instruments for navigation and orientation. Confirmation from teams here in the ground that we have reached the eclipse attitude, meaning Orion is in the proper position to observe it. The astronauts' break during this observation period is now over, and we are resuming their lunar flyby observations. The first of these is sunset. This is the solar corona that we'll be looking for. It's the outer atmosphere of the sun. The science team is also interested in if the astronauts can see polar plumes. These are thin streamers that project from the sun's north and south poles. Additionally, they're interested in seeing if the crew can witness coronal loops. These are arcs close to the sun's surface. And something else that we've previously mentioned is lunar dust. This is dust from the moon that is lofted above the lunar surface and illuminated by the sun. It was reported visible by Apollo astronauts. You're getting a live look from Orion as the crew observes a solar eclipse from the moon. Again, this solar eclipse is only visible to the crew on the spacecraft. It's not visible to anybody on Earth. The science team is interested in several different targets for them during this time frame. And we're personally looking forward to getting those images as well. Again, during the beginning portion of this eclipse, the astronauts will need to use eclipse glasses, just like we do from Earth, to safely view it. Once the moon has completely covered the sun, they'll be able to take off those glasses for almost an hour. Totality on Earth during a solar eclipse lasts only a couple of minutes. So this opportunity gives them a chance to look out into deep space and to look into see if there are other planets nearby. What you're seeing right now is the solar corona. That's the outer atmosphere of the sun. And the science team is very interested in any images that the crew can capture of this. They're hoping that they'll take pictures and describe the visibility, color, and shape of the solar corona as a whole and its substructures, those plumes and streamers.
Science integrity in the blind. This is continues to be unreal. The sun has gone behind the moon, and the corona is still visible, and it's bright, and it creates a halo almost around the entire moon. But when you get to the Earth side, the Earth shine is already shown. I mean, almost seconds after the sun set behind the moon. You could see Earth shine. The Earth is so bright out there, and the moon is just hanging in front of us. This black orb out in front of us, in front of now, not the blackness, but the gray that blends and drifts into the blackness. We can see stars and the planets behind it. And Christina is in window 1, Reid is in window 2 with the long lens, and Jeremy is describing it in window 3, and it is quite an impressive sight. You can still see the horizon lit up brighter where the sun set on that side of the moon. It is bright, and Earthshine is very distinct, and it creates quite an impressive visual illusion. Wow, it's amazing.
Again, you're looking at a live view from the Orion spacecraft on the Artemis II mission. Orion is now 252,125 miles away from us all on Earth. We're here in the Artemis mission control room in Houston, Texas, and what you had just before we lost that view quickly was the corona of the sun peeking around the moon as the astronauts are entering a solar eclipse for this portion of the lunar flyby. We're now over 5,500 statute miles from the moon. That closest approach today was just about 4,067 statute miles away. And teams in the room beginning to get a little busier and filter in and out as we are stepping through a handover. The Orbit 1 team is handing over to Orbit 2, who will continue monitoring lunar flyby and all of the systems aboard the Orion spacecraft. You're getting your last few views of the solar corona as the moon begins to take center stage and completely cover the sun. If you see that bright dot up near the top left of your screen, we think right now that that may be a part of the spacecraft, but we'll be sure to correct that if we end up figuring out later that it is something else entirely. It has been an absolute honor to join you here today for the lunar flyby of Artemis II, the first time humans have flown by the moon in over 50 years. I'm Leah Cheshire Mustachio, and I'm excited now to hand over the
game is shifting around in the windows, and we are transferring settings on a camera to pick up Earth shine, and it is amazing. The brightness where the corona, where the sunset is still bright. I think there may still be corona visible, but that part of the horizon is still lit brighter, and you still have a distinct Earth shine.
You know our rules that we don't talk when the crew is talking, so wanted to give Victor Glover a moment there to call down what he was seeing now that the moon is covering the sun. A really amazing time during today's lunar flyby. Again, thank you so much for letting us help tell this story today. I am Leah Cheshire Mustachio, handing it over to my friend Anna Schneider at the PAO console as the Orbit 2 team comes to join us. So thank you so much, and I hope you all enjoy tonight. Anna, you can take it away.
Thank you so much, Leah, and it's been a joy listening to your coverage over the last several hours. So as you mentioned, the Orbit 2 team of flight controllers is currently making their way on console and completing a shift handover with the Orbit 1 team of flight controllers. The Orbit 2 team tonight will be led by Flight Director Diane Daly, and she is currently handing over with the Orbit 1 flight director there on your screen, who was Flight Director Jeff Radigan. The Artemis II crew currently on board the Orion spacecraft. It continues to observe the eclipse that they are witnessing. There's about 43 minutes remaining in that eclipse period. This is Artemis Mission Control. You are currently seeing a live view of the solar array wing cameras on the Orion spacecraft. We spoke with our science team, and they did determine that that dot in the distance is Venus.
let's see, not a huge change in here, just an update. The camera settings for Earthshine are challenging. This one's challenging to capture. What we're seeing, we're just not picking up on the cameras. And after all of the amazing sights that we saw earlier, we just went sci-fi. This has, it just looks unreal. You can see the surface of the moon between, I guess, the Earthshine. I guess Earthshine. You can actually see a majority of the moon. It is the strangest looking thing that you can see so much on the surface.
This is Artemis Mission Control. You were just hearing some communications called down from NASA astronaut Victor Glover, currently on board the Orion spacecraft. They are currently observing an eclipse. There's about 39 minutes remaining in that eclipse period. Currently, we are in a forward link LOS, or loss of signal, so the crew can communicate down with...
He's seen 2 meteors, science.
So we are in a forward link loss of signal. We do expect to regain signal in about 3 minutes, and at that point then the ground can communicate back up to the crew on board the Orion spacecraft. In the meantime, the crew can continue to communicate down to the ground. The ground is just unable to respond, so they are continuing to provide some science observations during this eclipse period. They've made some comments about Earthshine, which is the sunlight reflected from Earth when they come around towards the moon's near side late in this flyby window.
science integrity in the blind. The glow around the moon is beginning to become a little bit more even. It's not so much distinct just where the sun set on the moon's horizon as we're flying through this trajectory, and then the sun's going to come up out of the other side. I think it's we're starting to see the glow around the moon get balanced out. I still see Earthshine, and the Earth is very bright out there. Still quite an unreal sight.
Integrity Houston, we have that sit rep loud and clear, and we are back with you. How do you hear me?
Hey Jenny, we have you loud and clear, thanks.
Copy. Victor, we're handing you over to science for some critical questions. Thanks for your report.
Integrity Science, we were loving your science sit reps in the blind, and it should come as no surprise that we have a number of follow-up questions. First, you mentioned Reid observing meteors. Can you speak to that? Were you referring to comets or impact flashes or something else?
Yeah, there was a little bit of giddiness. We have seen 3 impact flashes so far. I saw 2, and Jeremy has seen 1. Undoubtedly, Jeremy saw 2, so that's 4 total. Undoubtedly, quick impact flashes. It was not sun glint off of particulate from the thrusters or the purge tanks. It was definitely impact flashes on the moon. And Jeremy just saw another one. Go ahead with your next question.
Amazing news. I literally just looked over at the SIR and they were jumping up and down literally. If you could describe where on the moon you saw them, please.
So they've all been either on or a bit south of the equator and on the Earth side of the moon. Stand by. All right, so Jeremy has seen them kind of on and south of the equator, kind of spread across the moon, and mine were both south of the equator and just a little bit left of center of the moon.
Incredible news, Reid, and reminder, we have citizen scientists here on Earth looking for impact flashes, so hearing you saw them on the near side means that people saw them too.
This is Artemis Mission Control. We have regained that signal, so the team here in Mission Control was able to call back up to the crew on board the Orion spacecraft as they continue their lunar flyby. Specifically, they are now in that eclipse period. So the science team here in Mission Control was able to ask some questions about some of the situational reports they were providing during that loss of signal. Specifically, they were interested in some of the meteors that they mentioned seeing and those impact flashes, and they did provide confirmation that they did see at least 4 impact flashes during that lost signal.
Are you still with us, Houston, or do we lose you?
Integrity, I hear you loud and clear. How do you hear me?
Okay, we got you loud and clear. One of the other things I wanted to describe, which was surprising to me, but the entire moon is lit up. It's glowing behind the entire moon. I thought it would look, dark against the black sky or deep space, but the sun is lighting up the entire limb of the moon. You can see the entire perimeter of it, and even now with the sun far behind the moon, you can still make out little bits of topography around the entire limb, just bumps as you go around it. And there's about the glow around the moon, once your eyes adjust, is easily 10 widths or diameters of the sun around the entire moon.
Incredible to hear, Jeremy. Were you able to actually pick out any discrete features on the lunar surface? And if so, how do they look different than when you observe them in solar illumination?
No, we really haven't been able to identify features on the lunar surface yet. We just see, the topography on the limb. For the Earth glow, we're about a quarter moon, waxing quarter moon, if you will, from the Earth glow perspective, and it's just at a very, just the sight angle. I'm just not able to tell what I'm looking at yet in the Earth glow.
Understood. Thanks, Jeremy. One other question for you on the solar corona. Were you actually able to see any structure or color in the corona before most of it disappeared behind the moon?
Yeah, I didn't pick out any color, but definitely structure. There were streamers, and they were not uniform at all. For me, the 5 o'clock position, there was just this constant streamer. It would change in intensity and diameter, but it was always there, and it was always at the 5 o'clock position. I only saw one plume, and it came out of basically the 3 o'clock position of the sun. That was very short-lived when I could see the plume.
Exactly what we were looking for. Thanks, Jeremy. And a heads up that we, calculated here on the ground about how long you could see the corona for, and we expect it to start to appear again in the next 11 minutes. Thanks for those amazing descriptions.
Okay, we're excited to see it all again.
Integrity Houston, we're following along as well. That was outstanding. If you haven't already, just reminding you to swap positions at the windows. And that brief LOS we had previously was due to a data rate change expected.
Okay, we copy that, Jenny.
Integrity Science, one more request for you. While it's still fresh in your mind, any annotations or sketches you want to make of what you're seeing either around the corona structures you just mentioned or even on Earthshine would be so appreciated.
Okay, Kelsey, it's going to be pretty hard to go looking at a PCD right now, but we'll definitely try and annotate what we saw.
And if the annotations come in the next block where you're cleaning up your documentation, that sounds like a good plan to me.
This is Artemis Mission Control. On the bottom right corner of your screen, you can see a view of the Science Officer console here in Mission Control.
And we've been hearing that communication between the science officer. The Orbit 1 science officer is Kelsey Young, and she's been asking questions to the crew, specifically CSA astronaut Jeremy Hansen, based on the observations they've been making during this eclipse period. And then in the upper left-hand corner of your screen, you can see a view of the Artemis real-time orbit website, which provides updates on the velocity and the distance from Earth and the Moon of the Orion spacecraft as it continues to make its way back to Earth. The distance from the Moon will continue to increase at this point. So right now, Orion and its crew are about 6,300 miles away from the Moon and about 251,000 miles away from the Earth.
Okay, science, we're getting set up for sunrise. The window teams are, Christina is supporting, and also Azina 9 in window 1. Jeremy's got the long lens in window 2, and the short lens in window 2. And Reid is in window 3, and he has started recordings and is set up to see Corona.
Great, sit rep Victor. That sounds like a good config, and we're showing coronal effects start to appear on your video camera. So in the next few minutes, we should start to hear your observations.
This is Artemis Mission Control. We just heard the crew call down to the team here in Houston, reporting that they have swapped out who is in the windows for the final
portion of the lunar flyby. So Christina Koch is in window 1, with Jeremy Hansen in window 2 and Reid in window 3. Reid is focusing on observing corona, which is the solar corona, which is the sun's outermost atmosphere. There is about 18 minutes remaining in the eclipse period.
Science and Houston integrity. I know this observation won't be of any scientific value, but I'm really glad we launched on April 1st, because humans probably have not evolved to see what we're seeing. It is truly hard to describe. It is amazing.
Amazing. Thank you, Victor.
And just one more logistics note, we have gone as dark as we can in the cabin. We have turned the DUs all the way as dim as they can go, so you can't see anything on the screens. Every bit of light in the cabin affects the view. You're definitely seeing the brightness go closer. It's definitely brighter on the Earthshine side, and so we're expecting to see some corona here soon.
We copy all. Excited for what you see next.
I'm not sure if we talked much about the star field, but we've got lots of stars. You've got the nice glow around the moon, but right off the well, we're upside down now, but from upside down 4 o'clock, right off the edge of the moon, looks like a planet. That line of planets, there's something a moon diameter to the left, and something right off the limb of the moon to the right, and then something orange. It looks orange to the right of that, about half the moon diameter. So. But anyway, there are definitely stars. I think some of those planets that you said we might see, we're seeing. And so in unreal view, yeah, the moon in the foreground is one of the darkest things we see out the window. And now it's deep space behind it is kind of dark blue like it looks from Earth, but we can also still see stars. It's quite a wicked view.
Victor,
Ike's doing the best job, and I'm not going to try to add on to what he's doing. It's indescribable. No matter how long we look at this, our brains are not processing this image in front of us. It is absolutely spectacular, surreal. There's no adjectives. I'm going to need to invent some new ones to describe what we are looking at out this window.
This is just absolutely beautiful and inspiring to hear. And Victor, we suspect what you're seeing is Saturn and Mars. That reddish object is likely Mars. Good opportunity to look to the future of where we're going.
Yeah, we can absolutely see the color of Mars. That's awesome. Okay, and from this vantage point, the 4 o'clock on the Earthshine side is definitely getting brighter, still no coronal structure.
Houston copies.
We aren't able to distinguish which Mare is, but we can clearly see Mare in the Earthshine.
We copy.
This is Artemis Mission Control in Houston, Texas.
We have not seen an impact flash in the last 5 minutes.
Sounds unlucky, but you had a pretty strong start, so we'll take it.
And actually, right after I said that, right at the South Pole, near the South Pole on the Terminator, Reid just saw one.
Amazing.
Integrity Science, and as you look around our solar system neighborhood, you should see Saturn setting behind the moon right now.
We do. We've been watching it track close to the horizon, and it's right tangential to the moon at this moment.
This is Artemis Mission Control in Houston, Texas. We are currently 5 days, 2 hours, and 44 minutes into the Artemis II mission, and we have about 11 minutes remaining in the eclipse at the latter half of the lunar flyby that the Artemis II crew is experiencing on board the Orion spacecraft. We've received several different call downs from the crew and questions up from the science officer here in Mission Control. One of the things that they said that they were able to see is Mars off in the distance, and then the science team also confirmed that they should be seeing Saturn setting behind the moon. They've also acknowledged seeing several different impact flashes, and these are flashes of lights from meteorites striking the surface of the moon. They've also mentioned the solar corona, which is the sun's outermost atmosphere. Here in Mission Control Houston, the Orbit 1 and Orbit 2 teams have officially completed their handover. So the Orbit 2 team is now leading here in Mission Control, and that is being led by Flight Director Diane Daly, and the Capcom here in Mission Control will be Tess Caswell. And you can see there on your screen on the right-hand side is the Flight Director console, and Diane Daly is in the far right of that screen, and Tess Caswell, the Capcom or capsule communicator, is in the far left hand of that screen.
Okay, the light is continuing to grow in intensity. At about the 4 o'clock position on the the 8 o'clock position on the Earthshine side. Saturn has set. Mars is tracking towards the moon's horizon.
Integrity Science, we copy, and we're starting to see it on the vehicle stream. Looking forward to any coronal observations you can share with us.
This is Artemis Mission Control. That view you're seeing on your screen is coming from the solar array wing cameras outside of the Orion spacecraft. And you can see the light starting to come into view as the solar eclipse period is starting to end.
Integrity, still no coronal structure at this time, just continuing to grow in intensity.
Copy, Victor, and reminder, you still should have several minutes before the eclipse classes need to go on, and we can send you up a reminder when you're getting close to take your eyes away from the D5 viewfinder, but you should be good for several more minutes.
Copy, thank you, and yes, please send up the reminder. Thank you. Okay, we all think we're starting to see something. I believe the most popular term is baby hair. As the light grows in intensity and the horizon on this side becomes very distinct. You can still see Earth shine, even though the sun's brightness is definitely growing in intensity.
Love the description, Victor. I'm sure as the next couple minutes progress, more of those structures will continue to pop out.
This is Artemis Mission Control in Houston, Texas. The Artemis II astronauts on board the Orion spacecraft are currently observing an eclipse. And to the crew on board the spacecraft, the eclipse looks much like a total solar eclipse here on Earth, except the moon is much larger compared to the sun, unlike a terrestrial solar eclipse where the moon and the sun appear the same size in the sky.
We are definitely starting to see structure. That baby hair is rapidly growing out toward the 9 o'clock and the 8 o'clock. It's almost as if it were reaching out for Venus or for the Earth. If you've ever seen the spotlight off the top of the Luxor at night in Las Vegas, this looks like what that wants to be when it grows up.
Integrity Science, glad to hear you're following your training of tell it like you see it.
So far, it's pretty symmetrical. There are 2 or 3 streamers that are growing in intensity and in magnitude, and it's slowly starting to widen, starting to spread out across the horizon. Pretty amazing view.
And Integrity Houston, Great words. Reminder for you, we are approaching the brightness level at which you should no longer be using the viewfinder on the D5.
Integrity copies, and thanks for the heads up.
This is Artemis Mission Control.
And I think we're seeing some directionality. Some of it is going in different directions because it appears to be moving and combining and recombining as it's pointing in different directions, and some of it appears to be going like down toward the south pole of the moon, but it's and then coming back together and going out towards Venus and the Earth. And depending on how I stare at it, it looks like one large structure, but then it definitely has wisps, and you can see 3 or 4 structures inside of it. It's like watching a flame. It's like looking at a flame, and stand by. And so it has some inherent movement. Now there's a very bright spot. There's a very bright spot in the center of it. There's a towering light of. There's a towering light, and then there were like 2 streamers that were going 30 degrees out from it, and now it is just extremely bright.
Houston, copies all.
Starting to get a little warm.
And we copied all. We wanted to remind you at this point on the eclipse glasses. Should be about time for those.
Houston, we copy all. We are in eclipse glasses. That was an absolutely spectacular, magnificent experience.
Thanks for the report. We sure wish we were there with you.
This is Artemis Mission Control. The eclipse period is coming to an end, and we did hear that call up that the crew now has to put on those eclipse glasses to be able to protect their eyes for this final portion of the eclipse. And these views coming to you from the solar array wing cameras on the Orion spacecraft.
Hey, Houston, if you could give me about 20 new superlatives in the mission summary for tomorrow, that'll help my vocabulary out a bit. Thank you.
We will solicit input from the team.
This is Artemis Mission Control. There on your screen you can see a live look inside of the SIR, or the Science Evaluation Room, here in Mission Control Houston, just down the hallway from the Artemis Flight Control Room.
Integrity Houston, back with you after a data rate change. Regarding the SAW-3 camera T low caution, no action for you. It just got a little cool during the eclipse.
Okay, we copy, and if you didn't copy my request for the mission summary to add about 20 new superlatives to help my vocabulary, I would appreciate it.
We copied it fantastically.
And Integrity Science, this is basically wrapping up your fly-by-day observations. I can't say enough how much science we've already learned and how much inspiration you've provided to our entire team, the lunar science community, and the entire world with what you were able to bring today. You really brought the moon closer for us today, and we cannot say thank you enough. And Science signing off, and can't wait to talk to you tomorrow morning.
To your entire team, Kelsey, to the entire NASA science team, you all really turned to when we shifted launch dates to April 1st, and you got the most incredible package together for us to go do some great science and some great, truly human experience moments here. And we were well prepared, and we appreciate all of you. And this is what we do best when we all come together and work as a team. So y'all knocked it out of the park. Thank you for giving us this opportunity.
Beautiful words, Reid. Thanks so much.
And this is Artemis Mission Control. The lunar flyby observation period is starting to come to a close following that eclipse. And there on your screen you can see a look into the Science Evaluation Room, or the SIR, which is embedded within Mission Control to provide science input. And they provided that input throughout the live flyby operations today. They also have a back room called the Science Mission Operations Room that processes data, evaluates imagery, and supports rapid analysis. And then, of course, we have the science officer on console here in the Artemis Flight Control Room, which you can see a view there on the bottom right-hand corner of your screen. The science officer throughout the flyby operations today has been Kelsey Young, who is the Artemis Science Flight Operations Lead. And then to her left is Angela Garcia, who will be the science officer taking over for Orbit 2. And for the past 7 hours or so, the crew has been going through their lunar flyby observation period. And now they will wrap up that period and complete some final tasks and begin downlinking some of the amazing imagery that they've captured throughout the day, as well as some of the observations that they've recorded. And now on your screen, you're seeing a live look from the Orion spacecraft from those solar array wing cameras. The solar eclipse period ended just a few minutes ago, and during this eclipse, towards the end of the flyby window, it lasted about an hour, and it was when the sun was hidden from view behind the opposite side of the moon from the perspective of the Orion spacecraft and its crew. And during that time, the crew saw a mostly dark moon, and they used the opportunity to analyze the solar corona, which is the sun's outermost atmosphere, while it was visible. And then once the sun was completely out of view behind the moon, the crew looked for impact flashes, which they reported seeing multiple impact flashes, and those are flashes of light from meteoroids striking the surface of the moon. They also looked for dust lofting above the limb or the edge of the moon, along with some deep space targets, including planets, and they noticed Mars off to the distance, and we also saw Venus on one of the solar array wing cameras early on in the eclipse period. The crew also looked at parts of the moon illuminated by Earthshine, which is the sunlight reflected from the Earth when they come around toward the moon's near side at the very end of that flyby window.
Integrity Houston, understand that you are still reflecting upon and consolidating your lunar observations. At your convenience, I have 2 items related to the upcoming VIP event.
Go ahead.
All right, first we wanted to let you know that the message for that upcoming event is on board for review at your convenience. That's message 3.06.04. The second item is that we've seen a couple of video blips in previous events. So during the HDPAO setup activity, we're wondering if Jeremy could please confirm for us that the TS rate is set to 1300 when you get to step 10.
Okay, Jenny. Yeah, we're pretty sure we've been in 1300 for all the PAO events. We've been tracking that when we swap between the HHP and the D5.
We copy, Jeremy. Thanks. And for the record, the phenomenal Jenny has gone on to her next appointment of the day, and you've now got Tess with you.
I'm sorry, Tess. Great to have you on board Integrity.
No worries. Happy to be here.
This is Artemis Mission Control. We heard some communication there between the Capcom or capsule communicator here in Mission Control, which for Orbit 2 is Tess Caswell, and the CSA or Canadian Space Agency astronaut on board the Orion spacecraft, Jeremy Hansen. They were discussing an upcoming public affairs event.
And Integrity, 3-minute warning for the maneuver back to bias tail to sun.
The crew on board the Orion spacecraft recently completed their lunar observation period. It was an approximately 7-hour period of time in which they were focused on several different targets identified by the science team here on the ground that they studied and prepared for ahead of time. And then they also were referencing a lunar targeting package that was uplinked about a day ago with those final targets. Now they are completing some post-lunar flyby activities, so they're working to clean up their observations that they've made and also working to downlink some of the photos that they've taken throughout the day. The science team here on the ground will then work to get as much data as they can overnight, and then there will be a post-flyby conference tomorrow after the crew wakes up. And that's not a debrief, but a science data collection to capture their nuanced experience while they're still in the field and the experience is still fresh. And then, of course, there will also be a public affairs downlink event later in the day. Now that once the post-lunar flyby activities are complete. And then after that, the crew will go into some of their final activities for the day. They will have a private medical conference or PMC with the medical teams here on the ground. These are regular conferences that they have at the end of every day, and then there's also a flight director conference that they will have before they go into their pre-sleep period, during which they can complete hygiene activities and they will have the chance to eat their dinner and complete any other final personal activities for the day before they head into their sleep period.
we're curious if you're ready for us to start the stream a bit early and to test scene and voice.
Checking. And integrity, affirm. We are go to start the stream.
Okay, Houston, the stream has started. We checked TS rates 1300 and audio is true. So I will give you a voice check now on the mic.
We copy good settings and we've got a good view.
I sent an audio check down on the handheld mic. Did you get it?
Sorry for the delay, Jeremy. We were talking that a bit, but it was a bit broken, so please repeat for us. Integrity Houston, we like the scene. At your convenience, we'll take a 10 count with Jeremy in frame.
Okay, copy that. Give us 2 minutes and or 1 minute and we'll do that.
Copy. Great voice check and good words. We like the scene. And Integrity Houston, we are seeing a black cable going right through the middle of the scene. At your convenience, if you would please move that, PAO would appreciate it.
This is Artemis Mission Control. We're currently 5 days, 3 hours, and 21 minutes into the Artemis II mission following a liftoff from NASA's Kennedy Space Center in Florida on Wednesday, April 1st. The crew on board the Orion spacecraft is currently wrapping up their lunar flyby cleanup activities. They're making final...
Houston Integrity, high priority PAO images from the eclipse are on PCD1 in a so-named folder.
We copy, Christina. Thanks.
And NASA astronaut Christina Koch there calling down to the ground regarding some public affairs imagery that was captured during the lunar flyby activities. She referenced a PCD, that is in reference to their portable computing devices, which are basically tablets that they're able to transfer files and also follow along on processes and procedures and their timelines for the day.
No.
This is Artemis Mission Control in Houston, Texas. Currently on console here in Mission Control is the Orbit 2 team of flight controllers being led by Flight Director Diane Daly and the Capcom or capsule communicator, who serves as the single voice link up to the crew, is Tess Caswell. The crew on board the Orion spacecraft recently wrapped up their lunar flyby observation period, and now they are completing some cleanup activities and transferring some data and files down to the ground following that lunar flyby. Many of these files will be analyzed by the science team overnight in advance of a post-lunar flyby conference tomorrow once the crew wakes up. The crew is also preparing for an upcoming public affairs downlink event. And then following that downlink, they will have a few final activities for the day, including a private medical conference with their team here on the ground. These are standard conferences that happen at the end of every day, and they'll also have a private conference with the flight director here in Mission Control to go over the vehicle status and any other questions or concerns they may have for the remainder of their flight. We are currently in flight day 6, and we have a splashdown expected on Friday, April 10th. That splashdown expected in about 3 days, 21 hours, and 49 minutes from now. During the lunar flyby, and as part of Artemis II, it marked the first time in more than 50 years that humans were able to observe the moon directly, and provided a critical opportunity to practice how lunar science will be conducted during future Artemis missions. The moon preserves a near-continuous record of solar system history that has been erased on Earth, and with no atmosphere, weather, or plate tectonics, the lunar surface retains evidence of ancient impacts, volcanism, and solar activity that scientists can study today. Studying the moon helps scientists understand how planets formed and evolved, how the moon influenced Earth's history, and how the early sun shaped conditions across the inner solar system. The moon also serves as a unique platform for studying the broader universe. The science on Artemis is designed around questions best answered by humans working alongside robotic systems, combining decades of robotic lunar data with real-time human judgment, context, and adaptability. Currently on your screen, you're seeing a look at the Artemis real-time orbit website. You can access this website at any time throughout the mission at nasa.gov/trackartemis. It provides updates on the velocity as well as the distance from Earth and the distance from the moon of the Orion spacecraft and its crew. The crew currently on board the Orion spacecraft includes NASA astronaut Reid Wiseman, who is the commander for the mission, NASA astronaut Victor Glover, who is the pilot, alongside the 2 mission specialists, who are Christina Koch and Jeremy Hansen of the Canadian Space Agency. Currently, the Orion spacecraft is about 250,000 miles away from the Earth, and that distance now will continue to close down ahead of that splashdown on April 10th. And they are now about 8,100 miles away from the moon, and that distance will continue to increase as they are now in the return leg of their journey.
integrity for ARS.
Go ahead, integrity.
Hey, Tess, great to talk to you. Any chance we could drop the fan speed down for this PAO event?
We will put that in work. Great to be talking to you, too.
This is Artemis Mission Control in Houston, Texas. We're currently 5 days, 3 hours, and 37 minutes into the Artemis II mission. The crew on board the Orion spacecraft has recently concluded their lunar observation period during the lunar flyby. As part of that lunar flyby, the Orion spacecraft and its crew made the closest approach to the moon at a distance of 4,067 miles away from the surface at approximately 6 p.m. Central Time, 7 p.m. Eastern Time. Now, although the Artemis II mission is a new opportunity to study the moon, teams are also conducting other scientific experiments, including on the crew themselves. Here's a little bit more about the science of the mission.
Artemis II is our return of humans to the moon, flying around the moon on board Orion. But along with that, we're doing a lot of great science.
One of the exciting things about the Artemis missions to the moon is that science is actually a fundamental pillar of why we explore, why we're going, what we're doing in Artemis.
I think it's incredibly exciting that not only are we testing the vehicle, but we're testing science on board. Science where the astronauts are conducting experiments, science riding along with the astronauts. We have astronauts looking outside the window and really observing the lunar surface.
It will help us understand the deep space environment. It will help us understand how that environment affects our astronauts, our systems, and life in general.
So deep space is a challenge for us because you have to leave Earth's protective magnetic field. Here in low Earth orbit, the crew members are protected from some of the harmful radiation. Going to the moon, they'll no longer be protected, so they'll have a higher radiation exposure.
Much like Artemis I, we have so many radiation sensors and detectors that are inside the capsule so that we can fully understand and appreciate the radiation environment for protecting our astronauts. In my hand here, I'm holding a tissue chip model. This is the exact design that it's going to be flying alongside the astronauts. We'll be collecting samples from each of the crew members, and we can make these organ chips out of the astronauts themselves. So every crew member will have their own avatar on board, and then upon return we can evaluate that deep space radiation environment and what that compares to the astronaut themselves. Not only are they going to help change the course of medicine for the astronauts, but revolutionizing that on Earth as well.
We're looking at sleep, we're looking at team dynamics, we're looking at how you interact with the environment. We're also looking at the immune system, so what are the biomarkers? We're using saliva as a method to study hormones and different things in your body that may change during a mission like this. And then finally, how do we function after microgravity, being close to the moon, then returning to Earth?
Which will ultimately help us achieve our goal of getting humans to Mars.
And then on top of that, we have an opportunity to look at the moon from deep space on the far side for the first time in over 50 years.
having human eyeballs and brains back around the moon is going to unlock a new generation of lunar science discovery. The human eyeball is capable of taking in so much data in just a split second. They'll be able to tackle impact history, volcanic history. They'll be able to look at how the albedo, or kind of the shade and hue of the moon and the color of the moon, can tell us something about how that terrain evolved over time. We're integrating science in ways that have never been integrated into human exploration before. We have a front room mission control flight controller position called the science officer. We have a brand new science back room where it's basically our brain trust of lunar scientists and geologists supporting the crews of the future. And Artemis II will allow us to really test how this works so that future missions are really set up for success.
We'll also be deploying some CubeSats. They're small shoebox-sized spacecraft of their own. They're each provided by another country, one of our partners. As they conduct their research, they'll complement what we are doing at the moon with Orion.
It is so incredibly exciting to be a part of this mission.
It has been, really one of the privileges of a lifetime.
I can see the work I'm doing benefit crew members right now and benefit the crew members in the future. So it's incredibly exciting and it's very rewarding.
As this rocket launches humanity off of the Earth, we'll be setting the stage through our science to prepare humanity to leave Earth and explore the solar system.
And as part of that, we are going to inhibit cabin leak detection. The edge key manual response is still available. Copy, thumbs up.
This is Artemis Mission Control. Again, we're hearing some communication between the ground here and the Artemis Flight Control Room in Houston, Texas, specifically the Capcom or Capsule Communicator, who for Orbit 2 is Tess Caswell, and the crew on board the Orion spacecraft, that spacecraft named Integrity by its crew. They are preparing for an upcoming public affairs event, so they are discussing the camera views, which we will see here shortly. There on your screen on the left-hand side, you can see the Artemis Real-Time Orbit website, or ARO. The Artemis Real-Time Orbit website there on the left-hand side of your screen provides updates on the velocity of the Orion spacecraft during its journey around the moon. Following a lunar flyby earlier today, which concluded about an hour ago, the crew has been conducting some cleanup tasks, so they've been transferring some of their documentation, their photos and data that they captured during the flyby to the ground to be evaluated by the science team, and of course some of that imagery will also be evaluated by the public affairs team here at NASA and then shared with the world once it's available. The crew will also have a post-lunar flyby conference with the science team tomorrow following their sleep period to go over some of their observations while it's still fresh and at the top of their mind. On the bottom right-hand corner of your screen, you can see a look into the Artemis Flight Control Room here in Mission Control Houston, specifically the Flight Director Console and the Capcom or Capsule Communicator Console. The flight director currently on console for Orbit 2 is Diane Daly, and throughout the Artemis II mission, there are 3 shifts or orbits of flight controllers who provide 24/7 coverage and support to the Artemis II crew and the Orion spacecraft and its systems during its journey around the moon. We are expecting a splashdown on Friday, April 10th. That splashdown will take place in about 3 days, 21 hours, and 33 minutes. During the lunar flyby that took place earlier today, Orion, again that spacecraft named Integrity by its crew, passed approximately 4,000 to 6,000 miles from the moon and provided the crew with a full disk view of the lunar surface. And from that higher vantage point, much farther than Apollo's lunar orbits on average, the astronauts were able to observe both poles and large-scale geological features in a single view. And there on your screen, you're currently seeing a live look inside the cabin of the Orion spacecraft.
Integrity Houston, we are 3 minutes out from an on-time start, and we have adjusted the fan speed. We'll take a thumbs up if you're happy with it. Copy, thumbs up. Superlative thumbs up.
And there on your screen, you can see all of the Artemis II crew members. CSA astronaut Jeremy Hansen just floated out of view behind the camera, but you can still see NASA astronaut Reid Wiseman, NASA astronaut Christina Koch, and NASA astronaut Victor Glover as they prepare for an upcoming Public Affairs Downlink event, which is scheduled to take place in just a couple minutes from now. And there, floating back onto the screen, is CSA or Canadian Space Agency astronaut Jeremy Hansen. He is making himself comfy on some of the OX or Orion Crew Survival System suits that have been stowed for the outbound and now return journey. Shortly after the completion of these couple of public affairs downlink events, the crew will begin winding down for their day, and they will have the opportunity to eat dinner. Some of the items on their menu today for dinner include chicken with corn and black beans, sweet and sour pork, rice pilaf, spicy green beans, citrus fruit salad, and maple cream cookies. All of the And now we will go ahead and stand by for that public affairs event beginning in just about a minute.
Integrity Houston, no action for the DU-1 caution. We're taking a look. Integrity, this is Houston. Are you ready for the event?
Hello, Houston. Integrity is ready for the event.
Administrator Isaacman, this is Mission Control Houston. Please call Integrity for a voice check.
Integrity, Jared Isaacman, comm check.
Administrator Isaacman, we've got you loud and clear, sir. How us?
I've got you loud and clear. Artemis II crew, we have a very special guest who wanted to be the first person to greet you after your return from the far side of the moon. Reid, Victor, Christina, and Jeremy, it's my honor to introduce the President of the United States of America, President Donald J. Trump. Over to you, sir.
Well, thank you very much, Jared, and you are doing a fantastic job. And hello, very special hello to Artemis II. Today you've made history and made all America really proud, incredibly proud. We have a lot of things to be proud of lately, but this is there's nothing like what you're doing, circling around the moon for the first time in more than a half a century. and breaking the all-time record for the farthest distance from planet Earth. Humans have really never seen anything quite like what you're doing in a manned spacecraft. It's really special. I want to personally salute and congratulate Commander Reid Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Jeremy Hansen. And I also want to thank the entire amazing team at NASA, headed by Jared, who's a very special guy, by the way, and you all made this day possible, and you've really inspired the entire world. Really, everybody's watching. They find it incredible. I just watched you go to the back of the moon, and people haven't been there in a long time, we can say, but it's going to be more and more prevalent because we're going to be doing a lot of traveling, and then you're going to ultimately do the whole big trip to Mars, and that's going to be very exciting. So you look at, we had no astronaut has been to the moon since the days of Apollo program. The Apollo program was also very special, but that was 50 years ago, and at long last, America is back, and America is back in many ways stronger than ever before. We're the hottest country anywhere in the world. The Artemis crew flew in the most powerful rocket NASA has ever made, ever launched, traveled over 250,000 miles, broke the distance record set by the legendary Apollo 13. And America is a frontier nation, and the 4 brave astronauts of Artemis II are a modern day, you really are modern day pioneers, all of you. And one of them happens to be a neighbor. You know who that is, right? You have a special person over there, a neighbor, and we like our neighbor. Your mission paves the way for America's return to the lunar surface very soon. We're going all out. We're doing everything we can, and it's headed up by Jared. We'll plant our flag once again, and this time we won't just leave footprints. We'll establish a permanent presence on the moon, and we'll push on to Mars. That'll be very exciting. I'm waiting for that so much. I'd love to be here, but maybe we won't quite make it in terms of timing, but we will be up in the moon, and that's going to happen soon. So America will be second to none in space and everything else that we're doing, and we will continue to lead the whole thing into the stars, this incredible journey into the stars. So I just wanted, it's an honor to speak to you, and I wanted to congratulate each and every one of you. And tell me, what is the most unforgettable part of this really historic day? The whole world is watching and listening. Please tell me.
President, this call is certainly special to all of us, and we really have a lot of faith in our administrator, Jared Isaacman, who is with you. We appreciate his leadership in NASA and in the international community. We are doing great things, and we are proud to be a part of. I have to tell you, as we came around the near side of the moon, seeing all the sights that we've seen from Earth for all of our lives, but we're seeing them from a different perspective, and then we started to get a glimpse of the and we saw sights, oriental sights that no human has ever seen before, not even in Apollo, and that was amazing for us. And then the surprise of the day, we just came out of an eclipse where the sun, moon, and the entire dark moon about that big right out the window that we were watching. We could see the corona of the sun, and then we could see the planet train line up, and at Mars, and all of us commented how excited we are to watch this nation and this planet become a 2-planet species.
That is fantastic. You know, I had a decision to make in my first term, and the decision is, what are we going to do at NASA? Are we going to have it be revived, or are we going to close it down? And I had very little hesitation, and it's really great to have somebody like Jared involved, because he really makes it much easier for me. But it was not even a question in my own mind. We've spent what we had to do, and then of course we have Space Force, and Space Force is very much related to what you're doing, and that was my baby. That was a very important one, and it'll turn out to be truly one of the most important, I believe, decisions I've ever made. So we're very proud of Space Force, and we're very proud of all of you. Does anybody else have anything to say? A lot of people listening.
Mr. President, to be here with you speaking about our incredible day today. I think one of the biggest highlights was coming back from the far side of the moon and having the first glimpses of planet Earth again after being out of communication for about 45 minutes. It really just reminds you what a special place we have and how important it is for our nation to lead and not follow in exploring deep space.
I'd like to ask, what was your feeling when you had no communication, zero communication, all of a sudden it was cut off by, obviously, your very special location. What was your feeling when you had no communication? A little bit different, perhaps?
Yes, Mr. President, it was I said a little prayer, but then I had to keep rolling. I was actually recording scientific observations of the far side of the moon. You know, that is actually the time when we were the farthest and the closest to the moon. And so we were really able to make some of our most detailed observations of the far side of the moon up close. And so we were busy up here working really hard. And I must say, it was actually quite nice.
Did you see a difference, a big difference, between the far side of the moon and the near side of the moon? Was there a difference in feel or difference in look? What did you see?
Well, Mr. President, we certainly did, and our science team really set us up well to understand what they thought we might see. And the gravitational pull of the Earth has had a profound effect on the near side of the moon, changing all those dark mares, those dark patches of the moon you see from Earth. It's very different on the far side. While you see some small patches of those mare in deep craters, it's very much absent on that side, so that's really neat. And while I have the microphone, sir, I just want to thank you on behalf of Canada. The space leadership you spoke of from America truly is extraordinary. I've said this many times before. A nation that leads like that and creates and sets big goals for humanity that brings other countries along with it is truly incredible. And I know that's a very intentional, not a necessary decision, intentional decision to lead by example and to allow other countries like Canada to share our gifts and help you achieve these mutually beneficial goals, like establishing a presence on the moon and eventually going to Mars. And Canadians are so proud to be a part of this program.
Well, I have to say I spoke to a very special person, Wayne Gretzky, who I think you know, the great one. And I spoke to your Prime Minister and many other friends I have in Canada. They are so proud of you. And you have a lot of courage. I'm not sure if they'd want to do that. I'm not even sure if the great one would want to do that, to be honest with you. But you have a lot of courage doing what you're doing, a lot of bravery and a lot of genius. But they're very, very proud of you.
Administrator Alex, I'm going to just get a quick comm check, make sure you guys are still on the line and we didn't have a handover.
I am. Yes, I am.
And integrity, and back over to you, Mr. President.
Yeah, I think we might have gotten cut off. It is a long distance. It's a long ways. The reception's been great. There's a little bit of about a 9-second delay, but no, I just had a statement for, I don't know what you heard, but I was just saying they're very proud of your brilliant person from Canada on the ship. And Wayne Gretzky is a great friend of mine, and he's very proud of him. And the Prime Minister I spoke to, they're very, very honored that you have a courageous person from Canada. You have a lot of courageous people from Canada, so it was very nice. I'm not sure if you heard me say that, but it was very nice.
Yes, Mr. President, we heard that, and we do love our Jeremy Hansen. We love all our Canadian astronauts, Jenny Gibbons, Josh Kutrick. They're just great people, and they're such a welcome addition to our Corps.
Great. Well, I really look forward to, when we can, I look forward to seeing you in the Oval Office. I'll ask Jared to bring you over, and I'll ask for your autograph, because I don't really ask for autographs much, but you deserve that. You really are something. Everybody's talking about this. And I look forward to having you in the Oval Office at the White House, and we will celebrate your incredible achievements and triumphs. This is big. This is really big stuff. The whole world is talking about it. And if you have the time, I will certainly find the time. I've been pretty busy also, as you know, but I will absolutely find the time, and we'll get together, and I'm going to be giving you a big salute on behalf of the American people and beyond that.
Thank you for that, Mr. President. And when you want us, we will be there. And thank you for your leadership. Thank you to Jared for his leadership. Really, thank you for taking the time out today to visit NASA. It's really special for us, but it's really special for the team on the ground. A whole team of people all around the world pulled this off, and we just want to say thank you to all of you for this. It is the thrill and honor of a lifetime to have been on this journey. Today was amazing, but this 3-year journey has been amazing, and it was made possible by the American people and the Canadian people, and we're so grateful to you all. Thank you very much.
Well, thank you very much. And Jared, congratulations. We'll see you soon. And I know that you have Mars very much in your mind, so we'll start thinking about that pretty soon, I think. And thank you. Congratulations to everybody. I'll see you at the Oval Office.
Thank you for your time, Mr. President. It's been an honor.
Thank you very much. Bye.
Bye.
Integrity. This is Houston ACR. That concludes the event. Thank you.
Thank you to all participants. Integrity, we are now resuming operational audio communications. Integrity Houston, great job on the event. Just a heads up, we are on track to start the next event on time at 4:15.
Okay, sounds great. We'll be ready.
This is Artemis Mission Control in Houston, Texas. We just had that public affairs event with President Donald Trump and the crew on board the Orion spacecraft. And coming up in about 10 minutes, there will be another public affairs event. That event taking place at a mission elapsed time of 5 days, 4 hours, and 15 minutes. Currently on your screen, you're seeing a look at the Artemis real-time orbit website, which provides updates on the velocity as well as the distance of the Orion spacecraft from both Earth and the Moon. The Orion spacecraft and its crew, that crew including Reid, Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, are currently about 250,000 miles away from the Earth, and that distance is starting to become smaller as they are now on the return leg of their journey. And they are about 9,300 miles away from the Moon. They made their close approach to the Moon.
Integrity Houston with a question about fan speed.
Go ahead.
Hey, Reid, we were wondering if this adjusted fan speed is something that you would like to keep going forward, or if it was just a specific change request for the events this evening.
Certainly for PAO events, this is an ideal fan speed. If you're willing to give us this fan speed for routine habitability, I think we would take it and try it for a while.
And Reid, we are able to support keeping the fan speed in this config. Happy to keep it here to collect data.
Okay, you got 4 happy astronauts up here. We'll take it. Obviously, when we go to exercise, we'll need to bump it up, but I think for quiescent living, this will be great.
We copy, and we love seeing those smiles.
docking camera.
Go ahead.
Just want to make sure we have the config you're expecting. I have the dual camera bracket is installed, the window shade is closed, and the docking camera is stowed in its Alpha 3 storage area.
That's a good config.
Thank you.
And while I've got you, we are 3 minutes out from an on-time start of the next event.
This is Artemis Mission Control in Houston, Texas. You can see a live look of the Artemis II crew inside the Orion spacecraft cabin as they prepare for another public affairs downlink event. There on your screen is CSA astronaut Jeremy Hansen along with NASA astronaut Reid Wiseman and NASA astronaut Victor Glover popping up. Earlier today, the crew completed their lunar flyby observation period, during which the Orion spacecraft and its crew passed approximately 4,000 to 6,000 miles from the moon and provided the astronauts with a full disk view of the lunar surface. And from that higher vantage point, the astronauts were able to observe both poles and large-scale geological features in a single view. Towards the tail end of that observation period, they also were able to see an eclipse. And that eclipse period lasted about an hour and was when the sun was hidden from view behind the opposite side of the moon from the perspective of Orion. Since then, the crew has been working to clean up some of their observations and transfer some of the data and imagery down to the ground to begin processing, and the science team will take a look at that imagery as it comes down ahead of a post-lunar flyby conference tomorrow with the crew following their sleep period. Now we are standing by for a second public affairs event taking place in about a minute.
Integrity, this is Houston. Are you ready for the event?
Houston, Integrity is ready for the event.
Administrator Isaacman, this is Mission Control Houston. Please call Integrity for a voice check.
Integrity, Jared Isaacman, comm check.
Administrator Isaacman, we've got you loud and clear up here.
I've got you loud and clear, and let's see if we can top that last PO event. That was pretty special. So we are going to spend the next 20 minutes doing Q&A from a number of questions that have been submitted, and we are going to start with one from me. You all have spent years preparing for this moment and imagining what it must be like when you look down at the moon, at the lunar surface. What has surprised you all that you did not anticipate?
Go ahead. No.
It's on.
Administrator, great to chat with you. Just something that just shocked me because really using imagery and just the three-dimensionality of it. You know from your experience of seeing the Earth from space how it just seems different, and you look out in depth of things. And when we were on the far side of the moon looking back at Earth, it was just so obvious. You had this sphere out in front of you of the moon and this three-dimensional. You really felt like you weren't in a capsule. You'd been transported to the far side of the moon, and it really just bent your mind. It was an extraordinary human experience. I'm so grateful for it.
Integrity, Jared, anyone else want to answer that one?
You know, we had an amazing launch. The SLS is quite a powerful rocket, and got us into a 1,200 by, eventually a 100-mile orbit, and clearly power and speed, and then we did our translunar injection, and we were going quite fast. And so with all of that speed, though, it still took us days to get here. And so the scope of all of the things to a 321-foot tall rocket was amazing. It just puts the power required to do this in perspective. But then even with all that power and to get to those velocities, it still took us days. And the breadth of the distance we had to cover. Watching the distance from Earth count up and the distance from the moon count down was one of the most surprising things I've enjoyed.
Well, as I was trying to formulate an answer, at first I couldn't think of anything because there are so many things to choose from. I'll try to just narrow it down, but I'm going to go with something we did yesterday, a manual power flight test objective, where we just basically got to sit at the vehicle. It was Jeremy and I this time, and just drive around using the rotational hand controller, basically just drive it with the stick, and how well it handled, how tight the control algorithms were, and watching it respond when we actually degraded it on purpose by going into 3 degrees of freedom control, by actually inhibiting some of the jets, which even though we have jet redundancy, of course, for each other in these complicated algorithms. So it was just amazing to be in a deep spacecraft and just be flying it around by hand. The one other thing I'll say, how fast it has gone by. I'm not ready to go home. I can't believe that something this cramped of quarters can fly by and still be fun every single minute.
And I'll just close out with, I think just scale, Jared, is the thing that is just blowing my mind. You flew Polaris Dawn to some amazing apogee numbers, and on the International Space Station, we're 250 nautical miles up, and that's the most beautiful view I think a human could ever experience. And we are dealing with numbers that are 250,000 miles, and every time Mission Control points this vehicle either at the moon or at Earth, and it reminds me every day that humans have to go, we've got to explore, we got to go further to expand our knowledge, expand our horizons. And every time we take another step forward, it makes the world seem a little bit smaller and a little bit more manageable. And just putting these numbers in perspective, it is impossible as a human to look at these displays and comprehend them. But here we are, and NASA is doing this, an international team is doing this, and they're doing it very well.
Excellent words, Integrity. So certainly a very wild insertion orbit. I can imagine the contrast between perigee and apogee, the scale of it all, the 3D, seeing the moon come alive, and then certainly manual control. Well, every Dragon crew for the last 5 years is very jealous on that. Okay, so we're going to questions here. This one, the Artemis II crew, inspire all of us, but what inspires you?
I think as you get older, your answer to that question changes a lot. Certainly when I was a young boy and a young man, just seeing an airplane flying overhead, to me, that really lit a fire in me. And then I think when you reach your middle age, it is interesting to watch leadership throughout the world kind of change the course of human. You can watch that unfold. And now now that I'm just a little bit over 50, you'll be there soon. Now that I'm just a little bit over 50, I mean, it all ties back to just family, and you understand just how much the people that you surround yourself with, and that is really every night when you go to bed, that's really what you end up thinking. At least that's what I end up thinking.
Thank you. All right, so here's a question. It's a good one. So for the Artemis III crew, what is the advice you would pass along for the next astronauts that will go in Orion?
That's a great question, Jared. We've actually been thinking about the Artemis III crew since we were assigned as the Artemis II crew. It was the beginning of how we came up with how we wanted to fly this mission, how we wanted to buy down risk for the program, and values as a crew. And so, you know, over the course of these 3 years, we've taken a lot of notes. So we've almost got a book to hand them. But I think a few practical things, just sitting here, we've been living for the past 6 days, how you pack is a huge impact to how you will live on the journey. And so things like food and your hygiene products, and then, you know, you know what's going on with our waste management system, the technology that we have, practicing that and being familiar with that and being prepared mentally. I used it on the space station, I used it at home in training, but I'll be honest, I wasn't really prepared to have to use it for over half the mission, and but you know, we adapt and overcome, and so I can't wait to talk to that crew.
I'm glad you said it, or else I was. We definitely have to fix some of the plumbing. Okay, this question is from Merriam-Webster. So wordy one here. So you are going to be, well, you've already surpassed more than 250,000 miles from Earth, farther than any human has gone before. So what are some words that come to mind when you try to wrap your mind around this very unique experience?
I'll be honest with you, the main word, because superlatives just don't do it justice, is humility. We would never be here if it weren't for so many people that came before us, starting with Neil Armstrong, Katherine Johnson, Dorothy Vaughan, civil rights movement leaders, everyone who worked on this spacecraft. Before we got here in our 3 years of training, we went all over the country and even to our European and Canadian partners to see the people who have put their hands on this hardware, the millions of parts from every valve, to this entire thing, the people that put on harnesses every day to rig it up in the VAB. They all passed the record. We definitely didn't pass the record up here alone.
So this is actually very similar to the question the President of the United States asked just a brief bit ago. But during the quiet moments on your journey, when you were out of contact with everyone here on Earth, what were some of the thoughts that tended to occupy your mind most?
Yeah, as Victor said earlier, when we were on the far side of the moon and out of contact with planet Earth, we all knew it, and it was a milestone. We saw Earth disappear, the Earth set. But we were so busy with the science, and we have such faith in our vehicle integrity, such faith in mission control, that we were just at complete peace and just doing our job. And just trying to do a good job to collect as much science data as we could while we were on the far side of the moon, and we were just giddy in here, like of our lives.
He's being a bit humble, but as soon as we went out of comm with planet Earth, we did have maple cookies. As we just gathered together for about 30 seconds, each one of us had a maple cream cookie, and then right back into the science. But we had to take a moment to honor that time going behind Earth, and it was going behind the moon and out of touch with Earth, and that was a very surreal moment for this crew.
copy that. Good maple cookies on the far side. And how has this journey changed? How has this journey already changed the way you see our home planet and humanity's future among the stars?
There's so many directions I think we could go with that. And I just, I think that there's, global, but I think real impact is local. And is to see the Earth as an entire thing and look at it, this system, and to see it all in once. But my daughters, and just the things that we can impact directly, the people that I can touch, that I can speak to, hug, and show love and gratitude toward, is the thing that I think is going to change and last. But you also talked about the future that we're going to have in the stars. And this mission, I think we swung for the fence and launched on our first try after learning a lot earlier this year. But I think it set the stage for us to go out and continue to swing for the fence hard in our Orion SLS and ground systems programs to go and get the next one teed up so that crew can knock it off out of the park. And so I have huge expectations for what's coming next.
Good words. Are you feeling homesick for Earth?
I will tell you, last of my eyes, I did start thinking about getting home. It's not homesickness at all, but the first time probably in 3 years, I let my mind get past the moon and back towards home, and I had to catch myself right there. You're an operator just like we are, and that is the place to be when you're up here. We got to look one step ahead. What's next? What's our next burn? How are we setting up our trajectory to get home? And we are going to do that. We are locked in, and we are definitely excited for the second half of this mission. And we are on guard. We are first crew to fly this vehicle. We are ready for any contingency in any scenario, and we are going to stay locked in every second until we are back on that Navy ship and then home reunited with our families.
And copy that. Astronauts like being in space. That checks out. Okay, there's a lot of questions from the space photography community. How are the pictures going so far?
Well, we all love getting our hands on cameras and our eyes behind the lens here, because we're just trying to share the incredible things that we're seeing, and that's obviously the best way we can try to do that. I've been into night sky photography for a long time, and so this is really a dream come true for me. I have thought specifically to that community, the time lapses I've been trying to get, those are a little tougher because we have a very dynamic vehicle. It's not like being on ISS where you can get the city lights below and the auroras and the spinning stars around the North Star. There's a lot going on. But what we got to matter is out of this world. When we viewed that eclipse, that was the one time we all said, we literally cannot capture this with a camera. Everything else, I think we've really put our hearts and minds into making sure we understand so that we can bring that home to everyone. But having to set the low light features for Earthshine on the moon while it's an eclipse, that was a new one. I had to dig deep in my book for that one.
And thanks for the iPhones. They've been working great.
Very glad to hear that. And there are a couple billion people back here on Earth that are extremely excited to look at the imagery you've captured up there. So. Okay, well, I want to thank you all. Integrity. So Reid, Victor, Christina, Jeremy, on behalf of NASA and space-loving people across the world, thank you for taking us with you to the moon. Thank you for your courage. all of your beautiful words that we've heard. You represent the absolute best of us. We are proud of you, and we look forward to welcoming you back safely to the good Earth very soon. Godspeed, and go Artemis II.
Thank you so much, Administrator. We are just proud to be a part of this team, doing our work every day, and we are supported by a huge world of humans, and we are just honored to be a part of that. Thank you.
We'll see you soon.
Integrity, this is Houston ACR. That concludes the event. Thank you.
Thank you to all participants. Integrity, we are now resuming operational audio comm.
This is Artemis Mission Control in Houston, Texas. That second public affairs event with NASA Administrator Isaacman and the crew on board the Orion spacecraft named Integrity now complete, and there on your screen you're seeing a live view from the Orion spacecraft, specifically from the camera on its solar array wings, and you can see a crescent Earth there. The crew is now officially on the return leg of their journey, and Earth is now their target, with that splashdown targeted for April 10th. This is Mission Control Houston inside the Artemis Flight Control Room as the lunar flyby coverage is coming to a close. You can see a final look there of the Orion spacecraft and that crescent moon in the distance. The Artemis II crew inside the Orion spacecraft named Integrity lifted off atop the Space Launch System rocket on Wednesday, April 1st from NASA's Kennedy Space Center in Florida. This crew is the first to live and work inside the Orion spacecraft. And about 25 hours after launch, Orion conducted its TLI, or translunar injection burn, which committed Orion to departing high Earth orbit and set us up for today's flyby. TLI also served as the spacecraft's deorbit burn as it slingshot Orion around the moon and set the crew on its free return trajectory, with that splashdown slated for Friday, April 10th. Last night, on flight day 5, the crew entered the lunar sphere of influence, the point at which the pull of the moon's gravity became stronger than the pull of Earth's gravity, and the crew will remain in this lunar sphere of influence until about 12:25 p.m. Central, 1:25 p.m. Eastern on April 7th. Today, the crew spent the majority of their day making science observations and capturing imagery as part of the lunar flyby, during which Orion and its crew passed approximately 4,000 to 6,000 miles from the moon and provided the crew with a full disk view view of the lunar surface. From that higher vantage point, the crew was able to observe both poles and large-scale geologic features in a single view, and the Artemis II crew also became the first humans to directly observe certain far-side regions of the moon with unaided eyes. During the lunar flyby, the crew also surpassed the Apollo 13 distance record and made that farthest distance from the Earth during their mission at a distance of 252,756 miles away from Earth.
Integrity Houston with 2 updates.
Houston, go ahead with the updates.
Hey, Victor, again, awesome job on both of those events. The team down here really enjoyed following along. I've got 2 sync items for you. The first is that based on ground schedules, we'd like to pull your flight director conference up before your PMC, so we'll start the flight director conference at the time the PMC is currently scheduled.
Sounds good.
And the second item is just following up on the DU-1 caution. We believe this is a recurrence of what we saw with DU-2 earlier in the mission. It's back up and it's ready for you to reconfigure displays as you wish, and I see you have that in work.
Okay, great. We would love a main and secondary dump line status, or really the main line.
Check in. And Reid, back with you on the dump lines. The main dump is open and it's proceeding very slowly, but the secondary is still configured and go for use.
Okay, sounds good. Thank you.
And this is Artemis Mission Control. Some communication there between NASA astronaut Reid Wiseman and the Capcom, or capsule communicator, here in Mission Control, discussing some of the final activities on their timeline for the day before they head into pre-sleep and get ready to close out Flight Day 6. So during the flyby period, the Artemis crew and in its Orion spacecraft reached a farthest distance from Earth at 252,756 miles, which was 4,112 miles farther than Apollo 13. And a couple minutes prior to that farthest distance milestone, Orion also made its closest approach to the moon at a distance of 4,067 miles. And at the end of the lunar flyby period, the crew was also able to see an eclipse with the sun hidden from view behind the opposite side of the moon from the perspective of Orion. And during this time, the crew saw a mostly dark moon, and the crew also used the opportunity to analyze the solar corona, which is the sun's outermost atmosphere. And once the sun was completely out of view behind the moon, the crew observed impact flashes, which are flashes of light from meteoroids striking the surface, and some deep space targets, including planets such as the Mars, Venus, and Saturn. The crew's observations during this flyby, along with handheld photography and images from the Orion spacecraft, will form the basis for scientific investigations into the moon's geologic history, the lunar environment, and current processes such as new impacts. At this point in the Artemis II mission, the crew and the teams on the ground have begun or completed 23 of the 27 high-priority objectives for the mission, providing a tremendous insight into the operation of the Orion spacecraft and critical information as we prepare for future Artemis missions. Now that the lunar flyby observation period has concluded, along with the public affairs events that followed with President Donald Trump and NASA Administrator Jared Isaacman, we are going to wrap our broadcast coverage on NASA Plus. Thank you to everyone who tuned into our coverage on NASA Plus, as well as through our streaming partners on Peacock, Netflix, Amazon Prime, and HBO Max. While our NASA Plus coverage is concluding, our 24/7 continuous coverage will continue on NASA's YouTube page, so you can continue to follow our Artemis II crew on their return journey back to Earth. This is Mission Control Houston.